Good morning, everyone. I hope you're all doing well. We are streaming. We're doing our typical long streams today. Hopefully, we get stuff done. I feel like I've been slacking a little bit. Let me bring up toggle track. I actually don't have that open. So let me just grab that so we can actually time ourselves when we're actually being productive. The classic app, completely free to use. Right, yes, we've only been we did 4 and 5 hours, recently. That's just kind of lame of programming. We need to step up our game a little bit. So, we're back doing the streams, for many hours. Now, if you're new, I will say that, when I do these, I also have to do revision, and I have to have a break for lunch, which means we end up watching a video halfway through the live stream. Just kind of for a bit of time. Let me just bring up the chat. So everything takes forever to load on my laptop because it's low on battery. I've got another. I don't have 2 monitors, but I have a second computer here that has your lovely chat messages in. So yes. We are going to do the whole gambit today. So, we are running everything down. We are going to do revision first, and then we are going to then do our programming, and we're going to be adding, I think, a particle system. Hi, Bart. How you doing? Just finished school. Glad I could be on for your entertainment. I hope you had a good day at school, man. Hopefully, I didn't get too much homework. Yeah, thanks for joining us. Yes, so speaking of homework, we're going to have to do our own homework here and do our own revision. So what I'm going to do is, I think I've got 2 things that I could do today, in the beginning of the particle system. Step 1 is, I slammed my chest hard in the slide. Right. Okay, aside from that, well, yes, hopefully you recover and it wasn't too much of an injury. Mad times being a school kid. Anyway, so we have 2 ways I could tackle this. I could just dive into billboards and get more accurate billboards right now. We have this system billboard, right? We could do a bit more work so we can get this type of billboard. But I think for the particle system, we need as little computation as possible for each thing. So I think I'm going to stick with this until I need more advanced particles like this guy here. Meaning that when we actually do the computation for rendering the particle, it's extremely simple. We have this buck as well that we're probably going to chew through. I've closed it. Silly. Let me just grab it open. GPU Zen 3, and it has a how to do a particle system in the modern era effectively. I have done particle systems in the past. Billboard, bad indeed. Bad billboard. Well, yeah, it's the most basic type. And where have I got my books? Where are my books at? GPU Zen should be around in the middle. Cool. Yeah, so I do own this book. And we need to be about, what, 1, 2, 3, a bit further down. So here we go. We have this book, which we're probably going to go through, and multi-mega particle systems by these 2 guys. So that's going to be fun to try and pass through. This is probably going to probably how I'm going to tackle this today is I am going to read through this, figure out exactly what we need to do, and then kind of build up a list of things that's the most important for our particle system. And then hopefully we should have, I believe, probably a compute shader. So we're probably going to have, for the first time, have to do memory barriers, which we haven't done in a minute. Can you tell me where it is? I'd like to read it. Yes, I've left a link in the description. Remember, this book is not for free. I do own this physically. It's quite expensive, unfortunately, because these books are. But yes, I've left links in the description for the 2 books that we're going to be using today. It's either this, or if I feel like I want to do more billboard stuff today, which is this, we'll probably end up using the Foundations of Game Engine Development. But yes, this is a GPU the GPU Zen 3 advanced rendering techniques. So this is, you know, not something you should start with effectively. If you're just kind of starting with graphics, I don't recommend this book. I'm gonna probably struggle with this as well. But yes, we're gonna try and go through this. Fortunately, the code is very nice. Everything's well written. I haven't actually read any of this, so yeah, we'll literally start from the beginning. But first things first, we need to do some revision. And yes, we're going to do a marathon, a long stream today, so hopefully we get more done. So for those who weren't here yesterday, I'll show you what I've been doing. How far we got yesterday, right? If I can actually get my engine, thank you. Actually, the Visual Studios, the newest one, 2026. Let's bring up Void. Yeah, so I'll show you what we ended up doing. Now, if you were here, you probably know, you'll probably be maybe underwhelmed. Revision indeed. Yeah, well, you don't escape it when you're adult. So we got billboards working, right? And just to show you what I mean is when let's just say we get really close to the billboard, this is like, and we start to rotate the camera, you can see the billboard is starting to behave a bit strange. Like you can see it's moving kind of strangely, like whoa, it's like moving like this. But I think this is going to be good enough because this is not going to be a true billboard. You can see it kind of being silly. So what we're going to do here is we're going to fire. The only reason that we've got these is mostly for bullets. So I don't think we're ever going to need them to, you know, look more realistic. That's why I'm thinking that we're just going to dive into the particle system. Now, you may think, well, Escape Point, you basically had this yesterday. And yes, yesterday was basically solving bug after bug after bug. I had made some mistakes throughout my engine. And that kind of all came apparent when I tried to have the main menu, which we saw earlier, which is still basic. Hi, Escape Point, early stream today indeed. Yes, we're going to be doing a bit of a long one. Thank you for joining us, Ratchet. So when I tried to add this menu back in after getting the billboard working, what ended up happening is this didn't work at all. And I was like, oh dear, everything's going wrong. So yesterday was literally just spent me debugging all day. And basically getting back to where I thought I was yesterday. But yes, we simplified the engine. We got rid of some bad design decisions in the code. And that is all now pushed up onto the internet. Hello, Mika. Thank you for joining us. Well, Mika's also good at code. But you know some code too. I wouldn't be so harsh on yourself. So yes, we are doing that. We're going to be doing revision, then potentially just studying for a while, and then potentially just you know, whatever. I was looking through the people who got fired at id Software. It's all senior lead roles, like 70% of the entire, 75% of the entire company. What? Brutal, brutal. Yes, that is really sad to hear. I think we artists, programmers, and designers. I don't know if you know who bought id. I don't know if you, because I know you're quite young. id Software in the 90s was like the best game developer, like game development company to exist, all the way up into the 2000s. They invented the FPS genre, literally. That's where, yeah, they invented. If you've ever heard of Doom, those are the guys who made it. They're known for they're very known for, and Quake indeed. They're known for innovating and becoming like making new tech and like pushing the boundaries, right? Unfortunately, things have gone south. Even despite that, they were doing really well in the early 2020s, I think, and because he had Doom 2016 and Doom Eternal, which came out a bit later, which were both like very cool, like very advanced games, you know, for that technology-wise. But yeah, I think it's a bit of a sad sight, honestly, to see it struggling like it is right now. Yes, exactly. So many modern game engines can trace their origins back to id Tech's engines, 100%. They are doing well. It's just Microsoft being horrible. I see. Okay, right. There we go. Yes, they are owned by Microsoft. Well, it's, yeah. Which we are, you know, can't exactly say I'm enjoying Microsoft right now. So, yes. Another reason for me to plug in this sacred Linux USB. Yeah, pretty much. Yeah, the more and more people that move to Linux, the more and more I will have to move to Linux as well, which I'm completely fine with. Anyway, so let's dive into this. So again, just for the people who are aware, it's going to be revision first, and then it's going to be probably studying for a couple of hours, and then it's going to be implementing for another couple of hours, with a break in the middle to watch a video because I've packed my lunch. It's ready to go. So we can keep streaming through that. Right. Okay. And my revision news from Xbox and PlayStation has been horrible this week. Yeah, it's ugh. I really don't like the industry at the best of times, and wholly it's just ugh. It's just not good. Right, so when I do revision, I'll read this out loud so you guys aren't like hearing me just silently read as I stare into this. So the first thing I'm going to do is actually split this up into its own note, because right now it is what is it called? I'll turn this down just a no, it's fine actually. The audio looks fine. Right, so let's make this so. What are billboards? So yes, we are doing Obsidian again. Breaking up this note into smaller notes, and then what I'll do is I'll read this out loud once I've connected all the information together, because this is part of the so there are two types of billboards. Yes, so this is graphics theory, and we don't really have a main note yet, but I think they're going to connect basically with, we'll see in a minute anyway. So foundations of game engine graphics. Okay, so let's look at this. By the way, I use Catchy.io, the best Arch Linux. Yeah, yeah, I've heard like fantastic things about Catchy.os. If you want to use an Arch-based one bot, that is probably what I would recommend too, because the amount of oh, that's true. Yeah, Microsoft did do this for decades with Rare. You're completely right. Yes. So yes, if you want to use an Arch-based one, I use Linux Mint because I just want to be the most basic bro on the planet when it comes to Linux. Anyway, so there are two types of billboards: spherical and cylindrical. No, there's three actually. So spherical billboards, cylindrical, and polyboards. That's what I was thinking about yesterday. I was thinking, do I want a polyboard billboard? This is nothing to do with the geometry, but how it's orientated relative to the camera. Polyboards are basically triangle strips that act like billboards. So anyway, you can also get, oh, I've already mentioned this, I didn't realize. You can also get polyboard, which is used for things like, no, that's not right. Right, I'm going to make a new note here, polyboards. Smoke particles would be the spherical billboards, actually. Are used for effects where, what is it called? Billboards need to be connected to each other. Think of lightning effects and things like that, and other such line effect. Line graphical effects, I think. That kind of makes sense. Okay, graphical effects. Polygon trimming is a way to optimization for billboards, which, yes. This uses maths to trim the corners of things. Oops. Yeah. So that's the basic introduction to what a billboard is and the 3 different types. Polygon trimming added an extra thing. Thanks, Alex. Yeah, I'm trying to stay, disciplined and on task. Games don't write themselves. I want to make a good game for you guys, so it's I'm trying to stay. And also, it wouldn't be, I don't know if that there's like a video where I talk about being an expert, right? It wouldn't be very good if I don't show people like the effort is. I talk about the effort that's required, and if I'm not personally putting in the effort in, then that's not going to that's not going to be very good, is it? So yeah, thanks for that compliment, dude. Yeah, you saw that, yeah. Yeah, so I've also got to practice what I preach, right? So spherical. Actually, I want to spell this right because I don't know why I get tripped up by spherical. I don't know if it's got 2. I always think it's got like 2 E's in, right? Spherical billboard. So I'll copy this out. So yes, what we're doing right now is some revision. This is how I start off the day. So this is like you're seeing how I go about my whole day. We will be doing studying probably after that, and then development to do a particle system. We have done billboards already. So yeah, it's the next step is to actually get this to get these particles down. Companies like Microsoft, yeah, killed id and yeah, it sucks. Yeah, I'm sure any Linux distro, by the way, guys, is fine. So yeah, but it doesn't really matter. I've just heard great things about Catchy. I think it's because it's got like decent graphics driver support for as far as I'm aware, and that's for Arch based. I wonder if I should make a meta. Yeah, what I'm going to do actually, because this is going to be a big topic in graphics programming. I'm going to make a second tag. So I'm going to call particles. I think particles are their own thing. Yeah, so in graphics programming, this is going to be a subcategory of things. So this just allows me to group things together. And they need to be generally quite big to have a second thing. But I think it's going to be useful, right? Okay, so let's read through this as we do revision. Spherical billboards are defined, not is defined, by a center point, P, and 2 radii, X and Y, Ri, Rx, equal to the half width and half height. Okay. The billboards can rotate about the orientation, but its normal vector needs to always face the camera. So the union of all possible orientations is a sphere of radius of the square root of those 2 added together. It's not even over. I wouldn't be surprised after Fable is out that they cut to... Yeah, so sad about it as well, yeah. Yeah. Minecraft is still alive. Yeah, it's one of those things, isn't it? It feels like the only games that people care about, well, executives care about now is like something like Fortnite or something. If it's not making a gazillion money, then it's not worth keeping, which is kind of lame. We need to move the billboard vertices into billboard object space. Let's say that MC, which can be transformed to camera space, to camera to world space, and MO, which will transform from billboard object space to world space to connect both spaces M and C, I'm going to say C and O, together make the transforms work. Together to make the transform work. Yeah, I don't think I need to say that twice. You get both. You want to get both vectors x and y be the positive axes. No, it's axes. Sorry, of the camera matrix. Yeah, given by the inverse of object space and the inverse of cool. Hello, Emmanuel. Minecraft is carrying Xbox as a whole. It funds a lot of other stuff. Yeah, I can see that. Have you used Box 3D? I heard Callie mention it on the previous stream. I have researched it. No, I haven't used it personally. I have stuck with Jolt for now. I'm not going to try and swap out things that I don't have the need to. I started implementing physics just before Box 3D came out. But if Jolt becomes an absolute pain in the neck, maybe I will change. But yes, I haven't actually tried yet. But yeah, I've heard. It's good. It's good that people are starting to enjoy Box 3D. I think Box 2D was like loved by the 2D developers back in the day. I don't know what people think of it now, but yes, I remember it being very well respected. And easy to use. Right. So where MJ denotes the column J of matrix MC, if you place vertices of a billboard in the plane determined by a P direction X vector Y vector, then the resulting polygon is always parallel to a projected plane. To get the column vectors of the view matrix, you would want to do something like this. Cool. If you have for vertex positions, they're given by these. If MO is so, I'm just going to go through these quick. I tried writing a compute shader particle-based system before, and man, it didn't go well. Yeah, that's why we're going to be. That's why the title of the stream is "Beginning of a Particle System." I don't actually know what I'm getting myself into yet. I don't know if this is going to be like a massive odyssey that's going to take a couple of months, but whatever. I'm gonna fight my way through it. Because I want to do it in the modern way that I can use it in future games. So if I do something that's like purely CPU based, or like kind of like I did with when I was programming the Hazel game engine, then it's probably gonna I'm probably gonna end up having to throw it away. So yes, I'm gonna have to power through. Hi there, Bura. Hello. I do them with compute in my game. You get a nice benefit. Yeah, so that's what we're going to probably hopefully be doing. I just hope that I can do collision detection on these compute shaders. We'll see. There's a lot of things I don't quite know yet, so we're going to be kind of working our way through this and hopefully finding good resources to pass through to get more up to speed. Because I haven't done particles in a long time. So I'm glad I've got this book that is going to hopefully explain how we do it. For a single billboard, it is often the case that P lines on an object in the object space origin. This means that the vertex position are simply a sum of the differences between radius x vector and radius y vector. This doesn't work for particle systems as that contains a large number of independent billboards. This doesn't work for a system as that contains a large number of independent billboards. There is a... What am I saying? I've said the same thing twice here. So if MO is contains scale, then we need to renormalize. What am I saying? I've said the same thing twice. Yeah, I'm going to get rid of this because I think I've literally said the same thing twice. Right. For a single billboard, it's often the case that P lies in the object space. This means that the vertex position are simply a sum of differences between this. Okay, that's fine. This doesn't work for particle systems that contain a large number of independent billboards. There is different points P that represents the center of the particle. Oh, I see what I'm trying to say here. When you have billboards that have and a point P that isn't represented at the center. So this is why we might need to do something a bit more complicated of each billboard, but we'll see. I only collide with them in the depth map. Yeah, maybe we can. I think yes, GPU Zen 3. Yeah, that's exactly it. It is chapter 6. So we're gonna be going through this. So it looks like it has and this was designed to run on mobile GPUs. So I'm not gonna completely freak out when they say we need to do this crazy optimization, but at least they'll have an approach that's going to be relatively I don't know, efficient. I don't know. Again, I haven't done things like that in minutes. Right, so the equation only produces billboards that face the XY plane of the camera and not actual positions of the camera, except in those cases when billboards lie on the center of the viewport. Yes, this is actually mostly good enough from a visual standpoint, especially when the billboards are small in size. This is what the code would look like. So we have the positions, we have that, and yes, once I finally figured out how. The only thing I don't quite understand here is, admittedly, I don't understand how this algebra translates to this algebra, where we multiply both the positions, the radius, and the column vectors together, and then we add them all to the position, right? I don't quite get that, but anyway, that does actually make a billboard that sticks to the XY plane. Yeah, so if we want to do something that's more accurate, we need to do something better. Right, so let's connect some things together, and yeah, feel free to chip in, guys, if you've got like a oh, this is I'm very receptive to feedback today when it comes to particles, because I am pretty much like coming in this relatively blind, as only doing very simple 2D particle systems. Oh, this is the old school vertex shader update thing. Yes, I don't know if it's old school or not old school, but we'll see. I don't really know much. I'm going into this kind of considering that I might need to just completely obliterate any understanding that I have, right? So we'll see. We'll see if I end up doing. Yes, these need to be connected together. Okay, yeah, that's fine. And we're going to be writing lots of notes today, I think. So this might be like a pure study stream today, where we just kind of go through like build particles completely from scratch. So we don't need to do these. That was yesterday's stuff. So I need to open up my graphics indexer. So we have an index here. Where should we put this? So we got physically based rendering. We got maths. We got some other stuff. Let's, I'm going to put particles here. This is only for me anyway, particles. Yeah, okay. So then we want to do something like, so billboards, because that's going to be kind of what we're doing here. I know billboards is more complicated than just this, but I can always just put them in again if I need to have a billboard section that's isolated. And What are billboards? Why do I keep typing billboards? It is what it is. Alright, let's tab these out. Yeah, so today we're going to make... Our goal, honestly, is to get this to be large. I'm not too concerned with getting much coding done today. I really want to understand the problem first before we do anything. Because the last thing I want to do is, like, go down a rabbit hole, figure out that... I've done this before many, many times. The worst one example of what I'm talking about is like when I did a physics engine and I tried to do things with beveling planes. I tried to do collision detection with convex geometry, build a binary space partitioning tree, and use beveling planes to simplify collision detection between points, between geometry to points and lines with moving stuff. With moving geometry as lines, with static geometry as points. The problem with that was no one did that. No one does that anymore. No one does that. So that's exactly what I don't want to do. I don't want to end up in a situation where I'm doing something from like 1992 or something silly, right? Aaron uses a clever mix of double and floats to make simulations both stable and fast. Who's Aaron? Sorry, I'm actually unfamiliar, Mika. Right, so we've done a bit of revision. Do I want to keep doing revision? I kind of want to dive into this and just see how difficult this is going to be, because I feel like if I don't lock in right now, we're just going to be stuck. You know what might be good, actually? Might be worth watching Never End Dev. What is it? Never End? I forgot his name. So he has a particle system. I don't know if it's like how relevant. Like, it might be like a nice introduction to like how to do this fast. What is like triangle? I'm looking for a triangle. Never Engine Dev, yeah. Just kind of at least going through it. So, right, okay. Creator of Box 3D. That's really interesting. So he flips between. So that must be the numerical precision issues that I ran into. Right, okay. So we're going to watch this, and then it's hopefully going to give us some kind of understanding of what we need to do. Yeah, pretty much. I don't want to dive into it, but that speaks for something, right? Gaming companies are really not doing well right now. Anyway, right, okay, so let's see what one of the goats of engine development that exists are doing. So I'm going to read this. I'm going to let this play. I'm going to stop the music, and we're going to be pausing. Let me just make the audio for you guys so you can hear it kind of. About 60 is usually good. I'm not going to talk over them too much, just because I'm going to take notes as we go.
From fire and smoke.
Okay, that's really loud. Hopefully it's not just particles of this. You know, I want to see how to do them well.
To snowstorms and fluid simulation. They've captivated us since the beginning of time, and even to this day, people gather in droves to watch particle effects out in the real world. Even in games, they've been right there with us from the start, as early as Space Invaders in the shape of animated sprites, all the way up to today with complex particle simulations across a
Sorry, I should, if I'm going to do this properly, I should make a note quickly. So this is called a particle system from scratch. From scratch. Cool. So, and then reference. So there we go. Cool. Thanks. And cool.
Plethora of games and game engines. So today we're going to implement a particle system for Never Engine. So grab your coffee, maybe a little snack, drag me over onto your non-work related monitor, and let's get started.
Right, okay.
First things first. In order to have many particles, we first need to have one particle. And in order to have one particle, we need to figure out what a particle even is. As with anything, it really comes down to who you ask or what game you look at. But in its simplest form, it's just a position that's rendered as a quad, also known as a billboard in computer graphics. Here,
So we've done this already.
you can see that to render a quad, we render two triangles. Triangles simply because GPUs really like them for reasons we won't get into in this video. Actually, screw that, because I've wondered this myself for the longest time, so let's find out together. So as it turns out, One big contributor is that the 3 points making up a triangle will always lie on the plane that that triangle creates, simply because you need a minimum of 3 points to create a plane. This makes it a lot simpler to clip triangles and create new ones based off of what can be seen on screen. However, that is not the case for quads or any other higher dimensional polygon, as you can see here, where one or more points can lie outside of that plane. Now with that out of the way, to start us off with our particle billboard, we're just going to send over the particle positions as individual vertices in what is called a point list to the GPU. The vertex shader.
Okay, so first things first, we need to do a point list. Okay, so first things to start, I don't know what to call this. Let's say introduction to particles, right? First thing you need to do is send over positions in a position list, right? This is called point sprites. Thank you. Thank you, Rock. Yes, feel free to chip in, anyone. Okay, so I will I'll the point sprite. Where do I add that? Okay, I'll add that in when it gets further on.
In this case, just forwards the information over to the next stage, and here's where we.
Okay, so this is HLSL kind of syntax.
To the GPU. The vertex shader in this case just forwards the information over to the next stage.
You want to apparently forward over the positions to the next stage. Cool. I don't know what the next stage is.
And here's where we plug in a geometry shader, which, as the name suggests.
Geometry shader? Huh? Why a geometry shader? I'm suspicious immediately. Yeah, exactly. I'm what the hell is this about, right? Why is he immediately going to geometry shaders? Okay, so we'll finish this video and we'll take what we want, just use a mesh shader instead. Yeah, pretty much. Okay, so right. I'm not going to say anything. I'm just surprised that you said geometry shader. Not even. There's so little support for mesh shaders too. Yeah, it's what I'm going to try and do is what I'm going to try to do here is just all I'm going to try and learn is just how I'm just trying to learn the basics from this, but I'm super shocked that this is a geometry shader.
Just can either add, remove, or modify the geometry that's being passed in from the vertex shader. In our case, we're using it to create 2 triangles forming a quad facing the camera. We do this by transforming the particle position into the camera's coordinate space by multiplying it with a camera transform, and then we just.
Right. Okay. So what he's doing with the geometry shader. Okay, in the geometry shader, which apparently is this. Why is he using a geometry shader? I just don't understand this. You can create triangles via a position. So this might be just a complete throwaway thing that we never touch. This is not what I expected. This is completely throw me through a loop. I thought this would be like, okay, yes. Fortunately, this is only like 10 minutes. This won't take too long, and we're going to be here for hours anyway. So I'm not gonna like freak out and try and say no. We should not study this. This might be useful for understanding a couple of different things. In the geometry shader, we can create triangles via the position. What I do is instance rendering for particles and update the instance buffer in a compute shader and collide them with the depth buffer. Fantastic. I'm going to write that down as well. Okay, so Alex has said, I don't know where to put this, so I'm just going to stick this here. What we're going to do perhaps is follow your thing, because we do have an instant rendering system set up. So what you could do instead is use instant rendering and update the instance buffer in a compute shader. Assuming, I'm just going to write this in brackets here, assuming that we get the buffers right. We might be interesting to try and move to, what is it called? Indirect draw calls. This might be like a good motivation to try and do indirect draw calls so we don't have to touch the GPU, but for now we're not going to do that. Assuming that we get the buffers correctly synced. With memory barriers. Okay, so that's obviously just that's just a more note to myself, and you've also written Alex then collides them with a depth buffer and renders them after the update. Fantastic. Okay, thank you. So we just rain effects where I can change the instance point, different UVs, so you can get nice splash effect. Oh, okay. This allows for you to do you know what might be a good idea actually now I think about this. This might be okay, how long is this? Yeah, I'm immediately don't want to do this. What we might do instead, we might go rogue. Do I have this book here? Foundations of Game Engine Development. Do I have Game Engine Architecture as a PDF? Let me just see. If not, we have a picture of banana though. That's good. Yeah, I don't want to touch geometry shaders for obvious reasons. Real-time rendering, no. Vulkan 3D Cookbook, no. And no, let me look at the other books. I think these are all a bit older. I got these from a friend. The same friend I quoted in the How to Become an Expert thing video. Yeah, okay, so maybe you'll just dive into that other book then. I think that's what we're gonna do. So I think I'm just gonna take notes from stream perhaps, and then just kind of, we're not doing that. We're not doing whatever the geometry shader thing was. Right, so this allows you to do things like change the UV coordinates and get sorry, let me read that again properly. I changed the instance to point different UVs and get a nice splash animation on rain. When a collision detection, detection is found. Right. Do you know what GPU instancing is? Yes. All my rendering is doing instance rendering at the moment. So you do multi-indirect draw calls, yeah. The benefit, you might need to do multi-indirect draw calls to pull this off, so we might end up having to do a bit of research on that because I haven't done that in a minute. I have done that a bit more recently, so it's not like I'm completely stuck on this. So, but I've got to be careful here. What we could do is leave everything alone and start implementing indirect draw calls for just particles for now, and then we could then implement indirect draw calls that pass things to other things. We need to do that anyway for more advanced like culling. Yes, so culling. We want to obviously cull things in a compute shader, right? We don't want to do things on the CPU. If we can get around it, to have a fully GPU driven renderer. Right. So I think the plan is then. Yeah. So this is exactly what I thought the stream would be. It would be like, yeah, we learned one thing and then we're going to do something completely different that I had planned. Right. So we're going to open up the Niagara renderer. Well, my version of the Niagara renderer. And we're going to kind of steal how the indirect, because we need to have a compute pipeline. I think, okay, so the first task that I need to have, if we're going to do it like that, is to one, make sure this has the same kind of general idea. So I'm going to probably speed through this real quick. We're not going to do much in this book until we know what's in it. Yeah, because if this starts talking about compute shaders, then geometry shaders, then I'm also not going to do that. So I'm going to go through this and just make sure it's using compute shaders. If it's not using compute shaders, it's not doing them the air quotes standard way. Well, wow, it's a lot of nice compression in here actually. That's really cool. We are going to kind of do what basically this idea, but we're going to have to first build a test compute shader that fills up some kind of buffer somehow, right? And then we can interact with that, right? Unreal Engine's Niagara. No, slightly different. Oh, yes, find Control F. I'll explain what the Niagara render is in a minute. So, yes, that's a good point. Compute. So, geometry shader. Geometry. Sorry, that's my Windows Noise. Geometry shader. Where are we here? So we're in 15. Yeah, that's not. And what's this? 16. So for some reason it's all in this chapter, which is about. I have no idea. I think this is some kind of like. Yeah, so there is some geometry shader stuff in here, but I think we're okay. This is all in a part we don't care about. Okay, cool. Yeah, thanks for bearing with me, guys, and helping me out. I do very much appreciate it. It's honestly one of the coolest things about what is it called? About streaming, is that I get to have your lovely help. Okay, so the reason that I need multi-internet draw calls isn't that complicated. What's complicated is sharing buffers between shaders. That's where things get a bit tricky. Because multi-internet draw calls are just follow the syntax and then you're good. But like synchronizing them isn't straightforward. So the Niagara renderer, I have a hive mind indeed. I'm just being controlled by everyone in chat. That's kind of funny. Yes. So I called this. Actually, I don't know. I'm just going to pull it up in my Git. I can't remember what I called it. Falls, yes. I called it Falls because Niagara Falls. So this is the Arseny Kompulkin's tutorial series that I kind of followed along with for a while. It currently doesn't work the way you would want. It has a bug in it. I don't really know what it is, but I'll show you exactly. Okay, so we are missing. Right. Okay, so obviously. Vulk, so that is probably me. I would like this to run, so I'm just going to see what. I might have to regenerate the project. I think that's all I need to do. Let's do see if a dirty setup will work. So let's just close this. So that doesn't obliterate the project. That just forces a regeneration, and we are missing. We are okay. So Vulkan. Okay, so that is in. Why is it looking for that? That's interesting. let's look at my CMake file. So we're just going to do some CMake debugging real quick. I don't think this is going to be that difficult though. So what we're looking for here is how it finds the CMake path. Yeah, okay, so it does that when Vulk isn't. Okay, so everything's kind of good in here, but I don't think in Vulk. I think we got a Vulk from like 2000 and like. We could probably just update Vulk, because I think. What version are we on at the moment? Let's go into Vulk. What am I doing? I'm not on Linux. Git status. Git. Stash. Git. Checkout. Master. I assume it's master. Alright, just pull changes. And then hopefully we should be able to just run this exactly how we used to. That's my Windows noise. Yes, okay, so I don't know what was wrong with the Vulk, but Vulk isn't that complicated. So we could just catch it up. Hi, Nox, how you doing, dude? Or Gnox, whatever you like to be called. Right, so hopefully Vulk has found everything. No. It is still it's still failing. Right. In that case, let's look at the project and just kind of throw this in. I'm just gonna be lazy here because I don't really want to spend forever debugging this. And right, for some reason this is the target include is that. Actually, this is gonna be easy to find in the CMake if I just have that. So 4 dot what is it? It's hang on. Sorry, let me do this again. I had to delete a bunch of stuff from my C drive because I was running out of space. So 3, 2, 1, all right. So 1.4.321. Oh, are you kidding me? All right, whatever. I'll just manually grab this myself then. Obviously, regeneration of this project is not going to work, but yeah, I don't want to spend the whole point of this is to not debug things live. So we'll go with that. And it needed include actually, didn't it? Include. It should have Vulkan. Yeah. Select folder. Okay. Okay. And that should. Let's just build Vulk. Okay, so we can build everything now, hopefully. Unless something else doesn't have that. Okay, cool. Right, so to hopefully see if any... Okay. We are... Where are we? This is the problem when the project's left to languish. Where the heck is this? Assert CPP. What? I have literally no idea where we are. Okay, this might be a dead project. Let me just, right, this might be, this might never work, which is disappointing. But what we're going to do is regenerate the project from scratch and just see if that does anything. So clean. So it's going to do the whole thing from scratch, and hopefully that is good. But it's fine because we're going to be here for hours anyway, so I'm not stressing. And I said build, and it's all good. We can't launch a project unless we select a project. And we try. What's the issue now? It can't find a shader. Okay, get out the way. And shader path is what? /shaders, lowercase. Okay, so it looks like I had an older CMake system here, which I didn't. Cool. This is worth doing, by the way, I promise you. Okay, so this just needs to be copied, I believe. Do we have SPRV in here? Yes. Because this is a research thing that I was going to do anyway. So there's the SPRV. And let's just do this again. Okay, so it didn't work again. And what's the error? It's the problem with more advanced. So query pool with type is active and invalid. What? What on earth does this error mean? Pipeline statistics members are used to create active pipeline statistics. Must not contain query input assembly. Okay. Like I said, I don't mind debugging this for a bit because does this exist in our project? Okay. So right, let's get rid of this. This is really I'm gonna make the text a bit smaller. Right. Create query pool. And the error is it's not something like I've missed S type, so it's the command mesh indirect draw call count. Query 0 is query pool this with type query pipeline statistics is active, which is invalid because it was created with pipeline statistics. This thing, okay. Which is incompatible with mesh shaders. Okay, that's fine. It's incompatible with mesh shaders. That's we are unfortunately just going to have to say, because we have mesh shaders in this project, we are not going to do that. I'm sure later versions of Niagara fix this. I'm going to sleep now. Hopefully I'll catch the stream in the morning. Yeah. Hopefully, yeah. Have a good night's sleep, man. Excuse me. Why are we getting the same error? Oh, pipeline statistics must not be 0. Okay. We can't just set that to 0 if we're going to use this. What do we want to set this to? I actually don't know. This is a quite simple lookup, I think. Right. Query type, which I believe is what we're... Oh, pipeline statistics. Nope. Pipeline statistics. So if I go to here, pipeline statistics flags, we have maybe mesh shader invocations. I'm just going to throw this in here and just hope for the best. Because that is what the task shader is supposed to be doing. Mesh shader queries is not a... Oh, for goodness sake. The problem is if I get rid of this, we're going to have to like get rid of some other stuff, which is just going to cascade issues. So I'm trying to fix this particular issue so we don't have to deal with things. I mean, we could just enable this feature, I guess. But that is not enabled. Where on earth do you exist? Vulkan feature. So let's see. So we have Vulkan features. Is it physical? Blah blah blah. Do we already have this guy though? do, thank God. So now we need to enable equals true. Right, okay, hopefully that's the final error. Okay, oh no, the graphics card crashed. Okay, so this is too deadly to keep debugging. How on earth did that happen? Let's just check the stream is still live. Alright, so are we still good? People still here? Yes, okay. Yeah, the graphics, if I crash the graphics card, then that can happen. The stream can just end on me. You've got to be kind of careful. Right, so in that case, what I'm going to do is just try and get rid of this feature then. I didn't want to do that, but I think that's going to be the easiest thing to do. I should just get rid of this. And let's just go back until we find what we need. This. So, where is this used? I'm just hopefully just going to try and get rid of this. That's Vulk. We don't care about that. We want to see when we're using this thing. Okay, so we have Quake query pool. Now, if I get rid of these, I should hopefully be able to just see what's missing and just get rid of this thing, because it's just counting things that I don't really want to measure anyway. Okay, yep. So I really hope this is just separate stuff. One thing I don't like about Vulk is the fact that you can't you only get this. You don't get the how many arguments are in the when you IntelliSense can't work out the arguments based on this. But you know, minor complaint. That's just how it works. You know, if this is done in any other way, all right. Oh, missed one. Yep. So we're not going to be doing any of this. The problem is if we do this, we might be writing out data here. So yeah, these needs to be deleted. And it looks like we can't have this at all, which is kind of disappointing. And we can't do this. And we can't do this. By the looks of things. And we don't delete the... Right, okay, so hopefully, fingers crossed, that we don't crash the GPU anymore. We shall see. Yay! There we go. Okay, so the older version of... there are some undefined behaviors in this, because it's clipping the wrong things. But the reason I wanted to bring this up and get them back to life again is because even this old version of the Niagara renderer, which Arseny Kapulkin has written, and I follow along with, has nice memory barriers that we can try and like learn how to do the late fragment shader bit, what we need to transition to if we have a compute shader. So this is the benefit of like getting this project up and running. So I can unfortunately I wasn't taking notes at this time, so I've not been able to revise this. But yes, hopefully we can just, you know, blast through this and understanding this. But the first thing is, before we continue with anything to do with programming, we actually need to figure out, is this book even remotely useful? So let's do that next. So that was a bit of an odyssey there, but we got there in the end. And let's change music playlist. I'm kind of over that, I think. So we have this to go through. Let's make this like this and get our Obsidian notes open. Okay, so we have a lovely note from Alex, which I'm actually going to delete this and put this in streamer stuff. Stream stuff. Articles by Alex. So yes, I'm going to do that. Put that there, and I may make that into a note in itself. But yes, we're gonna come back to that. Let's make this full screen, half screen. Let's get rid of this. Well, in a minute anyway. So box, this is GPU Zen. Zen 3. Multi-mega particle system. So it looks like there's a load of optimizations here, which is good. Reference. Jeez. Fine, I'll do it the dumb way. There we go. A GPU Zen book. Zen 3. The page 123/124. Cool. Introduction. Fantastic. Okay. Right, let's keep going. The multi-mega particle system. Nicola and Pambola and Pambola and Wolfgang Engel. Excuse my yeah. Okay, so the final thing. Okay, introduction. Not much has changed in the particle system architecture since 2010. Most systems deal with relatively small amounts of particles, a few hundred, except for occasional outlier effects like rain that run on the GPU. Okay, so apparently, come on, particles, systems. Let's get rid of this now. We don't need this here. Haven't changed since the 2010s, which is nice to know. As most, only render a couple hundred. A few hundred, maybe. Hundred, with the exception of rain, which runs on the GPU. Most existing systems are, so like I said, I will read this out loud. VK, yeah, VK command draw particles. I wish that was a thing. That would be cool. If it is though, that'd be hilarious. Most existing systems are CPU based or require CPU interaction before submitting work to the GPU, substantially reducing their performance. Yes. Okay. So, see, most systems. Yeah, so it looks like we're going to be doing a full-fledged GPU-driven graphic particle system, which is pretty sick, but also more difficult. Most particle systems aren't GPU-based, and which reduces performance. I don't know how you would interact with things without. This is the thing I don't quite understand though. If I'm doing particles that have collision, do I need to then do them on the CPU? I don't know. Therefore, artists were trained to work around these restrictions and design particle effects that could suit rigid architecture of CPU-based systems. Okay. With GPUs allowing for more arithmetic power than years ago, it is possible to relax these limitations and have particle systems made up of hundreds of thousands, if not millions of particles. If you use GPU-based, if you have a GPU-based approach, you can do something like 1 million cigarettes of particles. Which would be good. This would be good for effects anyway. I want to put particles in the space outside of bullets. This article presents a GPU-driven particle system in which the interaction with the CPU is reduced to a minimum, and most of the implementations is contained in a single compute shader, reducing the times the data travels through memory. Wow, okay, so this introduces a compute shader approach that limits the amount of interaction with other shaders, I guess, to avoid moving things through memory. Cool. Next, we built our demo using the Forge rendering engine to implement particle systems. Okay, on an AMD RX 6400, 100,000 light-emitting firefly particles and 4 million transparent particles and 8 dynamic shadow cast particles can be handled at around 25 milliseconds per frame. Interesting. On a European Samsung Galaxy S22, we can simulate up to 4 million transparent particles while having 2 million of them visible simultaneously, and 10,000 lights running at 30 FPS. That's cool. Obviously, that'll just be that's way too much for us, and we don't need that level of stuff. I don't know what a shadow casting particle is though. If Sega started making GPUs. Oh yeah. What, with the superscalar tech? Oh, did I say SR? I meant to say RX. Sega's SR100 stands for R ray tracing. Right, let's get into this. So we have visible buffers as the next thing. Nice. I don't think I need to write anything. Visibility. Buffer. Yeah, buffer. Yeah, we need 100,000 particles in our Sonic games. That would actually be kind of sick, like in modern ones. Anyway, to support many lights and reduce the overhead for shadows, we use the triangle visibility buffer rendering architecture. Okay, developed by our company, The Forge, and now used by most modern rendering engines. Okay, I don't know how to implement that, because that sounds complicated. It is a GPU-driven rendering technique consisting of multiple phases, each contributing greatly to reduce the amount of drawn triangles and shaded pixels. Oh dear, this is tough. Right, so let's think about this for a minute. Yeah, basically I've just been a bit blindsided here because I don't know what this is, and it looks like a whole different set of things that I need to do if I wanted to match their performance. Sonic Frontiers has a good number of particles on the screen. Yeah, that's true actually. Alright, so I am a bit worried that I'm going to have to build whatever that is. What is this called? A triangle visibility buffer. What is this? I don't know if this is necessary or if this is just going to be overkill. So what is this? The visibility buffer, a cache-friendly approach to deferred shading. When was this written? 2013. And this is the visibility buffer. What is this talking about? So we have implemented a novel real-time rendering pipeline that recomputes data in a deferred pass that would normally be stored during the visibility pass. By doing so, we have significantly reduced the effects of working set during deferred pass. So, as it is better to exploit the cache hierarchies and minimize traffic to DRAM, we have also completely decoupled the visibility pass from the shading passes without requiring a second trip through the pipeline front end, as with a single Z prepass, our results demonstrate the performance advantage of our pipeline on GPU architecture with limited DRAM bandwidth, but with useful cache hierarchies. We hope that these innovations will spur additional research on how best design rendering system targeting future SoC platforms. Not sure what that means. Where power is always a concern. Oh, okay, so this is like a mobile thing. Right. Right, so we have a paper that's come up here, and is this still a thing? I've got to be careful here, so I don't want to implement something that's like from 2013 only. Because this seems like pre-meshlit, mesh shading things. Yeah, it is. Okay, so right. Okay. Yeah, so this is pair triangle culling, right? But if you were to use mesh shading, you would be able to get this for free with like very limited amount of work. You know, if you did like a cone. Sup, Angelica is a cutie. How you doing, dude? We're just looking at different research papers to figure out what we actually need to do. This is what I expect. We're on a bit of a research odyssey right now. Trying to figure out what on earth we even need to do to have a decent GPU-driven particle system. Right, so okay, so I'm just gonna have a quick skip through this just to make sure, is this absolutely necessary for what we need to do, or is this... So I'm gonna read through this and kind of assume that without any triangle culling we can't render as many particles, but we should still be able to do these type of things. So I think that's fine, but I'm going to make that assumption here. Okay, so triangle filtering. Triangles, for anyone who's running, this book is linked in the description, but it's obviously, I own this book in real life, and we're on chapter 6 if you are interested in reading about this as well. Triangle filtering. Triangle vertices and indices are processed by a compute shader to cull as many of them as possible, using the current camera matrix to evaluate whether a triangle is visible or not. It's in case it's visible, applying additional metrics to attempt culling. The indices of the triangle that cannot be culled become part of the set of indirect arguments. It is possible to use a set of arguments for a main camera view and one for shadow map view, so that the vertex and index buffers are accessed only once for all views. Alpha masked geometry is handled separately, using a similar approach using the diffuse textures to know which parts of the triangle should be discarded. Yeah, I have a feeling this is like pre-mesh shading optimizations. Which I'm not that concerned with, because I'm not going to put like 1,000 particles on this. Well, I'm not going to put like millions of particles on the screen and expect things to run normally. Batch compaction. Since triangle filtering runs on batches of 256 triangles, in our case, it can produce empty draw calls, so a shader is used to remove them to avoid overhead in the following phases. Okay. Visibility buffer pass. And execute indirect call is used to store data needed to shade the scene in an R8, G8, B8, A8 render target. One bit is used to represent whether the triangle is an alpha masked or not, and the 8 bits are used to store the ID, the draw call ID, and the last 20. Okay, so 8 bits are okay. 8 bits are okay. So 8 bits are okay. So this is just okay. This is just compressing stuff that we get into the next. Okay, so okay. Right. Okay, so this is just passing stuff from one buffer to another, right? There isn't anything in here that's like inherently complicated, assuming that you've already done this indirect thing. Okay, so 8 bits are used to store the draw call ID, and the last 23 bits are used to store the triangle ID relative to the draw ID. Okay, so I am going to assume that we can skip all this if we're just going to try and draw everything. Again, obviously not as efficient, but I don't want to have to write a whole mesh shader equivalent for things that I don't think are going to be needed. Anyway, the visibility buffer shading, the previous as... but we do need to know about this, because otherwise I think this is going to make less sense if we don't. The previously mentioned render target is shaded appropriately. The IDs are used to access the vertex buffer and reconstruct the barrier-centric coordinates of each triangle, which are used to retrieve any other information, normals, textures, and coordinates needed to shade it. Okay, that's interestingly using barrier-centric. Similarly, similar to the case of deferred shading, the amount shaded pixels is minimal compared to forward shading. Okay, fair enough. Still, the whole process has a much lower impact on memory since it's done on memory, since it does not need as many render targets. Okay. Right, fair enough. Hey man, it's my first stream. Do you try to understand the whole book, or just things that you need for your particular particle system / game engine? Yeah, it's that is an important aspect of like how deep do you go down a rabbit hole to understand something. I am in the middle, I think. I generally sometimes will just study maths for a while. Like I studied offline ray tracing for a bit, just to try and understand how light works better and stuff like that. So I do that sometimes, but for now, what I'm trying to do is build a GPU-driven particle system, and that is just going to be really difficult anyway. So what I'm trying to do is just be as lazy as possible, and blast through this as much as I can, setting things up. This is due to the fact that I don't have infinite time. So yes, I will try and do indirect draw calls with a compute shader, and then just leave it at that, transferring the barriers over. That's my goal at the moment. No, we lazy it out and just do the bare minimum. Basically, I mean, it's kind of smart to do the bare minimum. It's still not an easy task, but it's like, if you can get away with not writing something, then that's a W, assuming that you don't need it. Like, I don't need that visibility triangle buffer thing, because I'm not going to render like a billion I'm not trying to render a billion particles, right? That all have shadows and light and stuff like that, right? I just want to put like nice particles in space and have bullets in my little space game. Anyway, so I'm gonna say this book references a visibility buffer which calls triangles. From geometry, and if there are no triangles left in for a draw call, the draw call gets called too. It has to do a bunch. It does things in 2 phases. One for transparent, or translucent, I should say. Translucent materials and opaque. No, that's how you spell that. Yeah. Let me just use my spell checker, aka a search engine. Opaque. Yeah, there we go. Okay, cool. Triangles. I believe it has a. It builds up a. What is it called? A render. Builds up a buffer with 1 byte. One bit for working out if a triangle is alpha masked. This just might be relevant for what we end up reading later on. 8 bits for storing the draw call ID, and the last 23 bits store the triangle ID relative. Oops. To the draw ID. Right. I believe this is a poor man's mesh shading approach. Oops. To culling triangles from geometry. Meaning that I don't think you need this for a GPU-driven particle system. So that's kind of what I got from that. I don't really think that we need to do exactly what they do. Yeah, I hate reading, Angelica says. Too much translation to do, especially for category theory stuff. Yeah, reading gets hard for me after like 30 minutes of locking in. Yeah, I can go for about a couple of hours until I start getting tired. And that's probably what's going to happen today. I'm probably going to do a lot of reading today. Because we're going to have to figure all this out so we don't end up getting kind of stuck. the last thing I want to do is start writing a GPU-driven renderer, and then all of a sudden we get like completely stonewalled by some weirdness. Right, I'm in for the long haul today, so we're going to be here for a while. I just hope my throat doesn't get sore. Okay, we define a particle system as a collection of particle sets. Okay, so that's cool. You can define a particle system as a collection of particle sets. Cool. Maybe I should bold these because they're all italicized in the book. B, Control B, that's what I'm pressing. We've got to make sure that my future self doesn't get annoyed by myself not helping myself make this readable. Anyway, I'm not even reading this. Anyway, a particle set is a set of particles that shares the same properties such as texture, particle size, maximum speed, or AI behavior. Okay, so a particle set is just a set of particles that share the same properties like textures, size, speed, max speed, or AI behavior, which we might do. I don't know. That seems a bit like a future task. Anyway, each particle set is made up of a single particle, single particles, which keeps their current position, age, and velocity. Yep. So each particle within a particle set keeps track of position, age, and velocity. Oh, you know, I completely forgot to mention. Let's pause this for a brief sec. Yeah, we hit 3,000 subscribers on the channel, which is cool. My goal, just for the people who are newer to the streams, my goal was to reach 2,000 subscribers by the end of the year. Like, that was my like secret goal. And I was like, oh yeah, I've got to try really hard to hit 2,000 subscribers by the end of the year. And I had 1,356, I think, subscribers at that point. And now we're at 3K, which is kind of crazy. Yeah, we hit that long ago. Yeah, 3K. It's like I'm very grateful for everyone who's subscribed, and I thank you all for that. I just hope that that you find this channel useful and it keeps providing value and is useful for you guys. So I just want to say thank you to everyone. I'm sorry I got completely locked in with programming, so I completely got distracted. I just want to say thank you to you all. Yeah, I was shocked that we hit 2K so quickly, and now we're at 3, which is awesome. Yeah, I'll keep working hard for you guys, and I'll keep trying my best to provide as much value as possible for the people that care. So yes, thanks again, and let's see what the future holds, eh? Let's see if we can keep on growing. Who knows? I keep mentioning this. Well, I was honestly, when I started out with making YouTube videos, I was shocked I had 40 subscribers. I was like, wow, 40 people are interested, and now we're at 3K, which it just feels like it's surreal, right? Yeah. So we hit 3K when I was sleeping. Yes, last night. So It's real cool. Real cool stuff. Alright, let's get back into the grind. Why haven't you stopped? Okay, cool. Thank you for making quality civilians. Thank you, Tanash. Yeah, it's very much appreciated. Yeah, I'll keep trying to always provide value for you guys. I'm aware that this is a bit more of like a radio show, the actual stream, but you know, I'm forever grateful for you guys. And you know, even if you subscribed when I had like 10 subscribers, or you subscribed literally 5 seconds ago, you know, honestly, I'm still grateful for everyone. It's all awesome. Anyway, grind time. Multiple particle sets can achieve a certain. So should I highlight this? Is this like better for you guys if I'll do that. Multiple particle sets can achieve a certain more complex effect. Okay, so yes, when group multiple surprising no one particle effect sets can achieve a more complex effects. Okay, so we got that done. Yeah, I'm going to keep highlighting things so you can at least see where I'm up to. For example, a particle set that emulates fire and one that implements smoke can simulate a bonfire particle effect, right? Listing 6.1 shows the declaration of the structs used to represent particles and particle sets. Okay, so this is good. So we have particle. So these are structs. What's data mean? That's the thing I don't quite understand about this. I saw this earlier. I was like, data. Right. Okay, let's have a look. Because I want to translate into something I can use. So represent particles on particle sets. So I believe this. Okay, so yes, this is the individual particle, and this is the individual particle set. Okay, cool. What's data? So okay, particles and particle set structures from shader header particle def h FSL. Okay, so that's obviously their custom Forge, I assume, shading language. We have I just don't get this data thing. Okay, so the XY volume, position, amount of particles, color. Right, so there's a ton of stuff in here that I probably never want to use. So we have Boyd's in here. I've tried multiple times to do Boyd stuff, and it's never worked. It's been kind of a disappointing endeavor. Right, so what I'm going to do here is kind of make a mock. What's non? I think what I'm going to simply do is just. Oh, I see. Float name assignment value. Okay, that's actually okay. I understand this now. Voids, yeah. Oh dear. Yes. Okay, I can see where you get that. Yeah. Right. So particles. That's a particle. So uint. So this is a vec2, which is called velocity and age. Velocity. So yes. Can you? Wait, did I? I don't think I turned down the music. I apologize. Let me. Hopefully that hasn't been too loud for you guys. I will turn that down to here. Hopefully that's good. Let me know if that's good for you guys. Velocity and age. So I'm just going to copy this out, but kind of write in GLSL syntax because I don't really know what they're trying to do here. So position. Yeah, it's fine. It's been okay. Okay. Well, let me know if you want it louder again. I can always turn it up. Whatever you prefer. I don't want to make sure you've got a good listening experience. Set. Cool. Do this. Do. I have my own music anyway. Fantastic. That's all cool. So vec4 size, which I will write these comments as well, so I can actually try and use this in the future. So the x, y, z volume of a particle, w is the scale. Okay, so x, y, and z is the particle volume. Sorry, is the volume of the particle set. Interesting. W is for scaling particles. Cool. Let's scroll down. Right. W is the scale of particle. Yes. Okay. So we have position of the particle set. I kind of like this where we have like a container for vec3 position, and we have amount of particles spawned per second. Okay, amount of particles to be spawned per second. Very good. Because we might end up using this. This is why I'm going slow. Float particles per second. Per second. And color of the particles in the set. So we might just have these, right? I don't want to overcomplicate this where I have like particles that are all doing thousands of things. But yeah. Radius of emitted light, which is kind of cool. That would be really nice to have if that does work. So this is a float light radius. And AI type of particles. So if we have AI, game AI, by the way. We're not going to be sticking ChatGPT into a particle. I don't know what that would mean. Describes whether a particle should cast shadow or emit light. Okay, so describes whether, that's not the right whether, a particle, keep saying, should cast shadows or emit light. Okay, cool. So this is just another uint. Light bit field. Very cool. Right, so yes. Very good. Okay. maximum amount of particles to allocate. Very good. Uint, nope. Max particles yeah, so life time of the particle, a single particle or the particle set? Yeah, because we have 2 ages here. It's probably of the particle, I don't know. So this is just a float. Oh, initial age. Okay, so yeah, this is how long it's going to last. Age. And then forces for the flocking algorithms. So uint void. Our void seek strength. I think why I've never been able to implement void stuff is because when I tried to do it a long time ago, I just couldn't implement like the most basic thing of all time, which was like separate, which is like just velocity. I couldn't do the simple like correcting of velocity as time went on. This was me trying to go through the game AI book. I forgot what it's called, but it's a good book, but I didn't want to use GDI, which it was kind of stupid because I was just like, I'm going to use my own game engine, and it immediately made that super difficult to do because that just added like a layer of complexity to the thing I was supposed to be learning, which was AI. And yeah, I should have just been learning AI. That was me trying to be cool, I guess. Steering. Steering. Strength. Max. So I can't imagine it's like that difficult to write a full Boyd algorithm. It's actually really good. Like really efficient. Right. Cool. Written that out. I'm gonna say yeah, if you are gonna learn something, just go along with it, you know. Right, let's keep on keeping on. Okay, so all the particles are stored in the same buffer. Okay, the particle properties. Okay, so all particles, say all particles, are stored in the same buffer. I don't think I can rewrite that any other way. Particle properties such as particle sets to which they belong or whether they emit light are described by the 32-bit field which is stored in a different buffer. Okay, so we have a different buffer that stores a 32-bit field which keeps track of whether the particle emits light and keeps track of things like if the particle emits light and what particle set it belongs to. I was going to say take a shot for every time I say particle, but you're probably going to die by the second hour. This is going to be particle, 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 particle over and over again. It's probably going to lose all meaning by the time I finish this stream. Right, let's continue. belongs to. Okay, cool. Swag, right. The fact that bit fields are stored separately allows us to avoid accessing a whole particle in certain cases. This is an optimization that allows us to not access the whole particle in certain cases. I don't know what that means, but whatever. So we have two buffers we're working with. For example, light clustering shader can detect if a particle is dead by looking at the bit field without retrieving the whole. Ah, okay. To unpack which. Okay, so for example, if we have a light clustering shader, it can detect if a particle is dead by just looking at a bit field, at the bit field, without unpacking the entire particle. Which it belongs to. Fantastic. Okay. Of course, buffers need to be mirrored if a particle is located at index I. The particle, of course, if the particle needs to be mirrored if the particle is located at index I of the particle buffer, its bit field must be the same index of the bit field. Can I copy this? This will be easier. Yes, so can you do hash defines and shaders? I'm just going to assume we can, right? Anyway, for example, if a buffer needs to be mirrored, so if, for example, if the buffers need to be mirrored, why would we want to do that? If a particle is located at index I of the particle buffer, its bit field must be the same at the same index of the bit field. Sorry, I'm not quite getting this. Of course, buffers need to be mirrored if a particle, okay, is located at index I of the particle buffer. Its bit field, oh, okay, must be the same. Okay, yes. We need to, oops, to make sure that our bit field buffer and our particle buffer are 1-to-1, meaning that if we access something, access bit field ith, then that should correspond to the same bits, same index in the particle buffer. Right. Here are a list of, here is the list that defines for a bit for the bit field buffer. Cool. What up, Escape Point? Whoa, hello. Keen, how you doing, dude? We are just studying today. I'm just going to try and Today we're going to be a bit of a longer stream, so we're going full hog on learning how particles work, so I can do this properly. Hopefully by the time we'll have some kind of beginnings of a lovely GPU-driven renderer. Okay, what about C++? Is this going to work? Sorry, a GPU-driven renderer for particles. Hello? Syntax. Why? No, don't do that. Okay, all gray's completely... Why are you being annoying? Because this... I would like this not to be gray. That's kind of not good. Okay, Java works, I guess. For some reason, C made everything grey, so we're just going to go with 10. This is Java. We can't use syntax like GLSL in this code block here. So apparently, according to Obsidian, we're coding Java right now. Right. And we've lost our underline. Okay, so this is going to be fun to fix. Can I? No. Okay. Sorry, gang. This is going to be a bit of a faff. Can I go and insert at least? No. Great. Okay. Well, okay. It is what it is. It is what it is. I think it's still going to be faster than typing this out by hand. So we're just putting these back in. So this is valid syntax. Maybe that was why it's C. C didn't work. I'm just going to do these right now. So yeah, we have a lot of bit fields here, which we might not even use, but I think it's good to have a bit field like this that we can do like light clustering later, and we'll have at least a separate buffer for that. So that's actually really smart. I think C++ highlights. I think C++ gives highlighting in C in Obsidian. Yeah, I'll give that a shot again. For some reason, that wasn't working, but it may be because we didn't have. It was poorly formed because all the what are they called? The underlines of underscores have been deleted. So this is just. I'll do that after I've faffed around with this. It's important for me anyway that my notes are readable. I could just rush through this and be fine with it being a bit scuffed, but I don't want to have to look at this in the future and kind of like in a confused state. Like, did I deliberately mean to do that? You know? So yeah, we're tackling this as we go. Right, and almost done. So yeah, now the code is like more readable. But like I said, this is still going to be more... sorry, this is still faster despite this syntax being weird. Of going through this. So we have... I don't like... This is just me being picky there. Okay. For goodness sake. Okay. Right. Let's try. Nope. It's just all grey again. So yes, we're going to be coding in Java here for some reason. Okay, that was a big fail. So we can just read it. Okay, so each bit field type has a mask that allows us to isolate a certain property. In this case, the allocation state. So allocation set index is allocated. Okay. Oh, it's Lamau. Yeah, I don't know. Coding Java. That's how it is today. State of particles, bit field, state mask. Don't know exactly what that is. Is alive, is moving. AI behavior, bit mask. I see. Okay, so this is the total bit mask. Right. Okay, so I think this is the total state, and then these are the individual states. Rain, firefly, Boyd. Billboard, bit, aligned, velocity aligned. Screen aligned, velocity aligned, okay. Lighting flag, a particle can emit lights and cast shadows or is affected by lighting in the scene. Lighting, bits, which is the total thing. Non-light, light, shadow. Collision with depth buffer. Okay, so that's actually something that Alex was talking about. So can it collide with the depth buffer? So this is the Alex thing. Bitfield. You use Obsidian. I just use my brain. Not bad idea. Yeah, that's... I did that for many years, and the fact that I can't remember stuff is due to the fact that I never wrote it down. So yes. Right, I'm just gonna head to the loo real quick. I'll be right back, gang. And just put our lovely, zoom in so we have a BRB. Right, okay. Be right back with this crazy music playing. Okay. Right, let's continue. Let's go. Get rid of that. Okay, so the bit field and particle buffers are divided into 3 main sections. Okay, so we have 3 main sections for both particle buffers and bit field, and for both particle and bit field buffer, are divided. Into 3 main sections. Cool. To be honest, making notes in Obsidian while learning data structures and algorithms, but I noticed I never went back to read it, so I just stopped taking notes. I find that asking stuff to LLMs is less effort overall. Yeah, it probably is. But I know I kind of say this as a joke, obviously, but I want to turn my brain into an LLM, you know? I can just ask my brain and it can receive it. It can just recall the thing, right? So the idea is that every day I do a bit of revision, and then basically I will forget stuff, obviously, because there's too much to remember. But I hope that at least like 90% of what I've learned is kept in my brain. Anyway, section 1 contains particles that emit light and cast shadows. Section 2 contains particles that only emit light, and section 3 stores the rest. Okay, so section 1 contains particles that emit light and cast shadows. Section 2 contains particles that only emit light, and section 3 is for everything else. Sound. So Angelica Zacuti has said, yeah, I let AI do my design bookkeeping. I just tell it what to change and ask what I did last week, lol. But code design, I write myself and keep any of it, though Haskell code is undocumented. Is self-documenting afterwards. Makes sense. Book is hicky as hell. Yeah, that's fair enough. I want to use as little AI as possible. The only time I've actually used AI to seriously learn is actually I quiz myself. I get the AI to write a bunch of quizzes and then I pretend I'm being interviewed. That's the only time I've ever used AI to learn. And then I ignore what it says because I know it's going to be a lot of like half truths, and I don't want to learn like a bunch of AI gibberish that like subtly gets things wrong. So I then look at my notes and then try to correct the AI based on what the mistakes it's made, pretending that the interviewer has made a mistake on purpose to try and catch me out. Anyway, each of those sections is divided into 2 subsections. One for particles that belong to an active visible particle set. Okay, so each section is divided into 2 subsections. Okay, so we further divide these 3 sections. Say 3, it's easier to read. Sections into visible, visible and active, and one for inactive. So invisible particles. Cool. When I try to make a game, I keep it coherent, so I just manage my repositories as full markdown files. Interesting. Is that the bookkeeping thing? The bounds of each section are stored in a small read-write buffer. The bounds for each are stored in a small... Right, okay, so we have an additional buffer, apparently, that stores each section, stores the bounds of each section in a small read-write buffer computed by the preparation shader. Okay, interesting. So we have a preparation shader here. Right, so I'm going to split this up a bit. This is kind of getting a bit dense. Yeah, it's exactly that. Emanote to do. I spent a while on. Oh, right. Yes, you showed me that yesterday. Yes, exactly. Right. Yes, it's actually kind of nice looking. A small representation of this particle buffer is shown here. Okay, so as far as I'm aware, we have 3 buffers. Now we have 3 buffers. Okay. Okay, so now we want to insert a table. This is a bit complicated, but hey. Light plus shadow. I don't know if we have this visibility thing. Light only. And then standard. Okay, so I don't know how to do this, so I'm just going to do a active, inactive, kind of like that, right? So oops, I don't know how to do that in Obsidian, and I think it's going to be a bit complicated than just using this. Yeah, I'm just going to ignore it. Otherwise, it's going to be super complicated. So, okay, so we have a bit field buffer, we have the particle buffer itself, and we have this other buffer, which I'm going to call 3 buffers. Bit field. Boundary. And particle buffer. All tracking states. Cool. Right, so what I'm going to do is I'm going to go a bit... I don't know if I'm going to... Okay, no, let's keep going, I was going to make this into a smaller note, but I'm not entirely sure. We might have thrown this all away, to be honest. I hope not, but if it's too difficult to get anything working like this, then I see, so we have a getter in the shader itself. And then how dense are we here? So pack 3 floats. Okay. So it looks like packing is going to be quite difficult to parse. And then, yeah, we got to obviously sort them if they're all different. And then voids, which I probably don't need to do, and then rasterize. And then lighting. Light clustering. Which has got a bunch of stuff in there. Which tells us how you're supposed to do that in transparency. MATLAB, you can do that in MATLAB? Anyway. Very good. So I'm just looking ahead a little bit. Yeah, it's just the times and stuff. Because I just need to know what additional work do we need to do here. So what I mean by that is yeah, this is all well and good, learning all this stuff and doing the packing and stuff. We're getting repeating music, so I'm just going to change the song. I think we've heard this one as well, so I'm going to change this to this. Yeah, let me just figure out exactly what we need to do here, because I need to do the bare minimum to get this working, if that makes sense. This is all great. I just need to... I think this is like an addition on top of stuff, right? If that makes sense. So we should have a... I do like this idea of having multiple buffers for things, because then we can use it in different... we can use the data in different places. But if it's super difficult to... Because what I think is going to end up happening if I just we're going to read all this, right, and we're going to keep going. It's going to be great. And then by the time if we've read this, we're going to have to kind of do something different anyway, because this is so different, right? Sorry, this is so like this is like assumes that I think you already have a particle system. Anyway, hi. Do you have some C++ which you could recommend? A lot of code written in C++ nowadays, and though I know C, it is difficult for me to decipher C++ sometimes. Yeah. I know what you mean with that, with like people writing like super advanced C++. That's kind of like, what the heck. Just be aware though that C like C++ exists, which means that you can write C in a very C++. You can write C in a very C++ way. So you don't have to like learn all the shiny examples. But yes, I can recommend a book. So you're pretty advanced. Let me think. What would be a good book for that? I think Effective C++ would probably be a good bet. So if I go to private browser mode, because otherwise I get doxed if I do this without this. So it's not, you won't learn like super advanced template uses. But yeah, I think this is like a decent idea. It gets updated every now and again, but it's not really about learning C++. It's like how to write good C++, which is different than like learning C++ from scratch or something. I've read this. I've gone from cover to cover on this book. I really like C++ gotchas. This is one of my favorite books. I think it's underrated. C++, what is it called? It's a bit of an older book. This one, but it's like as far as I'm aware, it's still relevant. What this is about is avoiding like mistakes like that you can make in C++. Yeah, the Tor C++ book is great, but I think it assumes no knowledge, right? This is good if you just want to be, you know, straight up. Give me all the C++ right from the beginning. As far as I'm aware, this is someone at Kalia in chat is also going through this as well. And it's obviously written by the creator of what on earth is this? I'm trying to get to the contents. What am I looking for? I'm looking for the index page. Is there no index page? Well, I'm assuming that... Okay, so when Amazon is being really annoying here. Don't... For whatever you do, don't get these books. Holy moly. Absolutely avoid them like the plague. Yeah, so I don't want to go on Amazon because it's super annoying. Is there an index here? No. There's no way to know what's in this book. Okay, great. No, really? No? Table of content. Here we go, finally. Okay, so... Yeah, so this will give you, like if you want to learn, like, just that, like, everything from scratch, right? Like, you'll learn everything from scratch, but you'll know a lot of this, so you can probably skip over some of this. But it's good to know these type of things. But yeah, Effective C++ is good. Like Gotchas, C++ Gotchas is a good book. Yeah, C++ devs surely love mountains. I don't know where that's come from. Don't get Effective Modern C++. Oh, is it been updated? Okay, so I say that and I didn't realize this has been updated. Effective Modern... When I was reading Effective Modern C++, I was like reading C++ 98. It was like how to do Effective Modern C++, and it was like super old. But that was the one I was given at work, so maybe that was just me. So yeah, I would take your pick from those three. Effective C++ is just like, it's not a beginner book. It's like the Tor is fine. Like any teach yourself C++, but it will teach you from the beginning. Like assuming that you know nothing, which may be a bit slow for you if you already know C. And C++ Gotchas, I believe, is a very good book to Like, you'll find a bunch of stuff in here, you'll be like, oh, okay, so that's why I constantly get this compilation error. Like, because I'm doing this bad thing that's not explained very well. It's pretty old, but I think if you're going to write C like C++, which I'm doing, this is very good. Yeah, Scott Myers is a decent programmer. High singleton pattern paradigm is most elegant. Yeah, exactly. Yeah, his singleton has a high singleton. Yeah, so this was probably my favorite C++ book that I've read. That was purely C++. So hopefully that gives you some ideas. But I would say just start. I think a lot of people kind of get caught up in the perfect resource. It's like analysis by paralysis, right? Or paralysis by analysis even. If you just pick a book that I've suggested that will fit your needs, and then just try to start learning, you'll be fine. Like when I started learning C++, I started with a completely different book that's not here, but I started to learn C++ when C++ 11 was new and awesome and the newest thing on the market. Stop using auto pointers, guys. Use shared pointers instead. Yeah, so I was learning C++ back in the day, you know. And yeah, they're quite rare. This one's quite short if you ever get this one. It's quite a short book. Because it's just a list of things that you shouldn't do. Like, it talks about object slicing in one of them. It talks about magic number usage. So yeah, yeah. You know, all that kind of general stuff. Right. Let's close these. But yeah, tour of C++, C++ gotchas, and effective C++, which gets more updated. That gets more updated than the other books. This has been updated. This is the most up to date, I think. But you don't need to know like C++ 26 stuff, you know, in my opinion. Knowing every standard thing that you need to do that's now new isn't necessary to write good programs. I think that can just mean that you write code that only you can understand, which may be a goal, I don't know. But I like this standard KISS, keep it simple, stupid. If my C++ is simple and everyone can read it, then I'm going to be able to understand it in the future. Yeah, that's the way I look at it. If I've written some crazy C++ 26 exclusive thing, then I am probably going to struggle in the future to understand that. Yeah, and I think it's antithetical as well to writing fast code. You can end up writing slow code by accident because you've relied on the compiler to do things for you. But anyway, that's a side tangent. That's not really necessary to learn C++ to know it, to think like that. It's just that's my personal philosophy. It's all opinion though. Anyway, so I'm going to take a little break from what we're doing right now, I think. When I say break, I mean we're going to find another resource. I'm going to like learn something else and kind of go back to this, right? I think if we just go down one path, I think what we've learned here is quite good, but I think it's very specific, meaning that we need to understand other things as well, so to do this well. So I think what I'm going to do is study something else briefly and then kind of come back to this when I think it's necessary. Philosophy, push yourself to your limits. You're only using 30%. Yes, push yourself. I don't even mean that. Yes. Right, so we've done this, we've done this. So what we need to do now is, what I say is study the code. Study the blade. You are making friends and having girlfriends while I was studying the blade. Now what we need to do is like what I want to do is go through the indirect draw calls again. I think my goal today is to at least write a compute shader that does something, even if it just adds two numbers together and comes out and it doesn't, and we don't have any pipeline barrier issues, right? Because that's the hard part of dealing with compute shaders with different buffers. And if we're having 3 buffers in this particular case, that I think we need to deal with 1 buffer first. So I'm going to use the Niagara renderer to figure out exactly how to write this indirect draw call. I mean, you need to do it with indirect draw calls, right? So that's the first step, and hopefully that's chill beans. Right, so let's continue. So I think I'm gonna flip backwards and forwards. I had this idea that I was gonna watch all the Niagara videos from scratch again, but they're like hours long and it would take too long. Right, so we don't really care how the meshes get in. We just care about the shaders and how they interact. So I think what we're gonna do is maybe we should even write the view frost no culling algorithm, because that'll be like an indication that we can actually hand buffers from one thing to another, and it's actually a useful buffer, a useful thing to do. Or we should do this, the full screen pass for the pre-pass. I think this is what this is doing. What have we got here? So we got draw call. Either one I think we should try and implement. Project sphere, yes, we need to do the projection. Oh yes, I remember all this now. Oh, it's all coming back to me. That is so annoying to get right. Arsini though is so good. He simplified all the algebra on his stream. It was so cool. But I think we just need to, yes. We do the projected screen. Okay, so let's look at this properly. When is this used and what is it used for? That's the first thing I need to know. And we do need in and out. This is the general compute shader, 32 by 32. Fantastic. We have the global invocation ID. And we create a depth texture. What are we doing here? This might be the reverse hierarchy, actually. The hierarchical Z buffer. So let's just dig through this. So a lot of this is going to be like me remembering what's going on. Unfortunately, following exactly what Arsini did wasn't that useful for the names. So yeah, let's look at the shaders and try and figure out like when was this used. So we need to find the draw call comp or depth reduce, actually depth. Yeah, I think this is literally the. Yeah, what is this used for? Line 16, so we didn't use stack at the time. Depth reduce program. Yeah, we need to make a program, obviously. Compute pipeline, which I don't think we have. I don't think we can set up a compute pipeline. We also need to make it parallel with the draw. Oh, this is so complicated all of a sudden. Okay, so this was what? Yeah, I think this is the Z for. I think I have a. If I go to my air engine, we have. I think floating around in here like a shader that I never really used. It's a compute test, I think. Yeah, the depths hierarchy. The reason that I don't want to look at my old engine is because I did all my synchronization with render passes. Do not recommend. These are all the caches for the graphics pipelines. Yeah, GLSL test. What is this? Nafi... What the heck does that mean? Okay, so it's just a typo. So what do we have here? So Vulkan, so this is for voxel stuff, obviously. What are we doing here? I remember this being a test, but I don't remember exactly what it did, because I never used it. And it was never brought up either, when I was learning this for the first time. So yeah, we have a buffer. I think this is just trying to render voxels as 3D images. Let's see the position. Is it 3D? Yeah, it's 3D. Alright, so we won't use that. We just need to create a program that takes in a buffer and does something with it. What is the simplest way of doing this? Okay, let me think. Is it worth just trying to hack in together a particle system? To do this? Or should I try and do something simpler first and then do that? Yeah, let me think a bit. Okay, so... I just want to remember how to do pipeline barriers for these things. Yeah, so we just take the depth image here, we turn it to general, then we spit it back out again. This compute shader. And then we transition this to a shader read. I can't remember what this did. I'll look at this function in a minute, but okay, so we have two different issues here. We've got to make a now obviously the problem I'm trying to think of is also trying to get this to work with a GPU and a compute path. Sorry, we need I think we're going to have two different command buffers here. One for a compute and one for graphics. They need to work in parallel with each other so they don't block each other. When I set up memory barrier pipelines, they are global to the queue. So if I set up a memory barrier pipeline in the graphics queue and then I throw in a compute shader as well, it's going to be no ops for most of them. So I think it's okay actually. But what I don't want to do effectively is block graphics commands because I set up a memory pipeline barrier for a compute shader buffer thing. Now, yeah, the memory pipeline barrier, I think it's okay actually. But it would be nice to at least put the queue. I think how is this done? Is everything just in one queue? Yeah, I think it is actually. We just have a generic command buffer, I think. I don't think we have separate. And I think if Arseni's done this, and he's also done it with meshlets, then I think adding the complication of adding a second command buffer here, where the memory pipeline barriers are not going to be applied to some. The synchronization is going to get even harder, and I'm going to have to do some semaphore stuff perhaps at the end to make sure things are actually synced. Meaning that I don't think the increased parallelization of a compute shader is going to be worth it, perhaps. I could be completely wrong with that, but the memory pipeline barriers are kind of just going to skip over the graphics anyway if they're not interacting with it, because they're going to be no ops for their particular pipeline stage. Okay, so I think that's good. I think I've justified to myself that we can use the same graphics pipeline, same command buffer. And we just now need to make sure that our VK draw indirect count. Okay, so that has a second buffer to it, which is kind of difficult to track. So we have two buffers here. We have the draw call buffer, and we have the draw call count buffer. As well, when you use this guy. And obviously this is for... Do we have a non-mesh shading path? Mesh shading enabled. No, okay, so this is for the non-mesh shading path. And it looks like we can use the same structs for both, assuming that you've constructed these properly. And we count the number of draw calls, which is important because if we've reduced the number of draw calls based on culling, this is what this is for. I'm not entirely sure exactly what this... So that's the count. That's how many draw call counts we have. These are the actual draw calls. Right. And then we have a vertex buffer. These all get pushed up in a push descriptor. A push constants thing. We bind the index buffer, which is just, you know, it is what it is. Index buffers are index buffers. And yeah, I think we're chilling. So what the real problem is if we do something like a view frustum call, we actually just need to make sure that these two are updated when we do that via the compute shader, and then we trigger a view and then we trigger the indirect draw call counts. The problem is how does the instance rendering gel with this? So I have instance rendering right now. The thing I don't know how to do is combine them. Which is tricky. So, okay, let me think. Interesting that we begin and end rendering with a particular pass. That makes sense. Ah, right, interesting. So that's how our passes are done. Did not know that. Oh, actually, let's just for render. Do we use render more than once when we call this function? Yeah, we do. Okay, so we have multiple different renders, and that's for the early and late, and that's for view frustum culling. No, that's for that's specifically for using occlusion culling for meshlets. That's not actually anything that's going to be that useful for what we are interested in. So let's go to cull. Actually, I want to see this. How does this work? So we set up the pipeline stages I think that we're going to use based on so we need to wait for, I assume this is a source stage that we need. That means we need to wait. Is it wait for? No, we wait until, right? And then destination is when we finished. I'll have to look at my notes just briefly on that. That's often a confusing point for me. So that sets up the pipeline barrier. VK command, VK fill buffer. Huh. So that's the buffer count. So we need to set up a pipeline barrier for this, I assume. And then we do another pipeline barrier. We fill the command, we fill the buffers apparently. And we bind the compute shader. Okay, so this is the... Okay, so this is a homogeneous, I assume. Ah, okay, so this is the dependency thing. So that's the type of memory barrier that we've got. Whether it's image, buffer, or what, you know. Then we have this descriptors. Is this the thing? Oh, it's just the push descriptors. We push these up, and then we can access these buffers. Do we use the buffer device address here? So in the push descriptors, we're in general again. I think that's because we've got so many things here for the info type. Yeah, okay. So this is our cull program. And if I go to our draw cull, which I assume is this, we have a we just need to create a buffer. That's the actual. What is this for again? Is this for mesh shading? I hope. Mesh draw call. Because there's two different types here. Like a draw call cull based on that isn't mesh shading related. Doesn't have as many arguments, I don't think. But I can't remember the buffer type. Hang on, let me so when we're doing this, we've got to make sure that we're not copying the VK indirect draw call that's for meshlets. Yes, so indirect draw call in here actually does all of them. We need to make sure this is the thing that we're going to deal with. Index count. Ah, okay. Here's the instance count. Interesting. So we can actually store the instance count, pass it up. But the thing is, oh, we've got to work out what the instance count is, and then cull them based on a reduction. So I assume the instance count. Hang on. If we go back to our shader, instance count 1, yeah. Which is kind of tricky because okay, so I think what we need to do is understand VK indirect draw calls plus instance rendering, like the theory behind it, because as soon as we start to do something like particles and stuff, we need to be able to say if it's alive or dead. So we need a way to like turn it off. And even if we use this system that we've kind of worked out here earlier, right? We still need to build up this buffer and then like pass it around after a particular action has taken place. So then we can instance draw and use command and use indirect draw calls on the GPU for our particles per set. I think we would do a draw call per set or something like that anyway. I don't know what's like how much we can abuse this. Like, can we get like 10,000 particles in a set, 100,000 particles per set, you know? I don't know. Like, when does one draw call start to slow down things versus breaking up the draw calls? I don't know. But I think at the very least we need to understand the indirect draw call count, the indexed indirect draw call count, the buffer that needs to go there, and what we end up filling up with that buffer. Fill that up in a compute shader, even if we fill that up exact. Yeah, so our goal is to fill this up exactly as if nothing has happened. Pass that over to an indirect draw call, and then just draw one thing. That's what we're going to do. That's the task. Cool. I will pause that to ask you to help you out there. Hello. I'm struggling with tutorial hell. Any advice? Yes, tutorials are very good at teaching you what I would call one topic. Think about it. Have you ever heard of depth first search versus breadth first search? Tutorials do a depth first search effectively. So they go really deep into a topic, right? Now, the problem with that is as soon as you start to go laterally in a direction when you've gone deep, you end up getting stuck because you can't find your way through. And then what ends up happening is you think, oh, all I need to do is go and do another tutorial. So what I'm going to do is go do another depth first search of knowledge, another depth first search of knowledge, another depth first search of knowledge over and over again. And you have these like really deep fissures into like what the programming space is, I guess. You can imagine it like a general like blob of data. And you're kind of going in, like stabbing holes in, trying to get through. But what you really need to do is have a breadth of knowledge that you can have as a foundation. And I set this up in a way that you may think, okay, so what's the depth of knowledge that breadth of knowledge that I need? So you need a shallower breadth of knowledge that you can rely on. So if let's just say you do a tutorial, right? And I don't know, you learn how to make a website that does login screens or something. Like if you don't know JavaScript well enough that you can start modifying things, then you're going to be stuck. So you need like a general programming, like language programming knowledge base that you can go from. Or if you want to do graphics, you need a general graphics knowledge base rather than just going straight deep into something. And the way to do that is just make sure that you have a breadth of knowledge. Now, I would say, I've said this, I think, if you're learning C++, for example, I should be able to quiz you at a junior level on C++ for like a job interview. And I have this list in my roadmap. I don't know if I've still got it. So this is what a breadth of knowledge would look like, rather than a deep knowledge, right? So in C++, this is only for C++, you know, apply this to your own situation, but basic types you should be able to know: int, floats, doubles, all control types, if, switches, all those types, all different loop types, do, while, for, data structures for STL. At the very minimum, you should know, I think I should add arrays, standard vector, standard stack, standard map, standard unordered map, dynamic memory, how the heap and stack works, pointers, what pointers are, references, double pointers, pointers to references, all cast types, C-style casts, static, const cast, dynamic cast, etc. Arrays, static and dynamic arrays, maps, unordered, and what I'm talking about here is the actual data structure behind them, not just using these. You should know the data structures and algorithms behind data structures, you know, ordered maps, queues, and stacks. You should know functions, classes, and basic structs. You need to know the arguments, pass by value, pass by reference, pass by pointer, pros and cons of all these approaches, preprocessor things like macros and defines, all the 3 different variants of static, learn what inline does. I actually learned what this yesterday, just kind of forgot what it meant. At least the singleton pattern, I think you need to know, is a design pattern. You need to know inheritance, polymorphism, composition, object-oriented programming, for stuff like is and has relationships and differences between objects and that. You need to learn how to debug your program. You need to at least know breakpoints. You need to at least know one debugger. You need to know common runtime issues like what dereferencing a null pointer does, read access violation, write access violation. This is just going to help you in general for debugging. You need to understand basic constness like const cast, const functions, sorry, not const cast, const functions, const pointers, const references, const values, and const expert at the very least. You need to understand how to handle exceptions. You need to understand the static asserts and runtime asserts, learn the differences between the compilers. Basic templates, nothing crazy. You should be able to write a class template and a function template. You need to understand lambdas, libraries, static and dynamic. You need to know the difference between static and dynamic libraries, what the size of operator does, structs, classes, how big they are, you know, what that means, like how big something is, overloading operators. You need to know how constructors and destructors work, all the scope types, file I/O, at least have written a medium-sized project, understand your IDE well enough, and understand computing at some level, like what memory is, how the CPU, what the CPU is doing. That's what I would say. That's what I would say is like a breadth of knowledge that you would need to have a foundation for your things. Having small projects goals helps 100%. So that's what you should be learning, in my opinion. Hi, Botred. I would say I know almost all of that list, but maybe not at an optimized level, as you know. I'm stuck with perfectionism, and it hurts me, I think. Yeah, I should be able to quiz you on this, right? So a question that you should be able to answer is like, how big's the stack generally on a program? How big's a pointer on a 64-bit operating system? What does const expert do? When should I use const expr? When does const expr not work? What's object slicing? Why is inheritance sometimes worse for program design? You know what I mean? Like that's like I should be able to quiz you on these things, and you should be able to be like, yep. If you have that foundation of knowledge, then going forward, the next step is to figure out like program specific stuff, and it's like the same level of knowledge needs to be built off. So, for example, if you're like learning, I don't know, graphics, for example, I don't know, like I need to basically do the same again, but for graphics. I honestly don't feel like an expert, so I feel, you know, I feel like you know, I feel like I'm not like super qualified to give like everyone like how to get expert and stuff like that. But I started Vulkan engine. I did a triangle shard script. Okay, well done. Congratulations, by the way. But yes, for graphics, it's like I should again be able to quiz you on. So like, okay, I have a bug, and I have set a value to say the frames in flight are 3. And the swap chain images index is 3. I've hard-coded those values. What's wrong with that? Can you explain why setting the Vulkan image index count equal to 3 is a bad idea for acquiring an image? Like, stuff like that, right? Like, that's like a good... If you can answer these questions, like, you'll find that tutorial hell will start to dissipate because you'll be able to be independent. What I'm trying to say here is like a breadth of knowledge across these domains is useful. Triple buffering. Well, the answer to that question is you don't know how many Vulkan swap chain images are going to be on a GPU. That gets acquired. That's part of the setup of setting up the swap chain. So if I set that to 3, that might fail on someone else's computer. The frames in flight and swap chain index images are separate. You can set the frames in flight to like whatever you want, but the Vulkan, you can have like, say, I don't know, 2 swap chain images, 2 frames in flight and like 7 swap chain images, right? It just depends, right? So that would be like a potential issue that comes down the road, right? Can you show the project like how much progression's going? Currently I'm studying at the moment, but yes, I can. So we haven't actually done much yet. I don't know where we're up to, bot red, but we're trying to implement indirect draw calls so we can do like advanced particles in like an efficient way. So that's what we're trying to do right now. So that's where we're up to. Hopefully that's okay, bot red. So that's like that. What I'm trying to portray here is not like, oh, if you don't know that specific thing, then that's why you're stuck in tutorial hell. It's like having like this breadth of knowledge is good. Taking notes, in my opinion, is a really good idea. So it's not like the specific thing that you're missing that's an issue. It's like when people have tutorial hell, they've gone like that. Maybe you know something really advanced, right? Maybe you know something that's like super that I don't know at all, and I'm like, wow, I'll be super blown away by what you know. But then you might know people stuck in tutorial hell often know something really advanced but don't know something really basic, and that kind of trips them up. So when they write their own Vulkan renderer, for example, keep going with the triangle, by the way. Yeah, that's what I would do. Yeah, Obsidian is fantastic. Yeah, keep going with Vulkan. Keep yourself going. Keep going with how to Vulkan. Yeah, I take notes. And then I do revision every day on this. So it's a constant struggle to get good. It takes hours as well. I don't know if chat agrees with me with that. Feel free to help this, give your own opinions. Thanks for the help, buddy. Really helpful. I appreciate that. Yeah, you can definitely do it. By the way, this is not like impossible to learn. Like it just might take some time. That's all. Anyway. Yeah, so what I'm going to do is build a buffer and an account buffer and then just render that same thing. So our goal today is to build a compute shader with the same graphics pipeline. Be happy with the bare minimum law. Yeah. Right, okay, so we're going to be... And don't trust yourself when you're tired. That's good advice. So what we're going to do is... Excuse me. Is we're going to start reading the spec, I think, on this indirect draw call count. Don't trust it to lie. Yeah. I believe you on that one, to be honest. I like that. But yeah, beginner hell is all about, like, you've learned some advanced stuff, but you don't know the basics kind of stuff. That's all it comes down to, in my opinion. Again, people can... I think that's the way to get out of tutorial hell. So that means stop following tutorials and make sure you know the breadth of knowledge you need. Or if you are following tutorials, make sure it's like basic stuff. And take notes. So when I say don't follow tutorials, I'm not saying the beginner tutorials. I'm saying like advanced tutorials, like how to do mesh shading and do occlusion culling with meshlets. Right, that's like too advanced. That's like sleepers for the weak. That's like a bad idea. Anyway, right, let's so we're gonna make a like a pointless what am I doing? I'm trying to grab so we're gonna do this as, yes, draw command to draw command. So we need these two, and this is in the compute shader, and everything else I assume that we don't need. Yeah, okay, so the binding just has to be different. And now we just need to work backwards from here. Yeah, draw call data is for the culling. Yeah, okay, so mesh draw command. We don't need to do an offset of, because I don't think we're going to do meshlets. If we do, then we can just do meshlets later. Draw visibility, what is that used for? I don't know. Anyway, yeah, so we just need these fellas in a compute shader. So let's write a compute shader. Our first baby first compute shader. Well, I've already written compute shaders in the past, but I wanna have a target today that we can actually achieve. So we can do an indirect draw call on a particle, which would be great. Because then we're away with the races. Then it's all about implementation, like implementing a good system to do that with. But first things first, we need to be able to do that. All right, so we want a comp shader. What should we call this? Particle comp? I don't know. Right, I'm gonna make a Windows sound effect. Let's say particles plural, because eventually we are going to use this for our particles. At the very least, we need to have our particle indirect draw call set up. And we're going to take notes as we do this. This is going to be not immediately, quickly. I think if we get this done today, that'd be good. Reload. Right, let me just check something real quick before we continue. I think what I'm going to do as well, just a 32 by 32. I don't think there's anything complicated I need to worry about. So yeah. Let me just check something real quick, make sure the Discord's all happy. Cool. Fantastic. Alright, let's get back to it. Let's get our compute shader, which is here. It's going to be the simplest thing ever, but we also need to make sure that this makes sense. So we need to be inspired by this. Oh, okay. Inspired by renderer. So we need these two. Binding, I have no idea yet, but we also need the mesh draw struct. Which is the 5 integers that we have from where is that? It is, I think I've got it open here. No. Give me a minute. I need to yeah, let's just make this bigger now. Okay, so VK indirect indexed draw call count. Right, said that slightly wrong, but there we are. So for our buffer, yeah, we have that. No, that's not what I wanted. What do I want? I want this actually. Right, I could just go to meshes, I guess. Or I can ask Copilot. Yeah. Sounds great. What's the... It's not that. It's not draw call data. It's... Yeah, so that's what I need. Oh, fantastic. So I set this up. Oh, yeah, that's true. We need, if you do... Yeah, we need draw ID as well. That's super useful to have that. Now, we don't need this as mesh shading. Yeah, because if you have the draw ID... right, so that's the... We have that. Now we need the... let me just try. Isn't it layout? 32. I can't remember, so I'm gonna try and remember without. Oh, Y. Z. Right, so. And let's get out of here, thank you. Yeah, it is layout. Oh yeah, in. That's the thing I was missing. In. This is 1. You just multiply by 0. That would not be good. And then I'm just going to take some inspiration here, aka just copy and paste. So what we're going to do is that idea, and I'm going to take this. Where's this come from? Add a draw call count. Fine. That's fine. I think DI is, it's, I don't know why it's all, why is this undefined variable? Whatever. So where's this used? Invocation, which is great. Need that. So, index count. Dang it. Immediately stuffered by this because I need to know the index count. What would that be? I mean, I could literally just copy and paste this shader in, but I think it kind of defeats the point of trying to do stuff properly. Even though I've kind of already started, but I don't want to keep going. What would this be if it's not? Let me look at my... Yeah, so what I'm going to do is... I need to learn right now. That's what's happening. I need to learn. So the index count is obviously the total indices, but I don't know how to get the total indices in into the shader. Well, why aren't you using Linux? Because most gamers are still on Windows, but this game engine does run on Linux. It just gets developed mostly on Windows, and then I get it running on Linux, and then clean up some stuff that only Linux can do well. As the MSVC compiler is often not that good. But yeah, that's generally why I'm not using Linux. Until the mass exodus has finished with gamers, then to Linux, then unfortunately I'm still stuck on this platform. He's going to help me test my game for Windows, that's why. Yeah. Yeah, so there will be an ELF binary for you guys to play eventually. Right. So So I'm getting a bit hungry. Guys, do you want to, in chat, if you've got like a good programming / game development video that you think might be cool to watch while I eat my food, that might let me know, and I'll put that on. If you have some YouTuber in mind that's just like a good YouTuber that you like, feel free to suggest something. Because what I usually do for those who've never been here before, is I put on a YouTube video and I go on push to talk for a while, meaning that you won't be able to hear me talk, but also not hear me chew. I will still reply to chat, but I assume no one wants to hear cutlery and me chewing down a microphone for 20 minutes, right? So, because that's just gross to listen to. Anyway, so yeah, if you've got like a cool vid that you want to talk about, that's like related to game development / programming, that would be good. Either I always find them if you don't have anything in mind, but if you have something you want to show me, yeah, feel free to suggest something. You can't post links in the chat, so if you want me to search it, just tell me what I need to search, and I'll give it a search, so you can watch it. That's just like a YouTube moderation thing to stop scammers, I think. About the links, anyway. Anyway, so I'm gonna keep going for a bit longer. Get your mind off game development. Look up, want to be famous, just be racist. Okay, that sounds a bit edgy, that one. Yeah, we don't want to. It sounds a bit political. I don't want to turn this into a political stream by accident. Okay, so yeah, what we need to do is get rid of this. And I think how am I going to learn this? This is kind of interesting. Indirect draw calls. How do I learn properly how to do indirect draw calls? Let me just do a bit googling. So GPU driven renderer. Okay, so I'm blinded there. Fantastic. It looks like it's good. So even if this is for, I don't know if it's for Vulkan. I don't know what this is for actually. I didn't even check. So what do we have here? So I think it's like a generic. An overview of GPU-driven rendering in my renderer. Okay. Right, I think we should probably go through this actually then. This is probably more accurate, yeah. This is going to be way more useful. So what I'm going to do is... Because we have binders already, so we don't need to worry about it. I just need to know the commands. Engine architecture, draw and direct. Yeah, so we're gonna go through this, I think. Wishbones makes some entertaining devlogs. That sounds good. Not very technical though. It's fine. As long as it's part. I want to make sure that one, the video is like relatively on topic, and two, oh, this chapter is outdated. Boo. Right. I think this is fine. Yeah, what I want to do here is just, yeah, so what's this compute shader thing about? Yeah, I'm just trying to find resource at the moment. That's best. So we got 2 here. It's quite good. What is this? Oh, it's the same thing. Yeah, okay, so we got 1,000 different... Okay, right, let's just go through this real quick. I'm just gonna scan through this. You know what? The first thing I need to do is look at my notes. I think I've actually got some notes on this as well. Oh, right. Sorry, I'm looking at my notes, aren't I? This will be in Vulkan. Yeah, so I'm going to go through my notes first and then kind of work backwards. See what I already have written down. Depth, subpass, command buffers, indirect draw calls. Alright, so I'm going to read these. Yeah, my stomach is screaming. I'm trying to put it off a little bit because I don't want to be like hungry by the end of the stream. Oh, is that? Are you referring to the bird? Can you hear that bird? By the way, that bastard bird! Holy moly! It just sits there and screams its head off for hours straight. I don't know what it's doing. I feel like it gets in a bush and just screams over and over and over again. I mean, I don't mind it, obviously. I just think it's kind of funny. Just imagining, like, a bird getting into a bush and then just going, rah, 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 over and over again. Another day of screaming done. I was a very productive bird. Anyway, what are indirect draw calls? Indirect draw calls use command buffers. So this... Sorry, indirect draw calls use a command buffer. This is a buffer that gets written to in a shader and then reads out again in the shader. This command buffer, I think. Oh, draw command buffer. I see. This is known as GPU-driven rendering. The idea is the GPU is driving the rendering. and indirect draw calls is to offload draw call generation to the GPU. This allows us to call geometry on the GPU, which can reduce the amount of draw calls because we are allowing the GPU to generate draw calls. Okay, cool. Advantage of indirect draw calls. A common idea when it comes to rendering, when you iterate through each model in a scene, you bind the resources such as a vertex buffer, index buffer, descriptors before the draw call. One thing to note is that this isn't free in the command buffer generation, such as bind. Okay, so yeah, it's just an overhead thing. You can use indirect draw calls instead, introduced in Vulkan 1.2. Indirect draw calls instead of what? Indirect draw call count, I think I meant to say, which was instead introduced in Vulkan, which queries the GPU's buffer to get draw parameters. Okay, you have two advantages here. Draw calls can be generated on the GPU, such as in a compute shader, which can do additional work to call things. I hear it all the time, lol. I feel like it's coming from my outside, yeah. Yeah, it literally is, yeah. Angelica is the cutie, gets it, yeah. I don't know what it is. It's like a probably a swallow or something. Not a sparrow even. Just gets in a bush and just starts screaming. Using an array of draw calls can be called once, reducing command buffer overhead. Okay. Let's go to the next thing. Setting up an index draw call. Now, when you want to use an indirect draw call, you first need to use the struct. Okay. Draw indexed. I should have read this before. This provides the information of the vertices and indices. Okay. Since you can offset into the index buffer and vertex buffer using the draw indexed indirect command after 9 million. Hang on, let's read this. It's kind of funny. So 9,999,999 homeworks. Well done. Anyway, since you can offset into index buffers and vertex buffers using the draw indexed indirect command struct, you can make a huge index buffer that contains a bunch of models in the scene, bind that once if the total number of vertices exceeds 2 to the power of 16 or 2 to the power of 32 in the draw call. If the total number doesn't exceed these numbers. Okay, yeah. This only works if each portion of the index buffer is 0 indexed. Meaning if each model has, say, index buffer of 0, they can live in one index buffer. Got double left, fair enough. Okay, this is important. You don't need to create the VK draw indexed indirect command on the CPU, but you don't create it. Yeah, okay, you don't create it there. The whole point is that you fill it up on a compute shader, then pass up the draw indexed indirect draw call in an indirect draw call in an indirect past. Okay, which is only read and then generates the draw calls indirectly. Okay. Oh, I had it all here. Oh my goodness, I had this here the whole time, bruh. I should have just looked at my notes. Holy moly. Right, I'm gonna pick a video. Probably not the. Cool. Let's pick because I am getting hungry very quickly, as you can probably tell. Let's put on a video for us so I can eat food. So Wishbones, I've never heard of this guy. But yeah, thanks for the suggestion. I'm probably gonna, yeah, probably gonna avoid the other video. Hopefully that's okay. Angelica is a cutie. Is that right? Wishbone's game dev, or devlog, I guess. Let's check out what our fellow YouTubers doing. I've never heard of this guy. Wow, he's very popular. Horror games get darkness wrong. I fixed it. Devlog. Okay. We might watch 2 because I made Mario 64. Okay, that's kind of funny. Alright, right, so what I'm going to do is just let his video play just briefly, and just to get the audio right, and then I'll restart the video. Grab my food. Yeah, should we watch that one? I kind of like that.
Google Translate
Right.
is great, unless you use it back and forth like 100 times, after which, whatever you originally said gets sent straight to the Shadow Realm.
That's about right.
And I want to make Mario 64 to test whether it's really possible to extract any meaning from those
okay,
words.
that's probably
the
good.
only rule is that I must...
Okay, I'll do that. We'll watch this silly video, which is kind of fun. Thanks for the suggestion. I'll be right back. I'll just get my food, so I don't miss anything. It's not that loud, by the way. Don't. Right. Okay. Yeah.
Google Translate is great, unless you use it back and forth like 100 times, after which,
Okay,
whatever you
that should be
originally
good.
said gets sent
Yeah,
straight
yeah.
to the Shadow
Okay.
Realm.
There we go. Yeah, I didn't realize. I thought my voice was loud, quiet. I was trying to compare it to my voice. So yeah, I'll be right back. Actually, I can just talk to you from here, I think. I'm starving for some reason. Okay. Just getting the cutlery. And we'll slam to get this video. Enjoy the vid. And like I said, I'll go to push to talk so you don't. I know, yeah. It's kind of a fun video, this one. Alright, I'm gonna go and push to talk so you don't hear me chew or cutlery rattling and that kind of thing. So yeah, let's enjoy.
Google Translate is great, unless you use it back and forth like 100 times, after which, whatever you originally said gets sent straight to the Shadow Realm. And I want to make Mario 64 to test whether it's really possible to extract any meaning from those words. The only rule is that I must listen to every single instruction given to me, no matter how redonkulous it sounds. Now, you might be thinking that I stole the idea from this guy, but that's just not true. I actually stole it from this guy who makes recipes with Google Translate. We should first start with the man himself, Mary. Mary's beautiful face was everywhere. Alright, looks like we're making Mary 64 today. Head, smooth and slender, more than a third of its length, giving a rotated PC shape. So I modeled my PC, turned it on its side, smoothed it out, and Mary's gonna have one weird ass head. His green eyes are charming, his size and curly hair, and his ancient beliefs. With all those ancient beliefs, I bet Mary has a lot of wisdom to spill, so I'm gonna give him a beard. You guys know I suck at drawing, especially with my vertical mouse, don't ask, but it's not that bad. His nose is straight and slightly tapered for a low profile that makes it easy to move. Now while this does seem weird on the surface, when you really think about it, with all the moving around that Mary does, you need an aerodynamic nose to maximize performance, it's just that simple. So I took inspiration from Formula 1 cars in my design, and voila. And so that it can be opened easily. Okay, if you insist. I insist. Alright, well that's settled. Mario's body. Yes, Mario should be young and have 3 horsepower. To run, the legs must be strong and strong. Neck! I mean, for sure, you gotta have some strong legs to have 3 horsepower. The body is fish or fish-like and larger than a horse. This makes it strong and functional. No way he's larger than a horse. Well, that explains the horsepower. I'm not really sure how to tackle this fish problem though, because he's still like a human, so I'm just gonna put fins all over his back to get those sweet aerodynamics. Size, like green, but bigger. His dark tanned skin ends with the letter M, and his hair is blacker than his red hat shirt. Well, can't argue with that. So first we tan him. I'm gonna get cancelled. I think the whole letter M thing alludes to the fact that he's got tattoos on his skin. Now, I've never personally tattooed anyone before, but it doesn't seem that hard, especially because it's just the letter M. Put on your best blue shirt, white shirt, watch, gloves, and black shoes to fight your enemies. Keep it short, sweet, and hearty so that you can enjoy the break. So I went outside to look for my enemies, but unfortunately it seemed that my intimidating presence and my masculine aura has scared them into submission, so I triumphantly went back inside. Your hobbies are screaming, running through trees, and climbing trees. Yeah, they sure are. Ah! Pants appear to disappear on Mary. Yep, I'm getting cancelled. Create a Mario adventure. It gives Mario the ability to run and walk. Suddenly, Mario relaxed and slowly extended his arms like a princess. It, being me, made it so that when he's idle, he extends his arms out in the sassiest way possible, as I would imagine a princess doing it, and it's kinda cute. This seems to imply the existence of a running animation, which, depending on how you look at it, there could be, but we haven't been told to do that. Alright, I think I'm gonna leave Mary alone for now, so it's time to make the iconic castle grounds. Grass is green and iconic, pixels fill its species. Wave at terrain. I've never made pixel art before, but I did try to fill the iconic grass species with pixels, and I cooked, I fried that shit. And so far, you can't tell which game is the original. Build a 50 by 50 foot area of rooms and toilets, like Castle. It's a great game. It sure is a great game so far, let me tell you. Is this toilet building supposed to be in use, or is it like a toilet storage type area? Upon further examination, it says room, so I'm just gonna guess that it means like a proper bathroom area. And yeah, I think these rooms will do, because just like everything I make, the design is very human. And you know, I have to say it's... Sky, such as sky, 3 times, which I'm gonna make using the import free skybox button because I don't know how to make a skybox. For some reason this is going way smoother than I expected, but I'm kinda feeling like that's gonna take a turn for the worse soon. Let's build a castle together. Yep, I was right, that wasn't even the castle. Place it in the bottom center of the map as a marker, 30 by 30. Go to the entrance of the stone bridge over the river, 3 mar. I like how it's giving me measurements now though, because I can actually scientifically assemble the map exactly how it needs to be, according to Google Translate. Though I kinda have to assume that the castle is connected to the 50 by 50 toilet building, which takes up almost twice as much space as the castle itself. Obviously. Now for the river. I don't really know how big 1 mar is, let alone 3, so I'm just gonna give this my best guess. But as always, feel free to correct me in the comments. The tent is 5 meters in front of the metal tent. Mario's journey begins here. The metal tent? Ah, yeah, the one it hasn't mentioned until right now. I don't know what a metal tent would look like, or why anyone would want one of those, so I'm just gonna freestyle this one, and I'll place it where I think it needs to be, and then I can put Mario's tent 5 meters in front of that. And I'm not saying this is the best thing in the world, but if anyone needs a metal tent, bro, hit me up, I'm the guy. 6 trays, 3 food trays, 10 to 15 trays each, and 3 separate trays. Would you like care to explain where? Cause let me do the calculations. Where on God's green earth do you expect me to put 54 trays? I'm just gonna stuff them in the tiny castle for now so that we can't see them. I don't really know who needs all these trays or toilets, but I don't really want to meet them. Put 20 bucks on the card. I only have 16 bucks on my card, is that enough? 10 hide on the ground, 5 hide in boxes, and 5 behind trees, rocks, and shelters. Place the sun near or above the king. Yeah, this is no bueno. When your bucks start hiding from you, you've done something wrong in life. I think it's talking about a collectible system, but it hasn't told me that we should be able to collect them, so I guess they're just there. I made some trees. By made, I mean I stole a PNG, lowered the resolution, and wrote a script to look at the camera, which works optimally when the tree is at world origin, the player is at least 15 meters from it, and there's only one tree. I also added a few shelters, rocks, boxes, and ground. Now, I don't know what king you're talking about, but I'm pretty sure if I put the sun next to him, he'll burn, so I'm just gonna save the king and not do that. And speaking of money, I'm being paid by Skillshare. That was so smooth. Skillshare is the most ginormous online learning community for creative humans with a ton of classes from illustration, graphic design, photography, music, marketing, productivity, game development, game design, level design. For me, sometimes yapping at the camera about games gets pretty stressful, so I've started learning about yoga and meditation with this class. Feel free to join me as I do a headstand for the rest of the segment. I'm also still following along on this learning path for drawing which I mentioned last time Skillshare gave me money, and I think I'm making slow but steady progress towards my goal of not being cheeks at drawing. Learning paths are really cool because you can start from zero on a topic, and I will recommend you courses in an order that will let you master it by the end. There's a lot of stuff here for everyone, and even if you don't know what you want to do, and I will admit I've been slacking off on the knitting, but I do think it's fun to just try out new things that you never thought you might enjoy. It's the start of a new year, so if you want to begin some good habits for yourself, this is a great time to do that. If you want to put some money in my pocket, this is a great time to do that, because the first 500 people to use my link in the description will receive a 1-month free trial of Skillshare. Get started today. Path? Path. The waterfall's on the left, with a waterfall. After hours of meticulous deciphering, I think this means we need to make it rain, but only on the left side of the map. This then caused a waterfall to form, which created the Three Mawr River. Look, I'm doing my best here. There's probably 12 different interpretations of these prompts that I'm not thinking about, but if there's one thing I know for certain, is that this is one of them. The potion requires 8 hands, 12 weapons, and 4 gems. The potion? Anyway, unfortunately for my friend here, I only have 2 hands, so I guess no potion for me.
No, today. Yep. Go hard every day. This is a great video, by the way. This is actually quite funny. I'm just eating my lunch right now, and we'll continue onwards afterwards.
Sucks because I have way more than 12 weapons. Use the caves and rocks on the ground to cover Mario early in the game. And what about the tent? I mean, I guess Mario is camping in a cave, which explains the metal tent, since if the cave collapses, he needs somewhere safe to hide. And it gives him shelter from the rain on the left. In theory. The lore just writes itself. Decorative rugs are bright and sunny, think mountains in green, lakes in yellow, plots of land, a bunch of bugs. Yeah, I think that we have the bugs under control, so let's tackle this step by step. First, we put decorative rugs in the sunny spots. Now since there is rain on the left, we can only put rugs on the right, like this. I spread them out nicely to decorate the beautiful landscape. Next, we make some green mountains, we add some very suspicious yellow lakes, and plots of land. Look, I don't know who's been pissing in the lakes when we have perfectly good toilet building right over yonder. Bro, Mary can smell your bullshit from here. We're gonna find you. Mary's gonna sniff you down. Shiny rocks or bricks. Light up and create a blue swimming pool decorated with floating platforms. Yay, finally some blue water. I chose some nice shiny white bricks. Oh, what's that? Just a watermark. Then I made some iconic swimming pool props such as the bed, the donut, and the round thing, rendered in the greatest geometric complexity that the Nintendo 64 had to offer. Mario lurks. And this is the first change I actually think is great. It would be really fun to parkour across this if only Mary was allowed to jump. This next prompt is out of pocket as shit, but we gotta soldier on cause we're in too deep now. Make a list of measures to protect the environment and start with the botanical garden. Plants and medicinal flowers can be seen straight from a history book. Okay, listen up, here's my 3-step plan to save the environment. Number 1. I've added bins all around the map to make sure there's no littering. 2. Cars are not allowed near the botanical garden or the toilet building. 3. We do not use water bottles as all water is to be taken from the local lake. I put the botanical garden right here next to the lake as I think they would be using that as a water source. Unfortunately leading to the contamination of the medical history book flowers. Geometric shapes and obstacles that float in the air when Mario jumps or falls to be added. I'm pretty sure we've unlocked the ability to jump, so that's nice. I don't know how I managed to do it, but I added so much air resistance to Mario when he's idle that he literally falls like a feather. You can tell I totally aced my physics exam, but I think that it's just his nose acting as a parachute. You act in surprise. Whoa, where have you been? Add a little flower. As Mario runs, place his arms and legs behind him. He dances like a magnet of joyful energy. Turn off the air and water. Well, that took a dark turn. You know what the worst part is? I don't even know if the piss lakes qualify as water, so don't worry, they're not going anywhere. And yeah, this looks pretty good all things considered, and I think it's time for some more gameplay features. Double and triple jump when you want to double. Keep Mario as a new challenge. When you want to play, ta-da! After careful consideration, I think this means that he can only triple jump if he double jumped before. So every second jump should be a triple jump, and every third jump is a double jump, but only if the triple jump before that we can... So yeah, that's an interesting mechanic, I like that. Our hearts are weak, physiological functions. Hope remains alive, and it does not need to stay in the body for long.
I know, right?
Fortunately, since our hearts are weak, along with our physiological functions, I'm gonna have to give Mary very low health. This means that he can die, and in the original, they have a bunch of different death animations, but I'm gonna take a shortcut here, we only have one, it looks like that, deal with it. And then I proceeded to spend exponentially more time making the death transition effect from the original game. Don't let anyone tell you I have good time management. Look, hope remains alive, but it's not going to stay in my body for much longer, so Google Translate better do something good. Focus on stronger and longer hits because you will succeed. Raise the entertainment level. Entertainment tickets. I can't believe Google's roasting my video idea, I thought this was pretty fun. So clearly we need something to fight now, as we must focus on those long and strong hits in order to succeed. Which is why I ran some instructions for a Goomba through Google Translate. Goomba website. Alright, here's the Goomba website, I hope you're happy. The Goomba set is a small white round object that sits for about a minute and a half. The top of the neck should be longer and the bottom shorter.
Hello Heisenberg, how you doing? Just eating my lunch at the moment. We're watching a vid together.
Not without the well-rounded behind. So I guess we start with a sphere, and then we... the top of the neck is longer than the bottom of the neck. So you're basically saying that we have two abstract neck segments, the top and the bottom. The bottom has an unknown value, but keep in mind, the top is larger than that. It's hard to say, but I made it this long, so... And of course, we can't have a Goomba without that well-rounded behind. Just look at that thing with all its 8 polygons. It is brown, just like things that are brown. Whew, thank God for that. I was this close to making it brown like things that are fucking bastard amber. Let's look into it. Give him big angry eyes and large pupils. Easy. Apply a small amount under the eyes for a clearer look. I'm out of what? Eye drops, bleach, may I recommend some lake water? Here's my hypothesis. Maybe we need glasses for a clearer look, right? That looks pretty good. Change the softened bones. Bro, Mr. Goomba is having all sorts of medical emergencies. He can't see shit, now his bones gone soft. Place 2 small flat legs on the lower body. Whoa, look at that, it's actually looking like a Goomba. And bend them slightly. Alright, fuck, never mind then. His mouth is gaping with agony. Toddler teeth. Uh-huh. If it hits a wall or the side of a house, it will break. When Mario gets close, he must approach slowly to scare the Goomba away. Now, I haven't played too much Mario in my time, but I'm pretty sure this is totally accurate. So clearly, after about a minute and a half, he gets up and starts hitting shit until he breaks. But you see, if Mary can sneak up behind the Goomba undetected, he can scare him away, it's genius. The law of human relations. When Mario falls, the Goomba takes a breath for a moment and then disappears into the sky of tombs and stars. Aw, poor Goomba. When Mario falls on Goomba, Goomba first thinks about his life, takes a deep breath, poof! Just like that, he's in heaven. That's so sad. If Mario touches the bottle, he will be injured or die. Ah yes, the bottle, the famous Mario bottle, which kills on contact. Alright Mary, you better not touch that bottle. Fuck. Place the Goomba near an open area or shrine where Mario can crawl and attack. Mario crawls now? No, I'm not making an animation for that. I'm getting cancelled. You can play this game by starting with 2 to 3 bombs. I don't think I will, as I only have enough materials for 1 bomb and I already have a date set on which I'm going to use it, so unfortunately we're going to have to ask someone else. Now, just to jog our memory, Mario 64 looks like this. So let's see how Arwen plays. Welcome to Mary 64. So I do think that Google Translate can make a game, but it's just not going to be the same one you started with. So to answer our little experiment, kind of. Now, unfortunately, I can't release this because Nintendo will put a bomb in my mailbox, sue my entire family tree, kill my dog, demolish my house, and kick me out of the country, so this game's gonna live on in our hearts. And on Discord, just don't tell Nintendo. And I Google translated my outro for shits and giggles. So, thanks for watching the video, I hope all is well with you chicks. He runs away.
That was a funny video. Thanks for the suggestion. Right, I'm just gonna clean up, and I should be back to development. I just had a thought. So Heisenberg was sleeping. Well, have you had a good night's sleep? Anyway, I think to do these particles properly, we're gonna have to do something before particles. We're gonna have to move to a GPU-driven renderer. Due to the fact that we're going to have to use compute shaders, they're going to have to update the particles. If we don't have a GPU-driven renderer before that point, then it kind of like defeats the purpose of having this idea, right? So I think we're going to have a GPU-driven renderer, which is going to speed up everything, but we've got to make sure that we don't break everything at the same time. So yeah, I think to do that, we're going to have to be very careful, meaning that I'm going to have to like take my time. It's morning, wake up. Yep. Meaning that this might be a bit of an odyssey. I might have to do GPU-driven rendering first. And I think to test if this works, I might even just do view frosted and culling. Add that in, because that's quite easy to do. Because otherwise, if we just do GPU-driven rendering without any culling at all, it's almost like completely pointless. We're just not generating the draw calls on the GPU. Regardless, we're going to be moving that over. The problem is with that, we have it increases the complexity of the draw of the render loop. Because we're going to have buffers that get filled and all that kind of stuff. So yes, this is going to be a bit of a rewrite, I think. But I think I was going to have to do this at some point anyway. So yeah, it just so happens that to do things efficiently, we need to do basically do this all in one go. Right, okay, so I'm just going to clean up. I'll be right back. Back from the dead. Right, so hopefully that's chill with everyone. GPU driven rendering. So this might be like a multi-long like day thing that we end up having to go through. And yeah. So for those who don't know, what does a GPU driven renderer mean? It basically means that the GPU is driving the draw calls. I don't know why it's called driven renderer, but we try to basically build up buffers on compute shaders. Then that gets passed to a different buffer, and then then we run the draw calls. I think on another compute shader. I can't quite remember. So we're just going to try and do the simplest thing today with GPU driven rendering. We might even have to take a step back with our renderer. But yeah, so that's what I'm going to try. So we're still going to have a buffer device address accessing things. I don't exactly know. We just got, yeah. Alright, so, where were we up to? Let's start our timer again. One second. Let's get the music back up. I don't know why today. I'm really actually... Just pause that. I'm dead hungry. Yeah, so I needed that. Apparently it's supposed to be a heat wave today, and it's actually quite cool. I'm surprised. Pleasantly. Okay. So, to use indexed indirect draw calls, we are assuming that you have a traditional setting up. So you have, sorry, we're assuming you have your foundation of this. What? Okay, let's have a look. Oh, right, yeah, that's what we just read. These are the steps that you need to draw. These are the steps on how the indirect buffer would work for a compute shader that builds up a draw indexed indirect command. It first writes out the buffer in the compute shader, and then is read in on a vertex shader. I see. It's important to note I've left in the barriers because it's important when we are working with buffers. Okay. So VK's, okay, so I kind of use the old setup here. Oh, I see. Okay, so these are the I don't know what rasterization stage are, but I know where to get that from. Oh, I see. So these are the access masks. I assume it's source and destination. Okay, for some reason we have a pipeline stage here. So we do a VK dispatch. Group, get group count. Don't know what that means. Okay. This is very vague because this is a very vague compute shader, but it's important to note that it's important to look at the bottom of the shader. Okay. That the buffer's own. Okay, so the buffer's only write only. Okay. Vertex offset. Ah, right. Okay, so we need to pass in. I understand. So we have mesh index. And then the... okay, so the draw... Right. Okay, so we need the mesh draw as well. Okay. That's the thing I was missing. Cool wave. Yeah, exactly. There we go. And, yep. So what we need to do is get the data, not just also for the command buffer, but also the mesh draw data. So as far as I can tell, if I go back to my so we're not going to try and be fancy yet. We might just do an indirect draw call and then an indirect draw call count. And then we just do a size of draws. What's that? Okay. This is actually quite well written, actually. So in our draw data, is that for, hang on. So our mesh vertex count, right? In here. Go to mesh, please. What are we looking for? We're looking for mesh draw. And so, okay, so meshes equals helps locality in the vertex offset. I don't understand. I'm a bit stuck here and I don't quite know what to do, but that's fine. That's when I'm feeling like this, you got to remember that I'm improving at my maximum speed, right? It's one of these things where it's like, despite being confused and feel like I'm not getting anywhere, this is what excuse me, pardon me as well. This is what neuroplasticity feels like, confusion and probably mild frustration. So if you're ever going through the same thing, just let you know that all right, so you know it's actually a good thing. So meshlets we don't ever deal with. Draw call data, draw index offset. Okay. I don't think I can just put. Hang on. If I open up the what was it? Yeah, that has to have an index count. That has to have. I wonder if there's an indirect draw call that isn't indexed. Does that exist? Like just an indirect draw call rather than an indexed indirect draw call. Yeah, okay. A non-indexed indirect draw call, so we don't have to deal with the command. Okay, so right, that's good. That's going to help us a lot. Very specific type of draw call here. Can't touch this. As said, when I implemented this, I just used the normal draw calls with the number of vertices. Normal draw calls with the number of vertices and vertex pulled the index and vertex data. Yeah. I think that's what I'm going to try and get to. So we're going to try and implement this. I think this is the simplest thing. So we just need the command buffer, the buffer itself. How do you run this in the shader? So then you just get the draw ID from the draw commands. Okay, so that's how we're going to access it via our buffered device address. Right, okay. Mesh draw commands, let's see. Okay, yeah, so that needs to be in the... So the first thing I'm going to try to do with this is the particle, the billboard even. So I might even, hang on, yeah, what I'm going to do is kind of, so I don't break everything, I'm just going to add like a new shader. Hello, Mabdo. I don't think this is as complicated as I initially thought, if I just go one step at a time. We might go to a full GPU-driven renderer by the end of this. So... so I'm going to say new. And I'm going to add this to our... That's my Windows sound effect. And then I'm going to throw in literally the same shader into here. It's going to do exactly the same thing. It should compile, and then we should start modifying it. In particle, okay, so particle 29. Oh, that's true. Yeah, we don't. Cannot add. All right, so we have a task count. I don't think exists. Task offset. Yeah. Okay, so we just get these guys. Task first. Instance. So we don't want to do instant rendering. I think we can safely say that the index count is, because we know this already. Wait, is there a different buffer for this? Hang on. So okay, it's exactly the same. Draws are executed by this command with a buffer starting at an offset, increasing in the stride. Okay, next for excessive draws. The parameter of the draws are encoded in VK draw indirect command structure. Right. Okay. Yes. Yeah, so we have less to deal with. Okay, so maybe I should do. The weather is fine. It is, yeah. It feels completely fine. Okay, so let me think. Okay, right, if we don't have an index count, then we don't have an index buffer. Meaning that this is only going to be relevant for indirect draw calls that aren't indexed, which is fine, because... No, it's... What I'm trying to get at is... Maybe I should do everything as an indexed draw call, so the buffer creation isn't super complicated, and we don't have another type of indirect draw call buffers that live on the GPU. No. I think how many bindings that we can have that use a buffer device address are completely fine. Because we're doing this by a push constant, and we can just push in. It's just the compute shader that fills up this is just going to be arbitrarily limited. No, not limited. Yeah. Okay. So. Yeah. Let's simplify them, and we can always change it later, right? So I'm going to do this. Probably call this yeah, draw commands. I always like to do it like this. And now we don't have to worry about that. We have an instance of 1. The first index is 0. And the vertex offset is... Right, so I think it's just 0, 0. This could be 6, though. I'm not entirely sure. Let's look at our regular draw call. So if we go to game, and we go in here. So we have an instance count of 1. We have vertex count. Yeah, what's that? What I don't understand is what's the vertex count? If we go in here, no, if we go in here, so we have vertex offset, first instance count. Yeah, so we need to know what these do, I think. Oh, we have vertex count right there, literally. How come? Okay, we have vertex count. Okay, this is very strange. Vertex count. Now, obviously, instance count 1, first index, first vertex. So you don't have an index. You don't have vertex offset either. First instance is 0. That should fill up a buffer for a particle. Assuming... Okay, so we don't use this yet. This is a bit complicated. Yeah, how does that work for a regular person rather than doing some indirect draw call count thing? I'm glad it rained a little bit last night. I think it tried to rain last night. It kind of like only a little bit came through. But it's one of those things, isn't it? So this is the instance ID of the yeah, it's always 0. Instance count of instant number of yeah, okay. So everything's chill here. Now we need to decode this. The Yeah, hangers. That's what I was looking at. Vulkan guide. How do we deal with that? Let's just count first. Yep, so there's a bunch of stuff here that I don't care to... what I need is the compute shader. What I'm trying to find out is... how do we go through each draw call? You know? Oh, okay, fake indirect draw call. Oh, okay, yeah, that's equivalent to what it's doing. Like, how do we increment through that? Do we get the draw ID? Is that what it is? In the shader, anyway. Why are we in a I'm confused here. This doesn't seem right. The whole point of using an indirect draw call is that we fill it up on the on a shader. Why would you fill up an indirect draw call on the CPU? That's not GPU driven. That's unfortunate. But we need a way to increment through each draw command. And according to yeah, this might be unfortunately a complication. I wonder, can you do this as well? This is like such a niche function. Does that exist? Not an index. Yeah. Command index. Okay. So we have a count buffer and a count buffer offsets, max draw count. Cool. I think we have to use this. Max. Okay, so max count specifies the maximum number of draws that will be executed. The actual number of executed draws is the minimum of the count buffer and max count draws. So count buffer is the buffer containing draw count. Okay, so when we do this, we just need a way to access these fellas. So it means we need to push two things to, I think, as far as I'm aware, if we look at our push constants, let me actually look at our shaders. Where's our push constants? Unless it's like global. Yeah, so that's what we need to do basically to get out the draw ID. Then we can get out the draws, which is the, I believe, yeah, from the commands we get the draw ID, and then we can do that like in another layer of indirection. And that allows us to do, you know, everything else basically. I think, anyway. That's what I'm thinking, anyway. But the problem is I don't know how to use an indirect draw called count, really. What's the count? What's in the count buffer? I don't know. So when I build up the count, what fills up the count buffer? So we create buffers here. Where's the draw call count buffer? It's here. It's got just a number in it. It's VK buff. Okay, so it's got a load of stuff in. And it's VK. Okay, so it's local to the GPU only. We create this fella. But how does it get filled? What does it get filled with? Because we create a buffer. And okay, so then we can just fill a buffer with a command. And what does it get? Okay, what is this? Okay, so destination buffer size and okay, so what's the data? The data is the last thing. That's exactly what I needed to know. We have 0. Okay, so we say 0. And I assume that indirect read command, we set up a pipeline barrier for this. Yes, we set up a pipeline barrier here. And we fill this buffer up. Yeah, don't ask me what that white fluid is. I don't want to know. So we fill this up with zeros. And then we have to transition these buffers. This one has nothing in it. This one has something in it. This comes through. We pass them in. Basically. Then we do a push constant. Which I assume is like, I don't know, this one for example. It must have a push constant. Where is it? How are we accessing these buffer device addresses if we don't have a reference to them? You can do that? What? Yeah, no worries. Yeah, it's not like I was I'm not much of a Perl clutcher, let's put it that way. But, you know, there are limits. I'm not going to go crazy with it, you know. What is this? Okay, so it is binding a descriptor set. Okay, so this is, oh yeah, it's using this weird thing. The VK push constants with template. Yeah, we're not doing that. So we are just going to have to make up our own. Oh yeah, I know. I'm not one of those. Yeah, sometimes get me irritated when I talk to those people. I'm not going to go into it, but yeah. Nothing's worse when you're trying to make something a joke and then someone says something like, that's actually really offensive. It's like, now you just killed the mood, bro. Anyway, so these get okay. So he gets passed in. Okay, so we need to fill the buffer up with basically. This is a strange. Sure, sounds good. Okay, so this is the count buffer. We literally just fill it up with zeros. Then the then we fill up the command buffer on a compute shader using the data that we found from the what is it called? The count buffer to iterate through the draw commands. That's how it works. Got ya. And then... Yeah, there is a push constant. I'm so lost where this push constant... Where the push constant actually lives. VK command push constants. Which means there's a push constant. Oh, yeah, it's in the template thing. I've forgotten. Alright. So it pushes something in here. And that somehow means that we can access things without a ref. Very strange. Arsini was ahead of his time. Then we fill up this as if something happened. We have an indirect draw call buffer then. And then and only then can we render this thing, because now we have the index draw buffer count thing. Now the question is, do we mess around with this indirect draw call count buffer as well in here? That's another question I need to answer. So we have draw commands, obviously, but I assume that we don't write out to this fella, do we? Is it read only? Don't know. Let's have a look. So we just add 1 to this count. That's it. All right. So clearly it's just a number. This is a very strange interface. So we set up a buffer with 1 number in it. We then fill it with zeros, which is just setting a number to 1, setting a number to 0, and then in the shader we do an atomic add 1 to this value. So then we can increment through our command buffers. Okay. Wow. Crazy. Yeah, literally what this is about, right? So we have the draw ID, which is useful for referencing. Why do we need a draw ID? I'll forget that for a minute. I think the draw ID allows us to get at the command that we need, I think. So then in the vertex shader, we take in the draw ID. We get out mesh data, which is what? So mesh draw is this thing. That makes sense. We need to refer to our particles with an ID anyway, relative to a draw call, which is kind of what that book we were reading earlier is doing. So we have the index draw call count. We can do that. Next is the ID, and this is just anything that okay. So right. This is effectively our instance. Oh, is it? Oh, I'm so confused. How do you do an instance version of this? This is so confusing. Because when I launch these indirect draw calls, right, and I do this, and this, it seems to me that the draw ID is being used in place of an instance ID, instance index. I think that's what's happening. I don't know. This is complicated, to say the least. It amazes me every time I touch Vulkan stuff, I have to start from the beginning in order to understand what's going on. Makes sense. Yeah, it's tough. Let me think. Okay, so I'm going to do that then. I'm going to use a draw ID, which is generated from the compute shader, which is then passed in instead of an instance instance count, I guess. Because I don't know how I would draw the same object multiple times with an instance index that gets passed in as a draw ID. Sorry, as a draw command in a vertex shader. I don't know. I literally have no idea. But this is the only way to get this to be... to get these particles to be GPU driven. So that means that the instance... we're not going to be instance drawing these things. I just wouldn't know how to do it. Because when we do this, for example, we're getting the data from the draw commands out. Or here's a thought, right? Instead of this draw ID that we pass in here and then we pass in here, we don't have a draw ID. Cross that out. And we'll see if instance index works. Meaning that we don't need to read in this buffer. We just say draw indexed index draw call. Sorry. Draw. Command draw indexed. No. Command draw indirect count. We give it the count buffer. I assume. Let's have a look. How does that deal with the count? Do we have the count buffer twice? So that's actually filling up the buffer, right? Let me think. What am I doing? What am I trying to do here? Look for a VK. I'm looking for render actually. Okay, so that does the beginning and end of the. So that does. This is how you do passes, which I didn't realize. That's really interesting. I didn't know this is how you do passes. So I've learned so much, but I haven't implemented anything yet. Yeah, so if we want to do an index draw call, we send in our this thing. Yep. What? Draws. So we have an offset of, so we don't do the mesh shading. Excuse me. Mesh shading approach. We have this buffer that goes in here. What is this? Draw count. Right, okay, so it just feels like having a draw ID and passing in this buffer is just another way of doing a... Like, this indirect draw call count business is literally the same as instance drawing. As far as I'm aware. No, it's not. It's not. Because the indirect draw call count is generating more... It's putting a... Let's just say I have an indirect draw call. Hi, bot. I can't say anything wrong. Thank you. I can, my poopy understanding. So the The count tells us how many draw calls we have. So, do we create this twice or something? Like, how do we... Do we only create this one? I'm so confused. Because all we've done here is we've changed our compute... Okay, I'm going to change the music. We've listened to this a couple of times. Let's... I've got a particular track in mind. Give me a minute. It's a fall. Is this a fallback thing? Give me a minute. I'll put on a track. And all right. So right. I don't know the difference. I don't know. So sorry. No. Let me get this right in my head. I need to write some of this down. Okay, so I'm going to start writing this down because otherwise I'm going to start forgetting. So loose notes. It's going to be rough because I don't really have anywhere to put this. All right. So first things first. We know. Alright, I'm just going to copy some code in, yes. So I don't want to forget this. This is important. Because as soon as I start to forget this, I'll start to make mistakes. Yeah, so let's get this in. Okay, and we also need to define the buffer itself, which I'm probably going to start writing notes. Yeah, I think this is going to make more sense to me if I start like kind of just coding in Obsidian, because it's not going to be that complicated, right? So we create a buffer. So the reason I'm doing this bot, by the way, is so I can have a GPU driven renderer for our particle system. The problem is right now though, to have a fully GPU driven renderer, I need to do two things. One, I need indirect draw calls. That means the GPU needs to basically takes in draw calls and kind of runs them on its GPU on the GPU itself. The second thing I'm trying to do is also count how many draw calls we've got, which allows the GPU again to build up its own draw call buffer, right? So what this means is that we can take in a initial buffer. We can kick off a compute shader that does some work and gives the GPU draw calls. Then I can pass that over to the vertex shader or whatever, and that can plow through these draw calls. What about the vertex fragment shader? What does that do? Oh, okay. Just a standard basic fragment shader. I thought we had to do some craziness here. The problem with this all added up together, though, is the fact that it adds a lot of complexity. I've done this. So hopefully that explains a little bit what's going on. So when we create this... Hang on. Okay, so it's not gonna... Okay, cool, thank you. This is tricky. Yeah, so this is what I'm getting confused with. It is me or whatever. I tuned in. No one else chats. No. Most people put me on in the background while they do other things. That's typically what ends up happening. I consider my my live streams as like a radio show, so obviously you can interact with me whenever you want. And feel free, anyone who is watching, if you do want to interact with me, that's fine. But generally speaking, I am fully aware that, you know, I'm second monitor content. Yes, Angelica. There you go. Angelica is a cutie. Is working on something, putting me on in the background. Because I do the same. I do the same. I don't even have a GPU pipeline. Okay. What I'm looking for is the structs that match the shader. Bullet hit, bullet embed, bullet lower, max health. That's a good way of doing. Sounds like a logical way of doing things there. Right. So where is this? Yeah, that's what I'm looking for. Okay. So is there a indirect draw called count here? No. Okay. Next, I need to go into my shader. My compute shader. Yeah. Gonna take this out. I haven't quite finished yet, but we need to throw this in here. So basically, I'm going to explain to myself what I've just explained to Boss. The problem is I don't really do things like this anymore, so I'm probably going to have to create the buffer completely differently and build a memory pipeline barrier completely differently. Yeah, so we're going to steal the implementation of the memory pipeline barrier first, and then kind of build up that, because I need to do that next. So we're not going to do things the way it wants. So I'm going to take all these, definitely copied. I'm going to go to wherever this is, and now we're going to paste this here just kind of as a reference. So the buffer results. So this affects this. Okay. So this creates a buffer. Alright, so this isn't too complicated actually compared to mine. This looks very similar. Alright, so what I'm going to do then is take my create buffer. Whoever chatted last because school accounts. At whoever chatted last because school accounts word ain't allowed the bullet 3D engine. Because the school account word ain't allowed. Oh, you can't say Angelica is a cutie? Fair enough. Okay, so that, yes, lobotomy. I'm gonna say no. I think he's just making a, or she, I actually don't know. I'm not sure what they are making. They are making something, but yes, I assume that they have a mechanic. Yes, bots telling us about a physics engine called bullets. I completely forgot it existed. I think it's literally meant for bullets. It's like very specialized for FPS stuff though, as far as I'm aware. Okay. What am I trying to do here? I'm going into the pipeline barrier. That's the actual important thing. Not the create buffer. That was wrong. pipeline barrier. That's actually more interesting because I need to know the transition. Oh yeah, you wouldn't need bullet for that. Okay, so. And if I go to Obsidian, we can take out class on the bridge. Right. No, don't build. Okay. So we have the buffer itself. Source stage. Okay, that's the source stage. And then source access mask is next. I see. That makes sense. Right, and then the destination stage, I assume. Which is pipeline transfer. Yeah. Okay. Okay, that's good to know. So what I'm going to do then is... Yeah, this is comfortable enough. In fact, I'm going to find my version so I can do it exactly the same. How do I do these? Let's... Oh. What? Don't I do pipeline barriers too? Really? Oh, is this current project? Entire solution. There we go. No way, really? Oh my goodness. Do I do pipeline barriers 1? What am I doing with my life? Okay, so this is not... Oops. No, don't do that. Oh. VK memory buffer. VK buffer memory barrier. Right, okay. So this is a buffer memory. Apparently these are not, like... I thought escape point was, or escape was making a game engine. I'm just going insane basically right now. But I'm assuming Angelica is a QD is making a top-down engine. Right. Let me just think for a bit. I recently so hello, Darude Sandstorm. I recently started a new software engineering C++ focused internship. Do you have any tips on making a good impression and learning as much as I can through the opportunity? Right. I know it seems kind of a strange one to say off rip. Try to be likable when you're in the office, which is kind of not... that's going to go a long way, which just means be a good listener and pay attention to what your seniors say. You know, it does help to, you know, laugh at their jokes a bit and stuff like that. You know, so when they're telling you a story about, I don't know, maybe they've got kids and they're like, oh, my 4-year-old's doing this, doing that, you know, pay attention and actually listen to what they're saying, even if it's not about programming. You know, ask about their interests. You know, if they're talking about football, you know, ask them about football, even if you don't know much about it, if you can. Seems kind of a strange thing to do, but if you're likable, people will start liking you. And that is generally a good way to make a good first impression, a good impression, right? You know, you can go the extra mile by like, you know, getting someone a coffee or a tea, right? That, because it's not being slimy or anything. It's just like this is a good way of making sure that whoever you're shadowing likes to be around you, and they're going to be way more helpful. stuff like that, right? You don't have to do much. You just have to be, generally a good listener is probably the most important thing. And yeah, that's what I would do. If you want to impress them, generally speaking, when it comes to interns, we professional C++ developers, from what I've heard, even when they get juniors, this is the same as well. They assume that you know nothing. Like, they'll be like, okay, you probably know you probably know how to write a little program, but you probably don't know anything about anything. So, I wouldn't worry too much about being like super technical and super like switched on with your tech. I would say show them if you have a GitHub, you can show them. You don't have to make it public, but you can just show, or some kind of repository. You can tell them about what you're working on. But generally speaking, listening to them and paying attention and generally being likable is going to go a very long way. Because the last thing people want to hear from an intern is how smart they are, right? The last thing they want to hear is like, yeah, bro, I know all this already. Yeah, you don't need to teach me this. I did this ages ago. I did this in university. This is easy, That's the last thing anyone wants to hear when they're trying to onboard someone who's new. So, just generally not, you may already be like that, but I think that's like if you focus on that, you'll do a lot. You'll make a really good impression. I did this in the work, but yeah, exactly. It's really annoying when someone's like, I'm really smart. They kind of been dumping tasks on me, and I wish I was doing more shadowing. Well, talk to them. Like ask them. What I would do personally is, how do you? This is what I would ask. I would literally go to someone who's senior that you kind of already spoken to in the past. Like, how do you deal with like lots of work? I would love to know. And like ask them questions and get them to talk about themselves, and then you can maybe then bring up your problem about getting tasks dumped on you, right? Because literally this is how I do it, Like, how do you deal with tasks? They say something, pay attention what they've said. Don't just go and then say something else, and then be like, oh, okay, right, I'm trying to do these tasks, and I feel like my I don't know, my boss is giving me a lot of work. How do you deal with that? And then like listen to them again, right? Like that's how you get someone on your side and like help you solve problems. And let's just say that you've done that enough. You even might get like that same guy be like, all right, I'll help you out with your task. Come down. They might come down and help you out. And obviously be grateful for that if that does happen. But that's like generally how you would navigate that situation. It's kind of tough though, because it's like, if you've but I think it's like a good soft skill to focus on. Like, how can I be likable for the people around me that I'm talking to? Because they've seen 1,000, like especially older senior developers, they've seen 1,000 like smart kids who think they know everything. You don't want to be another one. Right, so what am I doing here? Hopefully that was helpful. That's what I would personally do. I know it can be intimidating. But yeah, just make sure you pick someone who's kind of remotely friendly. Sometimes you can pick someone who's a big grump. And then, but don't feel too bad if you get shot down. Like, oh, I don't have time for this, thing. Just think, okay, that was just a bad time. That was just a bad timing. So image barriers, we want buffer barriers. So let's build the buffer barriers version. Because that's what I would want. If I was working with someone and they were like brand new and I was like mentoring them, I would want someone who's like kind of cool. Okay, so We don't actually transition memory of buffers, looks like. Old, new layout, new layout. Okay, cool. Right, so I'm going to take this, and that actually makes my life a lot easier. So if we go into... let's get that in. Oh, what? What was I trying to copy? Yeah, this. Let's grab all this. Okay. And yeah, we're literally coding in Obsidian right now. But it looks like we don't need to do any Q stuff, so I'm just going to say ignore, ignore. So yeah, everything's good. Okay. This is not what I expected to do this morning. Or this afternoon. So, buffer barrier. I thought I would never get to do a buffer barrier. Wow. Here we are. It's exciting. I literally wrote in my notes, no one uses these, and then they're used. Wow, I'm excited. I wish the new hires and fresh grads are geniuses, so I can dump all the work on them. That's funny. Yeah. Right, so VK struct type buffer memory barrier. I could open it, by the way, if you're kind of like nervous to talk to people. You can always say like, what was it like being an intern when you were an intern? You know, like go to a senior. Doesn't have to be anyone in particular. You know, just find someone who's like who you think's cool, and like ask them like basic questions like that. It doesn't even have to be relevant to what you're doing, you know. And they'll probably tell you all sorts. Might be difficult to get them shut up if you ask them the right question, which is what you want. You definitely want that. That's gonna help you a lot. Alright, where's Obsidian? I keep losing it. Yeah, what is this? I think I'm gonna yeah, I think what I'm gonna do is just I'm gonna start coding in my IDE rather than this, because it's just autocomplete is impossible. Right, okay. Because I don't know if _2 is a thing. Yep, okay. Do you use DuckDuckGo because it has duck in it? Obviously. It's the only reason I use DuckDuckGo. So we don't need P next, I don't think. Okay, so... Hello, Munchie. How you doing, dude? Yeah, and now I can do this. Yay! There we go. And we are stealing... not that. Get rid of this. That's what I'm stealing. Okay, so that's the source stage. That's what we're waiting for. No, waiting on to finish. That's the access mask, that's the L2 cache, that's what we're ready for to finish, and this is what it needs to be in the all the way around. So this is L1 cache, this is the L2 cache. Cool. Hello. They've given me quite a large project, and I'm going I'm going from course project to giant solution. Going from course projects to a giant solutions with multiple objects. It's pretty overwhelming. I keep messing up things in the CI workflow, and I hate being a bother. Yeah, it's yeah, just well, you gotta remember you're surrounded by other programmers. It's not like you're gonna asking someone, oh, you know, I don't know, what's your favorite monster truck, right? Like, you know, that they're all gonna be interested in like some computer. Ignore, what's this called again? That's the one. So, and I don't think, like, if you imagine yourself, assuming that you're not talking to an asshole, you got to imagine that, you know, if you were an intern, if the shoes were switched and an intern came to you and was like, hey, how you doing, dude? And you hear something like, this CI workflow is kind of complicated, isn't it? You wouldn't be like, get out of here, you idiot. Right. You know, assuming that you weren't like in the middle of a meeting, though, walked in on the CEO, you know. You know, you got to think of it like that. Like, what's a assuming that you're a normal person, that's like not a crazy thing to say and try and, you know, talk to another engineer about. You're not going to be a bother if you're just going to have unless someone's I would say avoid people. If you want to avoid being a bother, just look for people who are in meetings, obviously, and also if someone's completely locked in with the headphones, like tapping away at the keyboard, you know, completely like staring at the monitor, that's probably not the best person to talk to. But I'm sure there'll be someone who's just kind of not intentionally looking at the monitor like a crazy person, who doesn't have music on, like blasting in their earphones in the office. You know, you look for the extrovert in the office. Effectively, that's what I would do. And it actually shows maturity, to be honest. If you're struggling with something and you can reach out to someone, that's a good sign. Juniors get this thing in their head where they think that they feel like they have to. I had this, by the way. This is something I constantly got criticized for, not asking for help soon enough, which just dragged things out and made everything slower, right? So the fact that you're reaching out to people is actually what you need to do if you are getting stuck. That is part of solving the problem, you know? Visual Studio nuked your install. That's so funny. Sorry, Ratchet. That's hilarious. Sorry to laugh at your miss. I just feel like Visual Studio just got. It's like, you're using Clang, are you? Well, I'll see what I think about that. And deleted it. That's kind of funny. Hunchback glasses net big is the worst one. I mean, I feel like if you go, I don't know if I've got a special skill for this or anything, but I don't think so. I would say just, you know, look for the. I'm just gonna say VK buffer here. Look for the guy who you want to talk to, and that's probably a good starting point, because you'll probably get an off. You'll probably be off put by anyone else, right? They probably have a bad vibe. What's the full, like, VK offset? Like, equals full or something? Oh, whole. VK whole size. And hey, and if it goes wrong, just blame me. Just say that was stupid advice by some bozo on the internet. But I really don't think it will be. I think you'll be fine. Right. Offset 0. Size is... Did I say size? Oh. Oh, I did offset. Yeah, that's completely right. Right, okay. Cool. Let's take this out. Put this in obsidian. Here, YouTube featured underneath your stream. They're advertising to me. Oh, right, you already subscribed, lol. I see. Yes, I've been paying off YouTube. Hopefully that's okay, guys. Yeah, hello, Detri. Hope you're having a great day, dude. Alright. Right, so that's what I want to do instead. So create buff. Oh, hang on. Needs to replace this. This song is so good. Pipeline barrier. Let's see that step. Okay, so if we go back to falls. Doodle doodle doodle. Gotta go to class. Well, good luck with your class. I'm making a GPU agnostic UI framework. Wish me luck. Well, GAPI. GAPI agnostic. Interesting. Cool. Yeah. I like that, Retcha. That's funny. Just use React. Yeah, just use React. When in doubt, use JavaScript. That's pretty much how it goes, right? Actually, that's still too low level for some web developers. It's like, no, we need like 20 frame rates on top of just regular JavaScript. Right, so right, get another rooster. Thanks for your advice, Escape Point. I'll let you know if they find me. You'll be fine. Don't be so nervous. You're an intern, you know. You're not supposed to know everything. That's like why they hired an intern. So this is what we want to do here, and I think dependency flag. I don't know what we need here, but we need buffer. Obviously, the buffer address. This needs to be 1. I know this enough that I don't need to go backwards and forwards. These need to be. Just like bother putting these in. Oh, I think I will. Image barrier and null PTR. I'd switch to web before I switch to native lol. Usually hire interns for free. I hope that is. I can imagine that's sometimes true, but yeah, at the end of the day, I think a good. I'm assuming it's like a good company that isn't just abusive and stuff. I wouldn't want to work there anyway, even if I got the internship. What's this dependency flag thing? Why is this saying, oh, right, okay, so, yeah, it's that. It's basically always that. There we go. Coding in Obsidian. Right, okay. Right, so we got that done. So now if you transition the buffer, we can actually fill the buffer. Yep. Now, where's this dependency flag actually? Let me just look this up in my code. Oh, okay, I just set it to 0. I just set it to 0, so I'm just going to remove it. Because it's already 0. Feels weird. Now the game is huge. Wow. 2007 was when Roblox was out? Jeez. Feels bad for the kids playing Roblox slop all day. Yeah. I see. I never played What? I played Prospector, I think, on Roblox. I've uninstalled it recently. It's kind of just taking up hard drive space. Right. You weren't even born in 07. Damn. I'll one day be an old, really old dude. So... Okay, so that's for creating a buffer. Yes, I'm going to make a game that's definitely going to kill Roblox. Well, I know this is going to seem super arrogant, but yeah, I would rather play my game over Roblox. It's not fun. I don't know. Playing Roblox for me is just not fun. Right. Yeah, so buffer creation. So I'm going to do create buffer. Oh, yeah, obvious. No, I don't want that one. I kind of want like a proper. Yeah, something like this. Let's go with... Yeah, let's go with something like this. And for the create buffer, we're going to say... So we have actually more layers of abstraction here. Just kind of... I'd rather play Sonic 06 than steal a brain art. Yeah, same to be fair. I went to my friend's house who's a bit older than me. He has like a couple of kids and they were playing Steal a Brain Rot. I just did not get it. I didn't understand what the game was. They just had a bunch of stuff and I was like, okay, what do you do? It just seemed like you just get more stuff. I don't know. I don't know why would anyone want to play that? Scripts used to until the entire server side. Yeah, I guess you could that would definitely make some kids cry. Alright, so we've heard this before, so let's pit on. I'm in the mood for the Dragon Ball Z soundtrack, to be honest. Budokai 1. Dun, 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 dun. Conveyor belt, you buy a brain rot there and then generate money at your base. You can steal it from other people's bases. They're expensive. You can steal their expensive brain rots because the more expensive, the more money it is. Makes per second. That's the whole game. You kill people with lasers with a laser door at your base. That's it. Okay. Really? Right. Interesting. That's all I'll say. Seems a bit boring, to be honest. Right, so what am I doing? I'm, so, excuse the, there's gardeners outside. No, they'll be gone shortly. I don't know why they're gardening, because there's like nothing to garden. All the grass is burnt. So what are we trying to do next? We're trying to create a buffer with this. Alright, I think I'm gonna have to do this myself actually. If we're gonna create a buffer like that, then my create buffer struct doesn't work. Yeah, so so what do we need to do? Yeah, because I assume that it's always like I think it's host visible every single time. But if we're gonna make this buffer, that's not relevant. So yeah, what I'm gonna do is steal. I'm gonna steal a brain rot, guys. And put this in here. I'm gonna kind of like work backwards. I'm not gonna have this. Okay, so sequence right. I think that's fine. Check. We just need to create buffer info to be correct, basically. And after that, we're good. Oh, no. So it's a VK storage. So that will be an indirect buffer. Yes, so that's all these. So that would be a these and these. No, these and these. That's perfect. Fantastic. Okay, so so now we need to make it so it is. I think host is gonna. I think our VMA allocator is gonna work this out. So we have a storage transfer. Use. Okay, so storage transfer. Okay, get rid of this. And the size is 4. That's the whole point there. Memory properties I don't think we need. Let me look at this and just see if there's a specific host device. Yeah, so what am I trying to do here? When I look at my obsidian, I have... I know this isn't very clear. Sorry, what is this buffer? This will be the indirect draw count buffer. Indirect draw call count buffer. So I'm trying to make it so it. For those who don't know what I'm doing, I'm moving to a GPU-driven renderer because, unfortunately, we need to do that for our particles. So at the very least, I'm going to get the particles to be GPU driven, meaning that we're going to fill up our GPU driven our indirect buffer up on in a compute shader, assuming that we have some things to do there. I don't know, some buffer related things, some particle related setup in the compute shader, and then we're going to if I was writing it from the CPU, I'd make it host visible and device local in rebar. The command I'm going to run, by the way, to fill up this tiny little buffer is vk fill buffer. It is going to be the simplest buffer of all time. So this creates a resource. This, if we have initial data. I don't think I've finished. Hang on. And then we return a handle. So we actually do it like this. I think I understand this better now. I just need to know the flags, basically. If I get the flags down, then I think I can simplify this drastically. VMA dedicated bits. Yeah, it's only going to be red. It's going to be like a read-only buffer. I don't understand this at all. No, I do. Can't. Yes, it's fine. It's fine. Yeah, that's it. Yeah. Yeah, I'm trying to make it device local. That's my goal anyway. So let me just read what you've said. Though I'd write mine in GPU. So it's just device local. Yep. Fill buffer is faster with device local. Otherwise you're writing through a PCIe bus. Yes. So I'm just trying to get it so it's not a... so VK allocate create host access sequence. I think this is chill. I don't think this has anything to do with the... no, this is not right. This means it's host visible. Host. So we need to find the VMA one that's just device. Let's look for device. Wait, can you just match case? That'd be way easier. Oh, weird. Okay. Oh no, I've lost where I was. I thought I was in... Yeah, okay. Okay, device doesn't exist here. That's fine. I think I clicked on something by accident. Oh, no, I didn't. Okay, okay, so this is huge. I've got to be careful here. Never allocates. Okay, so I'm just going to have to read these. I don't really know. I'm going to start with... Okay, these probably don't mean anything. Okay, so we don't want the host ones. Don't bind upper. Okay, so it's maybe this. Okay, so allocate create dedicated memory bit. Set this flag if the allocator should have its own memory block. There's only allow. Okay. So I'm just gonna read these. It's for special big resource. Okay, okay, cool. Set this flag if you're trying to allocate from existing VK create mapped bit. No. Allocate create user copy string bit. No. I can't imagine that's it. Set it's deprecated. Okay, fine. VMA allocate create upper address bit. No. I can't imagine that means anything to anyone. VK create don't bind. Create a buffer with the image / allocate. So don't bind them. When you bind yourself, you have more advanced bindings. No. Within a budget, can alias host. What do I do if I just want a... Yeah, I'm going to type in this. VMA buffer device. Like GPU one. I want a GPU one. For device only, just specify the device local. Just specify the device local memory bit flag. Where is that? Maybe I'm a bit lost here. So, is this in the buffer creation struct? Hang on. I actually don't know. I thought it was in VMA. I could be completely wrong there. Okay, yeah, the structured flag. Is there a... No, that's the usage. We don't care about that for this case. Share mode, concurrent, no, no, no. Device, local, VMA. I don't know. Where is this though? Oh, okay. Thanks, Ratchet. VK memory. Oh, it's the property. Oh, so it's a property. I'm just gonna look this up because obviously I've. Yeah. Okay, so that makes sense why he had properties now. And this is nothing. Yeah, fantastic. And this is... So in our case, we won't have that. So I'm just going to get rid of this. Because we won't have it host visible. Because it's going to make no sense. And this is part of the VK memory properties flag, which is... where is that? Is that part of this? And what was this? This is memory properties. When is this used? Yeah, I think I'm gonna have to look at the do this in C++ for a minute, rather than just googling stuff. So let's keep going, because I won't know. It's not the usage. Is it the flag? Sparse. No. Where is this MF at? Where's the memory properties? What account? What up, brother? Not much. Oh, required flags. Okay. Thank you, Ratchet. Again, thank you for helping me with this. Probably really basic. I just don't know where to assign anything at the moment. I'm gonna make notes on this so I won't ever make this mistake again. Or so require. Oops. Oh dear. Yeah, I'm good. Thank you for asking. How are you, dude? I'm just like working out the individual things that I need to make an indirect, a GPU-driven renderer. So I'm just doing a lot of studying right now. Yeah, required flags. Ah, right. Okay, so flags and required flags are different. Right. Or give me a minute. What is this? Hang on. Is this like a bigger strut? I thought it was just neon. Yeah, I don't worry, Ratchet right now. I'm just I completely understand what I need to do. I'm just kind of curious, like, what is the difference between these things? I'm just kind of like learning at the moment. Hopefully that's okay. So create allocator. Yeah, VMA allocation create info. VMA allocation create info. Yep. Required flags. Required flags. I see, so it is different. Okay, that's okay. So that is very different. And then that has the divide. Okay, okay, fantastic. Okay, cool. So flags and required flags are different. Cool. Did not know that. Well, it's not like I didn't know it. It's just I hadn't learned this way of doing this memory. Cool. So required flags. I'll make a note on this. Memory info. And then we take that and look at me learning on the fly. It's not there. I'll keep that open just for a minute. What's I trying to do here? In my notes, I was writing an equals. Yeah, VMA memory. Device. Oops. Local bit. Cool. Good diligence escape. Thank you. They have a different enum lol. But I know you're using the ancient version of VMA early on. Yes, we're not doing that at least. Yeah. Yeah, so let's just make sure it's... Yeah, it definitely goes to the... Yeah, it's definitely there. So I'm just going to copy and paste so I don't make a spelling mistake. Right, cool. Then I think that's going to work. We set the name, which if we don't have a creation struct, that's going to be a device count buffer. No, that's not device. It's got that stuck in my head. Indirect draw count buffer, which is what we're doing. This is very different. Okay, so we don't have this. That will never happen here. We haven't created the buffer yet. We have a way of doing this where we put it in a resource so we can reuse it later. The problem with that is it's going to require a bit of extra faff, to say the least. So yeah, just bear with me while I add an extra piece of code, which you probably never need to write on your own. So transfer, yes, we do have that. We have transfer, storage, indirect. Memory properties, divide. Yep. Okay. Yeah. So this access buffer is like a special container, which I need to fill in the rest of the stuff in. Which creation flags? Give me a minute. What specifically are you? Usage. Okay, so that's going to be everything other than the destination. Apparently that's always what I do, so that's chill. Not that that's going to do anything, but that just tells me some information. Size is 4, and the name is this here, and we should have that done. And finally, what do I do in my final thing? Oh yes, we need to do this. This is important. I think I deleted it. Oh no, I didn't. Okay, so buffer, we do have that. Then we return. Well, I'm gonna put this in a function, right? I don't know what to do with this. What's the handle? Oh, right. So when you access this, yep, you do that, and then we have that handle relating to that buffer, so we can look it up in our resource pool. So if I want to use the buffer from now on, then I've got to access it via the handle. You know, hypothetically, stuff happens here. And then, so I'm going to just kind of put this in a scope. I don't know what this is going to be. If it's going to, it's likely not going to be in the same place. That's all. Because then I would need to do this. You know, with the handle again. So whatever the handle is. Let's just say we have... What's the parent buffer? What's a parent buffer? Where do you see that? Sorry. Oh, right, yeah. This is not anything to do with This isn't Vulkan or anything. It just allows me to do it like a linked list to other buffers if I want to. Yeah, that's basically it. So if I have another buffer which is very similar, then I can just like go to the next one if I want. But I've never used that, honestly. I've kind of thought it was a good idea once. Picked it up from the mastering graphics programming with Vulkan, and I've kind of kept it. So handle, so buffer count, buffer handle, indirect count buffer handle, indirect count buffer handle, invalid buffer. And this is very specific to me. I'm coding in what is it called? Obsidian, because I'm about to write like a big load of notes. So I'm just gonna say exit 0 or exit -1. They kind of boil this down. So handle equals this, and then I can use this again, get the buffer out, and then we can do this. Very nice. Do this, fill the buffer. Cool. Okay. I can't seem to figure out why would one need a linked list of buffers. I haven't had the need for it either, so I've kind of just left it. There isn't any deep message or meaning there. I don't really have a... Oh, wrong. That is a VK buffer. And that should be, as far as I'm aware, this. So now we have a buffer filled with 0 that has a size of... So, of 4. So we just filled up it. So other stuff happens here. 4 5s in aura, I guess. You know what? Yeah, you're probably right. I'm wasting space because it's a pointer. Let's see. Do I use this thing literally ever? Oh, there we go. Look, apparently so. Do I need this global offset vertex buffer stuff? What? Why would I do this? So then I try to get the parent buffer of... Why would I ever... I don't ever bind a vertex buffer, to be honest, so I'm fine with that. Does our code build? Because I'm going to check if we ever do this, because... This might be like a stupid idea. Query buffer. That's just passing the parent buffer to itself. What do we have? We have destroy buffer. And if the parent buffer exists... we can't destroy a buffer if it has a parent's buffer. So a lot of the same stuff. If the parent's buffer is not equal to them, we also have to do that for this particular thing. Yeah, this would be nice to get rid of, actually. It's just filling up the code base. But I think every time we create a buffer, binus buffer is always this. Create a buffer is always invalid. This only happens in this massive struct, which I never really liked anyway. Function. Fill descriptor sets, which I barely use. In fact, I don't think do I even use this function anymore? Because I've used so many binus things over the past that I've reduced the need for this. Alright, yeah, thanks for pointing that out, actually. The only thing... I don't use a vertex buffer anymore. Okay, this... Let's just check that if any of these... Okay, let's ever get ran. Okay, so that's just data being passed from one thing to another. Now, if there's no... I know this is like not... This is mega distraction, by the way, but this is important to like... I was following along and I just didn't really question what I was doing. Okay. Yeah, this unfortunately this garden is you know, doing stuff in the back. Okay, so I'm just going to get rid of this compute shader just briefly because I'm not doing anything with it. And oh yes, version 460. Alright, cool. No, it's good to. It's sometimes like a second pair of eyes is sometimes really useful. Okay, we're not using it at all. We're getting rid of it. This is why it's good to stream, because I'm forever carrying around a pointless, what it seems to be anyway. I don't know why I did this. I really have no idea. I can't tell you. Yeah, okay, so that all dies. Oops. Yeah, I think if this compiles, then I'm going to push it. And there's no issues. Because this will just simplify. It'll reduce the code base size. And yeah. I can get rid of this now. We don't need a global vertex buffer. I think I got rid of that ages ago because that was just kind of confusing. So you, why are you here? Buffer descriptor. You also need to have not a parent handle. Yep. Bind parent if... Yeah, okay, so we also need to make sure that is deleted. Bind parent. We don't have that anymore. Less lines of code are always better. Assuming that it does the same thing. Well, okay. Assuming it's readable as well. I've got to be careful with that sometimes. Okay. I'm just going to bring this together so it's like nice to look at. Cool. Next. Yeah, so we never ever connect these buffers anyway. And if we want this, we can always just... Cool. We can always just add it back in. It's super trivial, right, to add back in. It's not like, you know, linked lists are like hard at all to like think or reason about. We've just now made our things more cache friendly, so yeah. Yeah, that was a good call. All right, let's see. Yep. Okay, let's commit that. I'm not going to commit any of the shaders though, so I think I'm going to do the opposite. No, where you commit everything and then restore staged stuff. Okay, so we have nothing in the place I want. Oh, this song is peak. I know I keep saying that over and over again. This is the benefit of not using AI. Look, I can just remember this off rip. Do-do. Okay. Commit. Removed a parent buffer that was never used. And just increased struct size and lines of code for nothing, for no reason. Cool. Push. Alright, cool. Let's get back to filling up a buffer. Do you keep all those commits locally? Do you keep... No, I know. I push them. I never saw the point of like having a bunch of local commits. It's just like, you know, if my computer blows up, which is kind of like why I push anyway, or once work's complete, like it doesn't matter if I committed it, if I haven't pushed it, it's still on my computer, right? Right. Okay, so we don't have this anymore, which is nice. Global offset. We don't have that either. Okay, so we're also going to get rid of that. What is this used for? Like, I swear to goodness. Oh, that's my Windows noise. Apologies. I don't know why that happened. Right, again. If this is always 0, then it doesn't matter. Set global offset. I don't think that's ever ran. Why do we don't have a global offset into a huge buffer anymore? Because we don't have that huge buffer. What is this for? We access a buffer and then we global cat. What is happening? Search for dynamic buffers. Get that layout. Bind set, yes. When's the actual bind happen though? Huh? Are you telling me that I could do this? Okay, cache offset. What does that do? That's what we're trying to do. Trying to work out here. Dynamic offset. Okay, is a pointer to a unsigned 32 int value specifying dynamic offsets. Okay, let's go back. Let's go back. Hang on. Number of offsets. Offset cache. Sure. Alright, let's just see what we end up doing with this. Sometimes I like to work on things in stages, if that makes sense. Squash them into a single commit. I have to say, Ratchet, the way you lay down your observations is unique. You make the person feel like he is so wrong to even think about that. No, I don't feel that way, to be fair. No, it's a good thing to think. Like, bro, why are you doing that? You know. So unassigned value, everything's 0. Okay. Assume that is true for every single case. 0, 0, 0. I don't understand why we're doing this. Let's see the call stack. Hang on. Game, skybox. Game, I assume. Okay. So there's 3 things that we're doing here. If every single offset is 0, then this could be simplified by just getting rid of it. No, it's a good question. I think Ratchet wasn't coming off as mean at all. He was just generally curious. Like, why do you use a parent buffer? What's that for? In this case, anyway. Yeah, I have a feeling that... What is this for? I think it's for the dynamic descriptor set. What is this? I think this is for when you have a dynamic uniform buffer object, maybe. It's a number of dynamic offsets into a dynamic offset. Yeah. Dynamic descriptor sets. Oh, I can't remember what this is called. It's like dynamic descriptor sets. I'm going to close some tabs before my RAM explodes. Dynamic descriptor sets? It's something like that anyway. But it's like old stuff, right? Yeah, I think because I'm using buffers with buffer device addresses anyway, and very rarely using descriptor sets, I kind of don't care. But let's kind of figure out what this is supposed to do, because this is like older stuff. Hey sir, I created a concept that can be shortened. That can shorten code from 50 lines to 5 theoretical. From 50 lines to 5 theoretically, could it be done? That can shorten code from. That can be done, yeah. Yeah, you can create a concept like use templates and then have concepts to reduce like lines of code, like functions or something. Kevin, I don't know if that's always the best idea. Personally, I like visibility over over like what people call elegance or conciseness, generally speaking. Anyway, so descriptor. I think Ratchet's right. Yeah, it's dynamic uniform slash. But I don't understand the offset into them though. That's the crazy part. Like, why am I doing this? So if I make them non-dynamic, what ends up happening? I think everything's been dynamic for ages. As far as I'm aware, we don't have a regular one. Oh no, we do. Okay. I think I've set everything to dynamic, but I don't know why this exists right now. Yeah, offset this into a dynamic buffer. Yeah, that you're binding. I think that's it, but I don't think I'm doing this ever. Let me think. How would I keep track of the I'm just gonna make sure that I'm not cast, because I remember doing this ages ago. I sent all dynamic buffers to be dynamic buffers. Anyway, okay, I'm gonna leave that then. I think it could be simplified, but for now, I think moving to dynamic, non-dynamic buffers, non-dynamic uniform buffers. Okay, let me run again. Make sure everything kind of like updates in a correct way. Yeah. Okay. So we're not getting any weirdness. We're still writing properly. Okay. Right. I'm fine with that. That's true. That's I think Ratchet's onto something there. I accidentally created an algorithm and I don't know if I should make it public because it's the first of its kind and will change the way vibe coding is done. It will eliminate vibe coding completely. Kevin, I would say go for it. I mean, if you really think you've got something, I would say to know if you've actually got something, you need other people to look at it. It's like how science is done, right? If I think I've come up with a breakthrough, but I'm just a crazy person, like, the only way to find that out is putting it out there on the internet, right? Yeah, don't worry about it. 30-second break from class. Well, I hope your class is going well. You can bind bits and bytes and create another descriptor set. So dynamic in dynamic buffers means a dynamic offset into it. Right, okay. Thank you. You can bind in bytes in without creating another descriptor set. Ah, right. Okay, so we can do like multiple. Right. Okay, got ya. Thanks for that, actually. That's good to know. Right. Tangent over. I'm going to stop trying to megwatch megwitch for your inputs, sir. Well, good luck with your algorithm and stuff. Anyway, so let's continue. So what I'm going to do is just continue on with this for a bit. I hope I haven't forgotten. Okay, so cool. I think I can write about this now. When you want to use indirect count buffers, you want to create a buffer that is filled up on the GPU. Though buffer device address is just an additional. Though with buffer device address, this is just an addition into. Ah, right. Yeah, that makes sense. Yeah. I love reading bytes too. Sometimes we even read nibbles. Very true. Very true. Oh, what is it? And crumbs. That's the other one. Yeah, and so is a crumb. I looked it up. Bits, crumbs, nibbles, and bytes are all things. They're all real. And for those who don't know, a bit is one binary 1 or 0, right? A crumb, for some reason, is 2. A nibble is 4, and a byte is 8. Opening my third eye and reading a qubit, a qubit shader. I see. Anyway, we want to indirect buffer count to fill up on the GPU, meaning that we need to make sure that it's is set to, let's make this bold, I guess. Oh no, put it in that. That's the meta. In the memory info required struct of the you don't want anything. Actually, full stop. You don't want anything like host anything host related in the VMA VMA allocation struct. I'm just going to copy this. It's just going to be easier. So that doesn't make any sense. Right, you do this so you can increment a value within a compute. What else do I need to say here? I'll say what the buffer is. The buffer should only contain a uint 32, so 4 bytes, as its okay. Using the power of quantum. Oh no, everyone's picking on you. To create real engine. Yep. That'd be that would have been a killer tweet in 2017. Still is. It's a real engine. Not every frame's possible. Yeah, I like that. I was tempted at some point. I know it seems super stupid, but to make my engine called the Unpeel engine. I don't know. It's just kind of stupid, but yeah, you can take that idea, the Unpeel engine. That's it, the Backrooms engine. Let me break out my 2 to the wow, yes, that's a real display real quick, yeah. Gotta watch from space, you know what I mean? The buffer should only contain, yeah, okay, so as it's only increasing a number to index into a draw account, draw buffer. Cool. That's how you set that up. Next step for me is figuring out how the bloody compute shader works. The next step is creating the compute shader that fills up the, what is it called? It's got a specific name. So VK draw, yeah. Right, okay, so we've done that. Hopefully, I really liked your last video. Oh, thank you. Keep it up, man. Yeah, you too did. Thank you, Stephen Lenz. Yeah, we appreciate you, Stephen, 100%. Nobody does, to be honest. I assume you're referring to something else. I don't even think my maths is right there. I don't know. I don't know quantum computing. Yeah, I don't know quantum computing either. Yeah, nobody understands quantum maths really. Anyway, let's keep it on. Yeah, got you. I figured it out. Right, let's keep on. Okay, so we need now to figure out how the compute shader works. When we're filling up a buffer of data. So the simplest, I think I have the simplest buffer. Give me a minute. So we don't have index. Okay, so the first thing I need to figure out is when I do this, what is wrong? Because this is not. Oh, what? Really? Right, sanity check. Build. Yeah, okay, so it doesn't know what that is. So that is correct now, okay. Whoops. So I'm going to grab all this and throw this into here, just to making sure it's legit. Okay, cool. Now we need to... Sometimes some guy will pop into the chat with severe AI psychosis like that. Hmm. Yeah, it is what it is. Well, you know, morning, Mika. With people like that, like I said, I don't want to be super harsh on them because, you know, they're not going to listen to me. But like I said, if someone thinks they're onto something, it's probably best to talk to other people about it. And get a reality check effectively. I hope you had a good sleep, by the way, Mika. You know, like me with my game engine, who think... It's like me trying to think like my game engine will be one day make a game. That's kind of deluded, isn't it? Anyway, right, so we need to... What am I trying to do here? I'm trying to do something. Oh yeah, so we need to go into falls. We need to transition the excuse me, sorry. No, the next step is actually transitioning. Okay. After we have filled the count buffer, we need to transition the buffer to be readable by a shader. Right, so classic, I'm just going to grab in where is it? It's hang on a minute. Have I broken this in like a different way in the past? What is this? Originally I just returned that. Okay. So this is broken, but I wonder if that's why. Like it's too well done. No, okay. Yeah, it's a very old version of the Niagara renderer. It's I was following along with Narsinis Kapulkin's tutorial series, which is why I'm in this code in the first place, because he does a lot of things correct. Like he understands things that I don't quite understand, and I'm kind of robbing some of his ideas. But I'm also taking notes, so I'm actually I'm going to make it my own. I'm not just going to be like, yo, I made this. That classic meme online. Someone hands someone an object and says, look, I made this. And then the person who received the object goes, wow, look, everyone, I made this. You know how it is. Right, okay, so... after we filled this guy up, what do we do? Where's the memory transition? That's what I'm looking for. It's in... So I need to look for... DCCB over and over again. Yep, okay, so that's the 2 steps there. Then we have to... What are we doing here? Okay, so this is the depth image. We don't care about that. And now we need to do another thing. Raster stage, I don't know what that is. Is that assigned something? Okay. So this is okay, so this is either vertex shader, cool. So vertex shader there basically. Yeah, forking the kernel and telling everyone I made it. Yeah, exactly. Junior Ratchet, I like that. Watching you focus on your work for a long time is keeping me motivated to study, man. I keep opening YouTube to distract myself, and then I see your streams and get motivated to study. Yeah, that's I'm glad I can do that. Yeah, that's one of the benefits. Why I'm partly why I'm doing this as well is for that reason. You know. So, more transitioning memory to a different type. I love the song. So I'm not gonna do what he's doing here at all. Is this a good idea to do them both at the same time? Hang on, let me think. So this is for a... What is this for? Image barrier. Right, okay, so he's setting multiple things up at the same time. Then he binds a compute shader. And then, based on, I assume, the pyramid barrier, whatever the pyramid was. Yeah, the pyramid thing. And the multiple different buffers. He then pushes them in a push descriptor template, which is new to me. And we push that up. And then we should be running that compute shader, basically. That's as far as I want to get today. At least in my understanding. If I can get that far. And when we do this, we have to then transition the memory out into a different state. Okay, we are not doing the image. That would be dumb. But yes, we do need to do that. So we need to transition just to write. Writable memory, effectively. Make sure that we're not going to run past the compute shader bit. And we have done the transfer and the indirect along with the vertex shader. Or do we wait for these? I prefer to call... yes, Junior Ratchet. I'm not actually one of those guys, by the way. I think they are all a... slash Gmail. Oh, is it? Oh, okay. I did wonder that... I don't know. Yeah, I did wonder if it came from somewhere, but maybe it's just a meme that someone came up on 4chan. People are afraid... what is his bloody name? Yeah, okay, so we're changing the music because we've heard this before. Let's go with... Let's just go through the Mega Man soundtrack. Right, okay. Oh, I need to turn that on now. Right, I don't know if I want to do this, to be honest, but we have we need to create another buffer. So yeah, let's create this buffer, and this is the command buffer guy. So yeah, okay, so here we go. We need to create this next. I mean, we created it before, but it doesn't really matter. So for some reason he has set a massive size. I don't know why. These memory properties, which are all the same, which implies that this is all GPU. I am assuming this is all device local. Okay, yeah, it's device local there. We write out, this is an output variable. We have the device in here, it's input variable. That's just classic VK device. The size I don't get. Storage, indirect. And it's, okay, cool. So I'm not going to copy that. What I'm going to do is just, so we can't do this yet. So the next step. What I'm going to do is we also need to create the draw command buffer, which allows us, which should be empty, as this is going to be filled up within a compute shader. That's why we did a bunch of work earlier to fill a buffer with 0, because we are going to use that in a compute shader to slowly, to incrementally, hang on, to go through each element within the draw command buffer and exclude things we don't need. This is the power. This is the power of fully GPU driven rendering. Right. Cool. Next, okay, so we need to create the command buffer. So I'm going to copy a lot of this, but not all of it. I think the first bit is probably going to be identical. I know this is super dense, but like, I'd rather like be the most explicit guy on the planet about this and never have to worry about this again, you know, because I've got it all written down. What's that meme of the guy with the clothes and accessories that all say stupid item, and then that guy goes, surely nobody's that stupid. That's me just now. Okay. I actually don't know that one. Right. Okay, for some reason, which I don't understand, I put it in off topic. Okay, let's see. I like that, actually. That's kind of funny. Yeah, I just saw a meme that Detree posted. That's quite funny. Right. Right. For some reason, which I don't understand, which I'm going to investigate, these buffers are all, for some reason, that big, which just seems massive. These like are huge buffers. But I will just paste them in for now, just to kind of like figure out one thing at a time, right? So I'm just going to also comment to myself. I don't know why yet you would want to make a draw command buffer this large. Okay. So it's going to be the same dealio. No storage. Indirect. But it's not transfer. So this is not a transfer buffer, which is the first of its type. Where is the next step? Okay, so it's not a transfer buffer, interestingly. So we can't transfer this to anything else. Next, local bits. This is the same dealio. And I've just got to change the handle, I think, as well. Yep. Okay. So these do need to be buffer device address is buffer device address accessible. Now we just got to make sure that the pipeline barrier makes sense, because I don't know off the top of my head what the pipeline barrier should be, but that's why we're taking our time. What is this? I don't understand what this buffer is. It's doing something in a compute shader. It's a. I wish I'd named these not what Arsini did back in the day. Arsini Kapulkin's YouTube channel has like this series, and he's named them the same, like the same thing. Anyway. I didn't even realize Nathan Baggs was in your Discord server. I know, yeah, lucky. I got really lucky. He joined. Top bloke. Right. No, yeah, no barriers, no fences, just raw dogging race conditions. Turn off validation errors. Oh, that'd be cool. Yeah. A collab stream when. Maybe when I release my game, he can fix it for me. I don't know. He can hack it better. That'd be so hype. Yeah, that would be so hype. But yeah, but yeah, if I, for now, I'll just you know, concentrate my own stuff just to make sure. So indirect and also vertex shader, VK pipeline apparently, stage vertex shader bits. Cool. Got rid of those two. And then the next is VK indirect read and to VK shader read. Okay. And then this is a compute shader, and then this is a write. So that becomes a write. Yes, that's fine. Yeah, synchronization is nearly. I like that. I performed arbitrary code execution on indie game engine. Yeah. No, so that'd be pretty hard to do. Just abuse the parent buffer primitive. Yeah, pretty much. It'll be the shortest video ever. Maybe you can make it into a 5-second YouTube short, perhaps. This bozo indie dev has left open his put indirect pointers everywhere that I can instantly abuse. Right, okay, so I think we're good, but we now, is this a buffer memory barrier? Actually, I didn't check. Yes. Then we do this. So we've created it, we've made the buffer. Hang on, do I need to do any other transitions before I continue? Let me think. I'm just wondering if I need to do anything else. With this fella. Where are we? So this is the So it looks like how Arsini did this in the past was he has a... I also need to make a graphics pipeline. Not a graphics pipeline, a compute pipeline. And I have not done that in like maybe, I don't know, a year. It's just gonna be a bit rusty. And what I don't need to do. VK, draw indirects. Okay, so that's the right. What do we do after that? So we bind a pipeline. We then run the compute shader. And then we transition again. Okay, so this is the important part. So we transition again to, I believe, probably the compute shader needs to be finished. We go from right in the L2 so the L1 cache, the accessible stuff. Sorry, the visible stuff. We make sure the indirect is done for the next guy, and then we make it so it can be read, and then we make it read only for the next thing. I think. Just a thorny thought. Leak gameplay data to a GPU buffer. Someone uses RenderDoc as a cheat engine. Yeah, that's a I'd be mad that. Just mess up the header. Yeah, I mean, considering all my code is publicly available, it's not gonna be hard to do anything with. You know, like, ooh, there's a mystery. Oh wait, he's just done that silly thing. Okay. Anyway, what are we doing next? Yeah, by the way, if anyone does actually want to criticize my code, I don't mind. I know it's obviously a kind of a difficult thing to do because you have to sit down and do stuff, but you know, if you do find some questionable decisions, you know, feel free to did my in my engine all my yeah, it got deleted for some reason. In my engine, all you need is a bogus cache file. Is that your engine? I feel like you're projecting there. I don't. Ratchet is projecting on us. He's worked with cache files. I know that for true. For Ace, yes. Anyway, right. So I need to run the compute shader next. So then, yeah, okay. So then we can run the compute shader, fill up the buffers, and then we just need to transition that buffer back to what we need to be read in by a bloody thingamajiggy. Right. Okay. So, didn't mean to do that. Hang on. That does need to be there. This does not. Okay, so we got it twice. Thank you. Compute shader that fills up the command buffer. Right, so the steps I need to take after that are basically bind the pipeline and then go nuts. I'm going to copy this and kind of modify it like I have been. Oh, that's a quote from me. I see. Yes. Yes, that'd be fun for your engine too. Right. So. Right. So he is using. Arsini once used a technique I've never seen anyone talk about called push constant templates. I'm not going to do that because I don't need to. I've just allocated the maximum size, and if I want to push constants of a given size, I can just throw in. So we aren't going to do this at all because we don't need to do that because we're not going to build up a hierarchical Z buffer. The descriptor infos, yes, that's fine, but I'm going to actually get them from our, like the way I would do it. Obviously, not that everyone would do it the same way, but I want obviously use my code as much as I can. I do configure push constant size per pipeline. Oh, do you? Okay, right. What am I doing? I copied the wrong thing. I have just everything at full size all the time. Technically, that lets the driver do some optimizations. Ooh, I see. I did have, yeah, because the effort on my end. Maybe I should do that. It is just me, you know, as the programmer, right? It's just I've just made it convenient for myself. So I copied the wrong thing. What do I need to copy? This. The count buffer. Obviously, I'm going to rename these. Right, so indirect buffer. Yep, and indirect count buffer. So we don't get naming collisions. I don't know if any of this is going to compile, but I'm kind of doing it more as a education on my own part than anything really. So get rid of these. VK buffer. Oh, no, it needs. What does it need? A VK dependent info needs. All right, let's close some tabs before I run out of RAM or something. Right, cool. Oh, this is an abstraction. Okay, isn't it VK? Yeah. Hang on. What is happening here? Dependency info, yeah. I assume it's just dependency infos. Dependency info, yeah. Right? And when I was building up the dependency infos, I needed just the actual VK buffer. Oh, this is kind of dangerous, actually. So this is fine, but no, I don't think it's going to work for my specific case. I don't have this level of abstraction, really. So I'm just going to make another dependency info, and then just have two in an array. So we have two buffers here. How do I set them? We just need them in. I figured some. Oh, but technically, okay. Because some of the push constant states can be used for other things. I think it takes 700 more hours for VS to repair itself. Wow, only 700. Look at you. Right. Let's keep it on. Right. So if we just have a. We need memory barriers, not an array of memory barriers. Ugh. Give me a second. What is he doing here? What is this? So it's a union between. Okay, so it is a VK image info or buffer info, and he can just able to set them. And this is what this is. It's a VK, just a VK buffer. Okay. So when we do this, I'm confused. How are we setting a VK buffer? Is that really a buffer? Okay. Question. What is this then? It has a buffer in it. There's a range and offset. Huh? Excuse me. Oh man, I think I need to stretch for a moment. Oh, my back's getting a bit tired. Give myself a stretch. Ugh. Right, so this is some C++ shenanigans. I don't know what's going on here. Right. This song is so hype. The Mega Man 2 music is so peak for the NES. Even the Airman stage. Right, okay, anyway, let's not get super distracted. So when he is assigning, here's a union of a struct. So we have a okay, no, he's doing the actual thing here, which I expect you to need to do every single time. The rest, it looks like he's relying on C++ to go select this thing correctly and then set these both to 0. I just don't see that happening. I mean, yeah, we can do the buffer, obviously, but... And wouldn't this be 0 and whole anyway? Like, not 0. Buffer descriptor info, right? As far as I'm aware. That we have... range is the size in bytes that is used to... used for this descriptor update. The whole... VK whole size is used to... It is to use the range from offset to the end of the buffer, yeah. So if I want to do the whole buffer with this descriptor thingamajiggy, descriptor buffer info, how does it know what we want here? This is interesting. Does it know what it wants? Or is this just like accidentally works? Obviously Arsini's thing doesn't technically work anymore, but how does it know that we've got a buffer? Like, and then we push that up. Oh no, we create a... What do we even do with this? I've forgotten. Yeah, we have another lambda, which effectively binds a push constants with template KHR. New that I've never seen anyone use these before apart from Arsini. I don't know if they were like a good idea at the time and no one uses them anymore because they're poop. I have no clue. Hello. Thank you for joining us. Right, so, what am I trying to do here? That's a push descriptor. Oh, it's crispy. Oh, yes, I've got to send you a 590 RTX. Escape point. Oh, right, yeah, duh. Not a push push constants. Mostly intended to use in OpenGL to Vulkan ports. Ah, right. Thanks for that, actually, because I'm a bit baffled by this sometimes. Yeah, because push constants and push descriptor. Okay, thank you. Push descriptor, yes. I thought it was a push constants, but I've been reading it as push. Yeah, I've been reading this as a push constants. Thank you. That makes sense why I haven't seen it. Right. What are we doing? Less efficient and more limited than a normal descriptor. Ah, okay, right. That's good to know. Yeah, I might actually research that. I think I'm going to write that in my notes. Because Alex was someone who was helping me out earlier. Stream stuff. So... I think I'll do this off stream, but yeah. Push descriptors are not the same as push constants. They are typically used when transferring a renderer from OpenGL to Vulkan. There we go. They are. I mean, I trust what you say. I'm just going to also verify this off stream, because that's really interesting to see. So they are less efficient and more limited versions of normal descriptors. The only game apparently that seems to use them is Minecraft's Minecraft's experimental Vulkan backend. Surely Microsoft can't just AI, right? Doesn't Copilot know immediately how to do this and not use these limited versions of descriptors? Surely these models that are limitlessly intelligent in every single way and flawlessly write code is able to come up with a better solution. Anyway. Because they are putting OpenGL. It makes sense, yeah. Thanks for that. Yes, I'll make this into a more substantial thing, because it is good to know these type of things that kind of like crop up out of nowhere. And I'll write that down. At the very least. Alright, Mahjong doesn't seem to use so much. The code is naturally stupid, fair enough. Alright, anyway, let's continue what we were doing. Right, so we want to... Right, in that case, we don't have to do this push constants nonsense, which is good. We can just do what we usually do, which is actually really useful. Yeah, so I'm just going to grab my own push constants thing. So thanks for that, Ratchet. That's actually helped us a lot. Because I can literally just push my own stuff. Use my own code today. Who would have thought it? Actually, I'm just going to absolutely make sure that's what we want to do. So this will be vertex. Size of push constants, which is just the call data I see. Push constants, layout. So this is just the layout. So I don't know what this extra variable... oh, yes, stages and layout. So compute... So compute pipeline. So I'm going to say, yeah, VK compute pipeline, just so I don't get confused. And what we're going to do now is obviously do the classic. I have a sneaking suspicion. Yes, we're just going to push up our buffers into our lovely array, the push constants thing. They actually do pretty good with Vulkan stuff. Is that Minecraft? I don't know. They were still using giga barriers last time I checked. Oh, yeah. Yeah, I know what you mean. Yeah, with giga barriers. Yeah, don't use giga barriers, folks. Use small, little nice barriers. And this will be what's indirect address, indirect count address. Yep. Fantastic. And then we dispatch based on final thing. I don't know what these do. Why are they written like that? What does that mean? So we're going to grab this out and try and figure out what he was trying to do. Thread count is just thread count divided by local size plus, okay, pretty much, which draws. Ah, right, okay, that's how that works. Good to know. Not inside. So I'm gonna have to put this in like a fake draw, a fake for what is it called? Oh my goodness. Render loop. There we go. Fake render loop. Because we have to have some setup in here for context. So mesh draws, I don't think we do anything with that. So actually, I can just get rid of this, and throw this in here. I'm actually going to do the arithmetic myself. Well, just so I can see it without any convolution, no complication, I should say. So we have two arguments here. We have, okay, this I don't know. Local size, and this is something he's written. Or is this something in, yes. Okay, so local size is what? No, I mean AI. Oh yeah, okay, fair enough, yeah. In game dev, great game devs not necessarily equal to great software engineers. I saw so much bad code in great games. Yeah, that's true. We're being a bit elitist here. I think Mika's a bit onto something. I mean, there's great games out there. Like, you know, people say like apparently Undertale had bad code in it, but it's like a fantastic game. But I think it's also fine to criticize code. And I think, despite us being a bit snarky here, yeah, Mika has a valid point. You can have a great game and have bad code, and the opposite too. I have to stretch again. Ugh, okay. So what do we set this to in and why? Yep. Okay. So we load shaders, and what do we do here? We take in shader.h, and what do we do? So we have shader module, and obviously it's not division by 0, so this is clearly set somehow. Unless I didn't see it, really? Oh, parse shader, okay. Oh no, okay, right. So we're doing some SPRV reflection here. Do I want to do that? Yeah, guys, I hate... Okay, fair enough, yeah. If it's not obvious. Yeah, there you go. Ratchet loves Minecraft. Wait idle between every command. Let's go. Perfect resource safety, yes. I like that. It's either wait, yeah, a QWait, maybe even better, QWait device for every single command. Or we just turn off validation and synchronization validation and have no synchronization at all. We either synchronization maxing or synchronization minning. Anyway, so he does some spiv reflection for some reason to... Why does he do this? I think all we're trying to extract here is... I just... If we're literally just trying to find the... this, then... we could just set these ourselves. Like, I don't see the need. But I don't really know. This seems to... I know it seems... Arseni's like a really smart guy, and I'm not going to dunk on him here, but... This to me seems like he's being too clever for his own good. If you just know... Like, what else is the point of doing this? If I know my graphics if I've set my compute shader that I'm going to use for a graphics pipeline, for a compute pipeline, to be 32x 32y, why do I need to then parse it to then get out those numbers? I can just get those numbers out. I can just have those numbers in the actual executable and not read a file. But I'm trying to figure out what else he's doing here that might be cool. Might be like necessary. I wonder if what would happen if I removed all barriers and commands and tested out. Yeah, validation errors and crashes. Yeah, I think what ends up happening, because my code, I end up like breaking stuff like pretty often. You'll probably just get a driver crash. I think it'd be unfortunately quite boring. I think you'll just get a driver crash. But who knows, it's undefined behavior, so you know, you can get anything happening. Maybe the intro of Skyrim starts playing. And that's same, I've never got a blue screen of death after a GPU crash. If you're on Windows, bidding. Oh yeah, that's true. Yeah, bidding. I see what you're saying. That's a good way of saying it. Yeah. Okay. I'm going to ignore what Arseni did in his renderer here. He has repassed. He does some SPRV reflection. I don't need that. I don't think. If I just want to know these, what are they called? This. Where is it? This. Then I could just write that in my file, right? There's no qualm. Unless I have thousands of shaders that are all like hard to carry, you know, and lots of different things moving. But for my little game, I don't really see the need to SPRV reflect for that reason. So we're not going to do that. uint 32 local compute. Say compute local IDX or something. Compute local X ID equals 32. And then we can take the draw calls and do the division, right? I mean, maybe there's stuff I don't understand about this, but yeah, that's generally my... I'm trying to avoid SPRV reflection like the plague, because it's just... IO is just so slow. Okay, so... And we want to avoid IO accessing for unnecessarily. I use C-line, but it regular clang now. Never hit a beding sound when I was using. Really, you've never accidentally done a overran a subscript operator or something? That's kind of interesting. Oh. I guess Ratchet's on another level of coding. So we need to find this function. That's not what I wanted. I wanted this. Thread group is first. Okay, that's good to know. So when we are doing this, we are going to write a variable num of x threads, I think. I'm just going to write it like this, and thread count. Alright, I'm going to skip back again. Apologies. So is draw count first. Okay, draw count size. Obsidian, yes. 32 divided by 32. Cool. Okay, so I'm just going to make some notes here. First thing we must mention is that we are incrementing by 1 for going over our indirect buffer count. Ah, thank you, Rashav. Yeah, Rashav. hello. Joined the Discord yesterday, and I really enjoyed following the progress. Thank you. I hope you have a good time in our little community. It's always a pleasure to have a new face, and yeah, just keep it on. So right now, if you're wondering what I'm doing, I'm writing excessive notes on how you're supposed to deal with something called GPU-driven rendering. What I'm trying to do is I'm trying to get the GPU to tell itself what to draw. And to do that correctly takes a bit of finesse. There's a lot of like balancing of barriers. So yes, we are trying to get these buffers to work properly. Hi Raj, good to see you again. Thank you for joining us. So that's why we're in Obsidian, which you're probably familiar if you saw that video where I talk about things. I'm kind of like writing code in here. So I'm going to take, actually I'm going to put this below. Oh, I don't know why your message got redacted. But hello, regardless. First thing we should mention is to increment... incrementing. We are going to increment by 1 over an indirect buffer count in a compute shader when we when we have a condition for a draw command, right? Yeah, a draw call. Is this only for particles? It will be for everything eventually, but yes, we're writing it just for particles right now, just because it's the simplest thing to get working. Because we don't have to worry about indexes, which is going to complicate things a little bit. Yeah, this is going to take some like meat to get working. It's not like a straightforward change. Super intriguing. My GPU works in highly abstracted, silly web GPU scenes. I see. Okay. And PyTorch. Seeing you work with buffers directly gives me a better appreciation for its wild intricacies. Yeah, it's I love all this stuff, so it's always I like to get in the weeds of things. Talking to the GPU is a lot of work, lol. Yeah, it's I like what I said this before, and I was super happy when I heard Tokyo Spliff, another guy who does this type of stuff online. If you're unfamiliar, he said exactly what I've been saying to people when it comes to graphics. It's like you're talking to a separate computer on your when you do this type of stuff. The GPU can be thought of as almost a separate computer, and that's why it's that you have to build up like almost like a network connection between these things. And so in a server, right, you can imagine it like that, we would want the server to do as much work as possible and the client to only receive stuff, right? So we can reduce the communication between the two, which is what we're doing, right? Yeah, nothing but good things to say about you and Tokyo Spliff. Oh, thank you. That's lovely. Indirect buffer count in compute shaders when we have a condition for a draw call. So when we are we need to limit the amount of draw calls we have for a given thing. We need to say we need to limit the amount of draw calls for a given thing. We need to say the maximum. Oh, this is too early. I've kind of written this too early. Hang on. Yeah, this is even after this because that would be for the indirect draw call count when we have the buffers and stuff. All right, cool. Sorry. We are pushing up our indirect buffer and indirect count buffer. One we are purely writing to, and the other, I believe, we are purely reading from. We are also, so this would be like this, tying our compute shader I wonder if fully occlusion culling per particle is even worth it. Would it be cheaper to check and discard one rather than draw it anyway? I'm not going to do occlusion culling on particles, I don't think. I didn't have that in mind. This is what I'm trying to build up here is effectively this. So I'm trying to build up a set of particles. Let me think. Let me relate this back to what I've actually been trying to do. So we're not doing occlusion culling. I basically need a compute shader to do in here. The idea anyway is this is going to be doing the particles, right? It's going to be doing the particle logic, like whatever that may be, here, and only when we have like finished everything, then we're going to build a draw call. I really want to do an instance draw call because that'd be really sick, but I don't really know how to do that. An instance indirect draw call even. But right now we're going to do it where we're going to have some separate things. And even if we don't end up using this for the particle system, we need. I kind of wanted to do this anyway because this is the beginning of like occlusion culling and a view frustum culling at the very least. You kind of need to build up this system anyway. So yeah, it's going to be the particle, because we need a compute shader to do the particles. And I thought, well, might as well build up the data and do the compute work here, and then pass over what we need to the vertex shader later on, which is going to read in the indirect draw call buffer and work out like way less. It's going to render way less. For example, if you do a view frustum call, you know, plus I don't know, plus a view frustum call. I don't know. I don't exactly know yet, but so it's like do particle logic and view frustum call here. You know, whatever that may be. I haven't quite decided yet. So I can almost say to do decide and write the particle logic. And then only when we are done, we'll write out what we need. We're going to do, unfortunately, a lot of draw calls, but they're going to be indirect at the very least. And then hopefully I can make it instance-based, which would be even better. Alright. That is... Okay, so you are right there, Ratchet. What I'm doing, what I'm copying here is not... I'm getting rid of this. I'm not writing to an image to build that hierarchical Z buffer, which is used for occlusion culling. So yes, I'm basically just taking the parts of this cull thing and only taking parts that I'm going to end up using in the end anyway, because I also need to sort the particles and stuff like that, so hopefully I can do that all on the GPU. I have not written a particle system, so I'm learning here. Lol. Oh, that's good. You asked a question. It's basically a sprite batch with extra dimensions, right? Or these lit particles. I want to try and use... you weren't here for this, but I was writing up a bunch of notes about how this mega particle system. And immediately, what they do is quite clever. They have multiple buffers, and they have in this buffer a bit field, basically, that kind of like turns stuff on and off. So they'll have like particles with lighting, and particles with shadows, and particles with that are just for rain. So that could be, you know, affected by, you know, wind. This is like fireflies and voids. Or they have just like regular, you know, is it regular stuff? So it's ignore it being Java. It wouldn't work in C. So what I want to do anyway is effectively kind of cop this idea. So this would be my particle set, which would have like things in common, and that'll be the individual particle. But what they're doing, eventually this is going to have to hit a compute shader. And do something, right? So I thought, well, if I'm going to have to do indirect draw calls to do this kind of thing where I cull the things, and basically run a compute shader, I don't want to have to like run all the because the meta right now, as far as I'm aware, is you run a compute shader and then you pass over the data to a vertex shader. So that's why I'm kind of doing this right now. I'm kind of like, all right, yeah, so we're going to have indirect draw calls to have this idea of a buffer, right, that does like a bit mask and a particle buffer. And this is the thing I don't quite understand. There's like a separation buffer apparently, which kind of like sets things as inactive and active. So there's a lot of things that we need to do, but this all mentions compute shaders. And like I said, you know, I thought, well, if I'm going to do compute shaders, might as well go all the way and do a GPU driven rendering as well on top of that, because this is what this is designed around. It does say, I think, at the beginning, this is, yeah, if you have a GPU based approach, you can do something like 1 millisian apparently of particles. So introduces the compute shader approach, which, you know, computer shader approach that limits the amount of interaction with other shaders. So that is me talking about different buffers. I think I say so when. Anyway, so that's the idea. Yeah, Java Spider. Do you know anything about pre-rendered backgrounds? No. You're talking about like Final Fantasy 7 type stuff? Mm-mm. Yeah, so all I'm doing this for, by the way, guys, is just so I can get the memory barriers correct. I need to get the memory barriers correct, otherwise this is just a non-starter. I can have all the buffers and particle sets that I want. If I don't have the memory barriers for writing things from shader to shader, then it's a no-go. It doesn't matter. So yeah, this is why I'm taking my time as well. I'm not like immediately trying to write this out. I'm trying to get more educated. I know no battle plan ever meets, what is it called? There's that saying, no battle plan ever survives the enemy. So no matter how well I plan, I'm gonna have to fix stuff that goes not the way I expect. But I can at least be more informed. Anyway, one way of purely writing, I believe we purely reading from. Okay, we are trying to we are trying in our compute shader. So our goal anyway, our short-term goal anyway. Yeah, that's it. Is, I know it's a dead simple one, but to do a GPU-driven rendered particle, right? We're going to render one particle, and then we're going to see if we can do something with that particle in the compute shader. So initially, our compute shader is going to have one particle in it. That's why I've set this to 6, for example, and one instance of that. And then it's like, all right, we can build it up from there, right? We can figure stuff out as we go. The first goal is to, you know, if I want to do anything like this or whatever, the first thing I need to do is like render one particle and get it to maybe move in the compute shader, so I know that I've passed over the data properly. I don't know. I don't know yet. So, but for now, it's just can I get a GPU-driven rendered something happening? Hence the long-winded approach to what we're doing. Right, let's take some water. Which, ironically, after I assume a lot of work, if everything works correctly, we'll just be in exactly the same situation with this. This will just be here as it is now, but with now a GPU-driven rendered approach, which is probably going to add a bunch of overhead for one particle, but now we have now it's in a compute shader, which is peak. The only downside is I don't know how to do this for bullets, right? Oh no, they're competing with me on the map though. So yeah, not sure. Intense music started as my engine got copyrighted. It's not overhead. It sounds, if it sounds cool. Yeah, I like that. But yeah, you know, in theory, we then should be able to do millions of particles, right? Which would be, you know, massive. It's still not, we're still not out the woodworks yet with 1 million particles, because how useful is that? You know, if I wanted to render a nebula, for example, you know, I'd need like a big cloud of stuff. It's gonna be a tough. But outside of this, outside the particles, I think I still need to move to GPU-driven rendering at some point anyway. And this just seems like a good point to do it. Anyways, right, so many things said, not much done, right? But I hope that explains it, because I know not everyone was here. How many hours ago? 8 hours ago. Anyway, we are trying to compute our... the compute shader and the C++ code are tied together with that's it, 6, 7. Since this will match the... Be careful. When you are trying to this code for another compute shader. I should say so be careful, I think. Less to read. So be careful. Okay. So this is also why I'm not even doing an indirect indexed indirect draw call. So this works as far as I'm aware, but the bindings might not be right. So I've got to check the bindings here. So right is the command buffer data, command buffer. We need to push constants, otherwise we haven't... The weird thing is, I don't really understand how we can have access to this. Like, just straight off rip. Surely... no, wrong. This shouldn't work. Like, it shouldn't know what this is, right? I don't know. I don't understand how this is not complaining. Anyway, without a push constants dereference of a pointer. Oh, one moment. Either way, first index should be an int though. Really? Are you sure? I kind of stole this from the... I don't think so. Give me a minute. If... Actually, I can just look this up. This needs to match VK... Whoops. That's my Windows noise. VK... draw indirect. And we need... Not that. Oh, I got the wrong thing. Give me a minute. This, but not the draw one. I got the wrong thing. That's what I'm after. Yeah, no, they're all unsigned. It needs to match the same. Hello, Alex Coates. How you doing, dude? That's what I'm trying to match. This exactly. We're just writing notes and studying all day. Okay, cool. Right, we got this. Right, again, this is not relevant here. So, this example here is... Yeah, vertex offset. Yeah, it's different. That's the tricky part. I'm doing like a really strange... I'm doing a draw indirect draw call, right? Not a draw indexed indirect draw call. Just fills up a command buffer and does nothing. In the commented... Oh, that was the thing. I was trying to get the... Obviously, we don't want to have the bindings the same. So we have... Oh, I'm an idiot. We're not using buffer device addresses. That's how you do a buffer device address. Okay, let's look at Obsidian a bit more. If we're doing this, that would be a regular descriptor. Yeah, 7 hours indeed. I'm going to keep going. How is draw ID different from draw underscore? It isn't, but you have to do this differently if you're using task and mesh shaders. GL draw ID, GL underscore draw ID isn't defined in a mesh shaders if you've generated your mesh shaders from a task shader instance. So that's why you would separate them out, right? So if you've got both, it just adds a little extra complexity for safeguarding against that in the future. So, do I want to do a buffer device address instead? This is a shader storage buffer object, and how do I want to access this fella? Yeah, that's a really annoying bug. Is what a bug. Oh, yeah, you're looking at that. That's a good point, actually. If I'm never going to use a mesh shader, should I just use a GL draw? It's probably better. Yeah, if you're not using... I'm just going to add a note, though. If you're not using a mesh/task shader approach to this, you don't need to store the draw ID. Yeah, it's good to know if you've never learned that. Yeah, because we can't just do a draw ID. You're right there. And it is important that we reduce the amount of size per particle. I don't think I could argue keeping that in if we're not using this in a task shader/mesh shader approach. Yeah. Angelica is a cutie. Yes, #1. Yo. You get that basically for a few different things. If you've liked the live stream, commented a lot, you get it. If you've watched it for a long time, you get it as well. All right, so eventually going to do stuff. Hello, Mr. Robot. Yes, hi, joining the first stream. Just a gamer has said, thank you for joining us, by the way. Not gonna lie, particles even in Unity and Unreal is very heavy on performance, if not right, batch calling, pooling, all the headache overhead needs to be done for handling a lot of particles. Yeah. Yeah, it's a headache, I think, for everyone right now. Okay, so we now need to transition this back out. Next step. Oh, yeah, okay, so how do I want to do this? If I do a buffer device address again, we're going to like... Yeah, so what I'm going to do, I think I'm going to resize my push constants as well. So we don't run out of buffer device address spaces. Oh no, I don't need to do that. No, I don't need to do that. What am I doing? What am I talking about? So let's rob these. I'm going to make my life simpler. Because he's using something I don't want to use. Which is push... What is it called? I've forgotten. It's push descriptors. There we go. So what we're going to do here is we're going to throw in... It's kind of a bit overkill, I guess, but... We can have other things in here. Hello, fix the billboards. Yes, I have. I'll show you if you want. So there we go. Ta-da! Billboard. Woohoo! It's clipping with the duck at the moment, but yeah. It's only a true billboard. It's only truly looking at the center of the camera when it's in the viewport. We are doing the simpler approach. Transition the memory. Transition the memory. Sorry, transition the buffer. We have written to be readable by a draw call. If you don't like the stream, you are an... I don't know what OPP means. Object-oriented programmer. Oh, I didn't even close that. Right, next is to rob. Oh, op means opponent. Got you. Thank you. Yeah, thank you. I guess my ops are object-oriented programmers. So it's kind of half right. Right, so we just need to transition this back out to readable memory. So let's take this, which is just going to be a repeat of before again. But this time, I am going to try... Whoops. Just going to comment out. I'm just going to delete a bunch of stuff so I can easily read this and then obviously not use my version, which is not like this. And remove these. And remove this. Okay. I watched your video on how to become an expert at programming, and it literally answered a lot of important questions relating on a handicapping myself in programming. It was extremely, I'm extremely thankful for that. Thank you. I appreciate that lovely compliment. Yeah, just keep it on. That's all it takes, bro. It just takes. At the end of the day, I can even distill it down even further. If you just put in the work, you'll get good. which a lot of people don't want to do. Oh, mosquitoes near me. Ugh, go away. I love the stream. I like to stop by every now and then to see what's going on. I could never make a full Vulkan FrameX / engine tool. Well, yeah. Thank you for stopping by as well. It's always nice to have a nice community like this. It makes streaming a lot more fun. So yeah, I very much appreciate you guys. Alright, so we can take this and throw this in here. Go like this. Get rid of that. Dependency info we'll put at the bottom, because that's what that code is doing. The rest is null, so we just have count of, which is fine. And we are transitioning our... we're waiting on this. Yeah, I just... my goal in life is to try and make... Well, one of my goals in life at least. Is to, provide value for you guys. So I'm always grateful to hear that I'm here providing value. Vertex shader bit. This comes here. I'm getting attacked by a fly. Oh my goodness, it's not good. Maybe I just stink, who knows. Alright. I thought it was a mosquito, but it's definitely not. Access. Okay, so we have read. After getting distracted by a fly. Let's make sure we got this right. Because this is likely the most important part. So we have indirect. So the indirect... Oh, hang on. What? Destination. Where's the destination? Oh, dear. Hey, do you watch football? No, I've never really got into it. I feel like it's one of these things where your family kind of brings you up to like it, but I've never got into it. Okay, so destination mask. Yeah, okay, so we missed that completely. And that should be the last thing, which is this. And this should be... Okay, so I'm going to delete these a bit as we go now. So, or vertex... Okay, so BK pipeline stage... vertex... Oops. Yep, that's right. Vertex shader bit. Lol. Yeah, programmers are allergic to sport. I do go to the gym, but I'm not very strong at all. Okay, so that's the same, and then we got this the same. Right. No, that's wrong. It's a comma. Okay, cool. Get rid of that. And part 2. It is actually going to be a full engine. I thought it's only going to work in your game. What's your bench now? My benchmark, like how many frames per second it is? It's not going to be full engine, no. It's just going to be... so that's the indirect buffer. Now let's how do I do this? No, I can list them in a thing. That's fine. Oh my, I'm an idiot. Right, I must be, my brain must be starting to fail me. My bench is pathetic. Honestly, it's what was it? I think it's 80 kilograms. It's not very good. Yeah, sorry. Duh. That's of course what I meant. Okay, next is this. Count. And then we can throw this in here. I've injured my back, so I can't really bench like I used to. It's kind of doing me in. So I'm just gonna say barriers, because I don't really know what to call it. And it's gonna call this 2. Oh, wrong thing. We can get rid of this, make our life easier. And then we transition. Ah, thank you. Any amount is pretty good as long as you keep improving. Yeah, that's true. Game or not, you still have all this Vulkan BS. Well, I do half of that. So, oh no, you mentioned, yeah, okay, there, 80. I do calisthenics, so though. Ah, yeah, that can get you really strong. So yeah, I did calisthenics for a long time. It's just relative to your body weight, isn't it? Oh, dude. Right, we're almost there. Nice. Yeah, keep going, tab. I think you're going to shoot past me. Like I said, I've injured my back, so it's an old injury from many eons ago. Funny enough, doing calisthenics. I won't go into that story again, but yeah, basically, well, I can sum it up real quick. I hurt my back because I was trying to do a handstand press up. Yes. Don't do handstand press ups, and to failure. That's all I can say. Indirect buffer. That's it. Mr. the Robot. That's just super solid. That's what humans have done for millennium. So, you know, despite everyone you now going to the gym, it's equally as valid. So this is that, and this is this. Sorry, I'm just trying to kill this mosquito. I don't know why all the bugs are starting to attack me all of a sudden. Right, okay, so stuff you can do without equipment, indeed. Okay, so we transition them out into things, and then I at least want to get this written down, so we're almost done, almost done, almost done. Then we do a render bloody pass, which I'm just going to use a giga render pass at the moment. And then we can do an index draw call. Oh, this is almost done, almost done, almost done. Okay, so I'm actually going to take my code, kind of meld this together. Where's my code gone? All you need is gravity, and yeah. Pull-ups are good for back, indeed. Especially weighted ones. Oh, I see you're saying all you see is gravity. Anyway, render. Render. Where is my cheap 2D renderer? It's in here. We're going to go in here. Going to steal all this stuff. But instead of doing a regular index draw call, sorry, not an index draw call, a regular draw call, I guess, without any index, without an index, we can, right, I'm just gonna not use that. We can go in here and be inspired by this and kind of use our lovely final boss index draw call. I keep saying it, indirect draw call. Okay, command buffer. Then we take. I'm gonna have to get these buffers again once more. One more time. So then we can go in here. VK buffer. And then we can go in here. And we do size of this. I'm not going to do offset off really, because we don't need to, because we've simplified ourselves down. Right, this indirect VK buffer. And finally the draw size, which is we did earlier on 100k. So hypothetically, we're going to set this to 1 when we're trying to do this for the first time. And apparently that is the same size, which I don't quite understand. But anyway, that should be it. Yeah, I agree with you. The pull-ups there. It took me forever to learn a pull. It took me like 3 months to be able to do one pull-up. Are you from Britain, actually? Like, what part are you in? Northwest. So around there. But yes, I am British. So British English. Okay, so what would we need to do in the vertex shader though? We aren't actually done yet. So I'm just going to get that in. So when we're in the vertex shader, we take in the draw commands. British French. No. As my dad would say, I'm as English as a cricket bat. Although that feels more Indian nowadays, because that's more of an Indian thing. Cricket. Anyway, first pull up took me 6 months. Calisthenic journey hours. Oh, nice, dude. That's sick. You can do 10 now. My accent is awesome. Thank you. Indeed, you have the aura. You don't pull yourself up. You push the bar down. That's the aura there. What's the most English thing? Beans on toast? Racism, perhaps? No, I don't know. Probably, I feel like, yeah, cup of tea with an English breakfast, probably. Yeah, yeah, cup of tea, English breakfast. Yeah, having a full brekkie. Okay, so we have mesh draws here. I've got to figure out how to get out this data, which I don't quite know. Well, you know us, Brits. Even if French, maybe I should start with this joke. But anyway, even if the French use it, you know, we invented it first, so we like to say we invented everything, including racism. To be careful I don't get banned from YouTube for these jokes. Girly tea party with plain biscuits. Yeah, rich cheese are very common for
Cucumber sandwiches.
yeah, cucumber sandwiches, stuff like that. Oh my goodness, I've got to concentrate on this now. Let's get this locked in. Uniform. I have to admit my brain is it's falling through my nose. Yeah, but yeah. Yeah, just within reason, you know. Offensive jokes for just for the sake of it on, you know, I don't know. They're just not funny sometimes, you know. Like I used to, like I had this guy in like when I was like a teenager just say the same jokes over and over again, and he was like, I love offensive jokes. And he'd say stuff like, you know what joke I like? Women's rights. It's like, yeah, bro, but ha ha ha. It's just not funny though. It's not like I'm offended by it. It's just like boring. Right. Yeah, I like dark humor, and they like tell the most boring jokes you've ever heard in your life. Yeah, it just got annoying more than anything. We can switch to Fluxer for more offensive jokes. I don't know that guy. I'm sure he has the jokes. Oh, I've got a stretch flipper deck. Oh, I'm not gonna lie. Oh, I'm getting tired. All right, so let's pick a track. Let's pause the timer for a moment. Let's pick a tune. Perk myself back up. What have we got? So we've got nothing here. These are so YouTube would only let me see 200 at a time. You're probably familiar with that. All right. What do we need? I'm kind of vibing with the newest stuff I've added to the list recently. Oops. Let's see. Yeah, we'll go through these. This is killer. Low key peak music playlist. Yeah, I just had to find a playlist that wasn't going to be copyright stricken. So I just put on my like favorite Crash Team Racing's peak music. Nowadays, Mr. the Robot had said, Gen Alpha are 6-7 Italian brain rot memes, I see. Yeah, long stream today, indeed. So far, I've embedded 6-7 cinema emotional damage names. That's funny. In my game, that's great. Yeah, so we're just gonna like run through these tracks. This song is like my favorite though. I had to be careful though, because some game tracks like Disco Elysium soundtracks and like some other like indie game music is completely utterly oblivious. You can't listen to it on YouTube like we're doing right now. It is quite peculiar. Like all the music in Disco Elysium is copyright claimed stuff. Oh yeah, it's a good game. I listened to it one stream and my whole stream got immediately copyright claimed. I was like, never mind. Yeah, it's great. It's great stuff. Right. Okay. So let's start our timer again to measure our programming, and let's try and, for the love of God, get this done. So we have the. Yeah, I don't quite know how mesh draw sweet. Yeah, so what we can do here is this. For draws, what's mesh draw? I don't even know what mesh draw is. It's kind of tricky. So trying to figure out how to do this properly is kind of tricky because I don't know what all these are. I hope this is just the materials and stuff, which would be nice. Because then we can why is the Ask Copilot at the top? Instead of go to location, right? Mesh draw, position, orientation. Okay, so I'm just going to throw that in there so I know what we're looking at the very least. So we have mesh draw commands. Do we even use this outside of that? Yeah, I'm just looking through. What is the difference between Visual Studio and Visual Studio Code? Visual Studio's is heavier weight. It has like profilers built into it. It has like more intense debugging, and it's generally more used by C++ developers because it's just got more stuff that you can, I guess, kick yourself over when you broke. Alright, so we need to go into... What am I doing? Oh yeah, my shader. Yeah, I can definitely tell on my brain's struggling. So I also need to make sure that these kind of like gel together. So then we can... Yeah, effectively I've like written a program at the same time I've taken notes today. So yeah, that's what I needed. I don't think I'm going to do the whole shader. But the instance count is for the texture coordinates, and then the index count is that. Yeah, both of them are very bloated, to be fair. I'm not going to lie. I really like how you take notes. I like making notes too. I prefer handwriting them, but handwritten notes are hard to maintain and share. Yeah, that's a... Yeah, I don't really get the benefit of Visual Studio's code unless you're on Linux. I'd rather just have a full integrated IDE. But, you know, each to their own. I used code blocks originally. There you go. Mika's on it, basically. My problem is if I have a draw call and then I get the draw data route, which will be the... If I look at this again. I don't know how this is going to work, to be honest. Outside of, like, drawing. Ah, right, it's going to get this stuff out. Alright, so for our use case, we're going to... I think I'm going to have to work out how instance rendering works per draw call. Because if I look at... I have a sneaking suspicion that this has a draw call count and he's not using it. Sorry, an instance count. Oh, this is tricky. I don't know how the instance rendering works with this at all. I've been learning a little bit of NeoVim, by the way. I'm not completely against using NeoVim. But at the end of the day, this has everything kind of just here. I've been using it for years. Should you switch to Visual Studio? Depends on what. It doesn't really matter. I feel like people kind of like someone said something in the video about, you know, programming expert in the YouTube comments, which made me laugh. He said, "I know this guy's a fraud because he doesn't use NeoVim." Like, it really doesn't matter. Like, it's you use what you want. At the end of the day, if using Notepad to type up all your code is fine, then that's fine. It doesn't matter. Like, I know you get less vibe, you get less cool points on the internet if you're not using NeoVim, but for some reason that's the cool text editor, but they're all just text editors at the end of the day. Alright, so what am I trying to do here? So whatever's comfortable. I say Visual Studios if you're brand new, but that's because it like nicely integrates with CMake, and I like to use CMake for stuff. Yeah, I feel like I need to do instant rendering here. I don't know how this works though. Let me just look into this a little bit. So the instance rendering is filled up in a buffer, but I don't know how to use it. Is there like an instance version of this? I don't. Okay, so I'm going to say like, how does indirect draw calls happen? Indirect draw calls instanced. I'm a normie. I use Emacs. Yo, do you actually use Emacs? That's kind of sick. Like, I feel like that's like the underrated. Yeah, but how do I do instance based? Is there an instance here? That's my Windows noise. Like, so yeah, so we build this up, but like, what do we do with it? Can you change compilers when you use Visual Studio, or you're stuck with MSVC? I think Ratchet uses Visual Studios and uses Clang, so yes, you can. For some reason though, it deleted his Clang compiler for no reason. See you, man. See you, Mr. Oba. Thank you for joining us. Emacs was made it slow and still slow. Yeah, so just use whatever's best for you. I use code blocks. I use Visual Studios. I use NeoVim on Linux. It is what it is. Just because I would like to have like both GDB and NeoVim kind of working together, so I can have like stuff going on. Oh, there you go. There, CL's XE has a Clang backend. I like that. That's funny. All right. I literally don't know. I need to. How do I look this up? Instanced. I don't know what to look up, to be honest. Because indirect draws, we get a draw call, right? We put it on the GPU. And then we instanced over that. Like, what's the point of writing the data into the GPU if we're going to use the instance count? Yeah, I think it's fine. I think that's how. I think I'm overcomplicating in my brain. I think at the very least, as far as I'm aware, theoretically, we literally don't change anything. We keep it all the same. The only time we have to do this is if we have the draw. We're doing it things by draw ID. But if we've generated the draw calls on the GPU and then we use the draw call buffer, then the draw calls will be generated on the GPU. So that means that if we have more than one instance, we will have access to instance index in exactly the same way. Meaning that everything's fine. Everything's chill beans. We can now use this fella with an extension, I believe. But yeah, everything's chill. So now when you run the indirect thingamajiggy, this thing, you will get in all the indirect draw, sorry, the regular. So in this case, it'll be 1 per draw call. That would be the number of draw calls, which would be extremely excessive. All the regular stuff that you would get with a regular draw call, including, yeah, okay, so this is all just, yeah, all clicked in my brain. That's really good as well, because I was super confused how I'd do this. I just have to remember that it's just indirect now. It's the same deal. It's just indirect. Nothing else changes. So if you have, like, say 10,000 draw calls per and 10,000 instances, you have X objects in the scene. If you need to access the draw calls in the shader, you do what is it called? Fantastic, yes. So this is going to be like massive overhead, but also we can do that now, which is the whole point of this. We can have 100,000 draw calls with 100,000 instance, with 100,000 instances, right? Which is like the whole point of this indirect draw. Okay, so that's like really good. I feel like I figured out like basically everything I need to in this stream, which is nice. And now we can start writing it. Now, yes, we have written it, so you know, So I actually don't need this at all because this is just the same dealio. Yeah, everything just makes sense. Just make sure you bind the graphics pipeline that correctly corresponds to the compute set up for indirect draw calls. Super cool. Right, okay. There we go. There we go. That was a bit of an odyssey, I have to admit. So I think I've written enough notes now and understood enough. Mostly written code. So we did do development here. This was all development work that we did. Which I will be like copying into the engine, I think. Probably not. I'll probably do it one draw call, so we have the same thing. And then increasing the instances, but only doing the indirect draw calls when we exceed a particular level. So let's just say that instance count reaches 70. Like, I don't know, 20,000, right? And then I would like generate another draw call, right? And then these get automatically generated on the CPU. Everything's on the CPU. We can do the compute stuff for the actual particle in the filling up of the command buffer here. So they actually don't know how to do this yet, but yes, this hopefully all works out in the sense that we can actually do the particle logic here when we are generating the draw calls for our particles. We can instance render them. It's all fine. It's all chill. In exactly the same way. We just need to pull out that buffer once it has been written to, and we have been very careful making sure that we are doing this with all our pipeline stages and access things. So hopefully, fingers crossed, assuming that we all use the same command buffer and put it in the main queue, all this should just kind of work. Obviously, that's not going to happen, but, you know, that's a step in the right direction, right? Okay, I'm going to share my Discord server with everyone who may be watching. If you're not already joined, here is an invite link for you. Note any VOD watchers, that is a 7-day link. So if you're watching in the future. Yeah, I just want to say this is the end of the stream. And also thank you for all of you. Thank you for all of your lovely comments and keeping me company over these long hours. I have had fun. I hope you've enjoyed yourselves. Anyway, yeah, thank you for all the likes and chats. And anyone who's newly subscribed, I hope you enjoy your time here. And thank you for all staying subscribed too. Yeah, alright. I am going to end it here, guys. I hope you all have a fantastic rest of the day, whatever you end up doing. So yeah, alright, bye guys. Bye.